Hi everyone and welcome back to PrepFusion. I know many students were waiting for the signals R-PYQ. So today we will discuss most of the important questions from GATE, EC and EE for all the topics. So we will start off with basics of signals, then we'll start with basics of systems, then we'll go to our continuous time Fourier series, continuous time Fourier transform, Laplace transform, Z transform. Uh, then we will also study about sampling and analog filters, like digital filters and analog filters. Okay. Now, in between, I have covered some concepts. I have explained. It is not like the previous RPYQs where I was explaining all the concepts and then I was getting into the questions, because signal is a very vast chapter. It will require me more time to do the complete revision. So I am expecting that you will be revising on your own and coming back to this video and watching me solve it. Before solving it, you must solve it on your own and then see my solution. And I have tried my level best to reduce formulas to minimum. Okay, signals has a lot of formulas. I tried to derive everything from scratch and then solve all the questions. Okay, that was my attempt, so that you will have the same approach in the actual examination hall, because I do understand my memory is very weak, and I know most of the students memory also will be very weak, because there will be so many formulas to remember. I do agree. So I have tried to derive most of the things. Once you will watch the solutions, you will realize I have, of course I will use formulas, but I have tried to minimize the remembering part as much as possible, mugging up part as much as possible, right? So my expectation would be, I am not covering the discrete part. Okay, so this DTFS, DTFT, I will take few questions of DTFS, DTFT which came in electrical, which came in EC. I will take few questions, but not all of them, right? So make sure you at least cover these. If you want to cover the discrete part, make sure you watch these videos. No question will come out of these videos. Okay, every or whatever questions will be asked, they will come in this. Recently in BEL examination as well, one very weird question came. No one was able to solve it, but that also came from these videos which Himanshu sir has taught. So if you want to study the discrete part, make sure you watch these 4 videos. Of course, this is the linking concept which links all the transforms, and you watch this video and your discrete part will be done. And the continuous part you already know, because most of the students study the continuous part very well. Just need to revise a bit. You can revise through this revision X notes. So we have this revision X notes. Please keep in mind, this were created till chapter 2, that is till systems, basis of systems. I did not get the time to create for continuous time Fourier series, continuous time Fourier transform, Laplace transform, Z transform. If I get the time, I will update it. You make sure you just go into our website or just search revision X notes. You will get the complete idea. If you want to revise the continuous part or the discrete, like anything, you can revise it through the revision X notes, or if you have your own notes, you can revise that. These are our short notes. Okay, so make sure you do these things, and then only you come back and watch this. So if you enjoy this, trust me, you will enjoy this, right? Please watch it thoroughly. I'm giving my full effort here, and trust me, you will enjoy this, because I will use as little as formula, like as little formula as possible. That is my target, and I have done that. So you will enjoy this video. Make sure you watch every bit of it. Like, you will revise a lot of stuff here, lot of, almost I have tried to cover all the concepts. Okay, so yeah, if you are enjoying this, please hit the like button, comment down below. That helps us to reach to more people. And yeah, I will meet you with basics of signals. So let's begin with the first question. The waveform of a periodic signal xt is shown. The a signal gt is defined such that gt is equals to this. The average power of gt would be. So basically they are asking me what is the power of gt. Now we certainly know, if there is any scaling or any shifting, time shifting in time domain, right? It will not change anything to the power. Power will be same. Power will be same. Okay. So yeah, power is same. Now, uh, ultimately, right? If power is same, so whatever is the power of xt, I will have same power of gt, right? So ultimately I will have to find out the power of xt. How do I calculate the power of xt? It's a periodic signal, so the average power formula is energy of xt upon capital T. That is the power formula, right? Capital T is the time period. I can easily observe time period is, if I start from -1, I will end at 2, so it is 3. Time period is 3. I will just have to calculate the energy. What is the energy? So what is the energy of this half triangle? If I have a whole triangle, right, if its half width is 1, its energy is 2a square by tau. That is its half width, right? So if I have a half triangle, its energy would be a square by tau. So 2a square by tau and divide by 3 is also there. Okay, these are very basic formulas for energy of a triangle. So I hope you remember these things. So it will be a square by sorry, what am I saying? Okay, let me explain. So if I have a triangle like this, right, and its half width is tau, its energy would be a square into tau, 2a square into tau divided by 3. That is the energy of a complete triangle. If I have half triangle, its energy would be a square tau by 3. As you can see, I have only half a triangle, so its energy would be a square tau by 3. So tau is what? Tau is 1. Tau is 1, and okay, tau is 1. So this will be a square. A square, what is the A? A is the amplitude, highest value, that is 3. So 3 square into 1 divided by 3, that is the energy of this particular triangle. What is the energy of this particular triangle? It is also same, right? 3 square minus 3 square into 1 divided by 3. So 3 square into 1 divided by 3. Sorry. And of course, the energy of the remaining portion from 1 to 2, it is 0, because the signal value itself is 0. So this shall be equals to 2 into 3 square upon 3, or simply 2. Okay, so your power would be 2. Very simple, very straightforward question. I don't think you have to think much on this question. Let's move on to this one. The impulse response of an LTI system can be obtained by differentiating the unit ramp response. So impulse response of LTI system, no, not differentiating the unit ramp, it is differentiating the unit step response. So it is certainly differentiating the unit step response. That is how we get the impulse response. And if I want to integrate, no, I will not be able to get impulse response by integrating any of these signals. By integrating step response, I can get ramp response. That's it. Okay, very simple, very easy to understand. I don't think there is much debate in this particular question. Let's move on to the next one. Two sequences x1 and of 2 and x2 x1 of n and x2 of n have the same energy. Suppose x1 of n is this, where alpha is positive real number and un is unit step sequence, and x2 of n is this, uh, then value of alpha would be, so they have the same energy. So what is the energy in the first case? How do I calculate energy for a discrete time sequence? So energy of x2 of n would be the magnitude of x2 of n, adding up all the magnitudes of x2 of n starting from 0, 1, 2 and so on, right, going towards infinity. So n basically will start from minus infinity to plus infinity throughout, right? That is what the energy of a discrete time sequence is. In this case, the x2 of n exists only for n equals to 0 and 1, otherwise it is always 0. So this will be equals to this whole square plus this whole square, so it is 1.5 plus 1.5, that is equals to 3, right? So your x2 of n is equals to energy of x2 of n is equals to 3. Okay, yeah, energy of x2 of n is 3. Now we got the energy of x2 of n. Now let us calculate the energy of x1 of n. So x1 of n, they have told, so u of n is the unit step sequence, so it only exists for positive values of n, right? So energy of x1 of n, this shall be equals to so it will be basically n equals to 1, so n equals to 0. Unit step sequence exists for n equals to 0, n equals to 1, n equals to 2, and towards positive infinity. It does not exist less than n equals to 0. So yeah, when n is equals to 0, what is x1 of n? It is alpha. So what is x1 of n whole square? It is alpha square, right? When n equals to 1, it is 0.5 into alpha, so basically it will be 0.5 alpha whole square, right? Then plus this will be 0.5 square alpha whole square, and this will go on. Basically this will be 0.5 for n equals to 3, this will be 0.5 raised to the power 3 whole square, right? And I will add all these numbers up. So do you see something common? If I take alpha square common, right, you can take alpha square common. If I take alpha square common, ultimately your summation will be alpha square, just give me alpha square 1 plus 0.5 whole square plus 0.5 raised to the power of 4 plus 0.5 raised to the power of 6, and so on, right? So what do I see? There is a what? There is a common ratio, common factor of 0.5 whole square. So it is a geometric progression series, GP series. So the summation of a GP series shall be, so alpha square is there at the outside, it is first term of an infinite GP series, that is first term divided by 1 minus r, a divided by 1 minus r. 1 minus r is 0.5 whole square. So this shall be equals to alpha square, and this is 0.75, that is 3 by 4. So 4 alpha square by 3. Okay, 4 alpha square by 3. This is the energy of the first signal, and this shall be equals to this value, right? So this shall be equals to 3, the energy of the second signal. So from here I get the value of alpha. Now alpha, they have told me that alpha is a positive number, okay, but alpha is a positive real number. So alpha square will have two solutions, one will be negative and positive. Of course I will choose the positive number because alpha is given to me, that is a positive number. So this will be equals to 3 by 4. Okay, so alpha is equals to 3 by 4, right? So no, not 3 by 4, sorry, alpha is equals to 3 by 2, because I will take the under root, it will be 3 by 2. So this is equals to 1.5. So your answer is equals to 1.5. This is your answer for the question. Not super simple, but not super difficult as well. Let's now solve this question. So consider the signal f of t 1 plus 2 cos pi t plus 3 sin this 4 cos this, where t is in seconds. Its fundamental time period in seconds is, what is its fundamental time period? So the interesting thing about this is basically, I see that are all the, so let me first write the frequencies of each term. So this is an DC term. So DC term can take any frequency. It can take 0, infinity, anything. So DC term, the frequency, it does not matter. If you add DC with any periodic term, right, the frequency becomes, overall frequency of the whole signal becomes of whatever the frequency was of this term. It does not depend on DC. So DC, I don't need to think about DC. You add anything, you like with any signal you add DC, it does not change the period. Period remains same. So I don't care about DC term. All I care about is the AC part. So for this first part, what is the omega naught? For this omega naught is pi. What is omega naught here? It is 2 pi by 3. What is omega naught here? It is pi by 2. Okay. So these are my omega naught. Now, yeah, we got our omega naught values. Now I can see that if I take the ratio of the first uh, frequency to the second frequency, or the third and second, any combination, I see the ratio always comes out to be rational. So the ratio are always rational. So certainly I will get a periodic signal, and certainly if they have asked NAT type question, if they are asking fundamental time period, then certainly they will have to be rational, like the division, right? This term and this term have to be rational, otherwise question will be empty. So certainly they will be rational. Now what is the frequency of the overall signal? That is basically HCF of frequencies of each term. So first one pi, then 2 pi by 3, and then pi by 2. Now whenever we are taking HCF, right, and if there is some ratio, so we can convert it like this. So HCF of the numerator, that is pi, 2 pi, pi, and divide by the LCM of the denominator. So this is pi by 1, pi by 1. So this will be 1, this will be 3, this will be 2. Oh, that's how we convert. And this, I think you studying in signals, so I will not explain every single thing here. So what is HCF? HCF is the highest common factor. Highest common factor, right? What is the highest common factor that I can take? It is pi. It is pi. From the numerator, it is pi. So that is equals to pi. What is the lowest common multiple? Right? That all of it, if I choose, all three will be like multiple of that. That is 6, right? In this case, it is 6, because 6 has a multiple of 3, 6 has a multiple of 2 as well, and 6 of course has a multiple of 1 as well. If I choose 3, 3 is not multiple of 2, right? So that's a problem. So this will be 6. Okay. So my omega naught of the overall signal is pi by 6, but they have asked what is the fundamental time period. So fundamental time period would be basically T naught would be 2 pi upon omega naught, that is pi by 6. So this would be 12 seconds. So 12 seconds would be your answer for the question. Let's solve the next question. This is the next question. The radian frequency values for which the discrete time sinusoidal signals S1 has a period of 40 is slash r. So I hope you have studied the concept of uh, period frequency for discrete time signals, and we know for discrete time signals I can have multiple frequencies, because whenever you do uh, your omega n and omega n plus pi, sorry, omega n plus capital N, things change, and I think there is a derivation. What is the derivation? Derivation is that your discrete frequency, also known as cyclic frequency, divided by 2 pi, right, must be rational. Okay, basically it must be a ratio. So okay, let me write it like this. So this is my discrete frequency, right, omega. Okay, so 2 pi by omega will give me what? Will give me period, that is n, capital N, correct? But it is not just capital N, it should be capital N by m. What is m? M is just any integer. M is just any integer. So I can have multiple frequencies, not only single frequencies. When m is equals to 1, it is equals to n. That is correct. But m can be anything, because this ratio must be rational. This ratio must be rational. Cool. So from this equation I can get my omega to be 2 pi m. Okay, 2 pi m. So it is 2 pi m. Yeah. m, so 2 pi m by n, correct? So if I see what is n, n is given to me, that is 40, n is 40, right? So this shall be equals to pi by 20 into m. Now we will have to just check for what values of m are any of these options matching. Okay, so if I say m equals to 1, this will be 0.05 pi, which is certainly not present, but I see 0.15 pi present. That is what? That comes when my capital M is equals to 3. So this is one of the correct answers. Okay, again I see the double of this, right? 0.3 pi, this also will be correct. When that will be correct? When my capital M equals to 6. And again this also will be correct when my capital M equals to what? It is equals to 9, right? So M equals to 369, all these options are matching, this will never match. Ultimately, if you find out one frequency, right, the others if you see will be just multiple. Basically, all frequencies must be multiple of 0.05 pi. Okay, not just this, because yeah, 0.05, yeah 0.05, yeah, all of them should be multiple of 0.05, which this certainly is not, right? So option A, C, D is my correct answer for this question. Let's move on to the next question. This is the next question, where XR and XA are respectively the RMS and the average values of xt, that is equals to xt minus capital T. Basically, it tells me that it is a periodic signal. And similarly, YR and YA are the RMS and average value of this. K and T are independent of time T. Which of the following is true? YA is equals to K into XA. Okay. So, if a signal is periodic, right? If a signal is periodic, then the average of YA will be, this K is just a constant, that will be just at the in front, and it will be average of XA. That is correct actually. Okay, this is definitely certainly true. This part is true. Okay, so YA will be K equals to XA. Automatically these two options are gone. Okay, these two options are gone. Average value of YA would be K into XA, that we know because this K is just a constant. Whenever I take the, so what do I mean by average value, right? So if xt is periodic with capital T, yt also will be periodic, because ultimately I am multiplying by a constant number, that will not change the periodicity. So what is the average? Ya average, that will be equals to integration from 0 to t, obviously divided by capital T of yt dt, right? What is yt dt? Yt is this value, k into xt 1 by t 0 to t k into xt into dt. Now k is just a constant that can come outside, that shall be equals to this 1 by t integration of 0 to t xt dt. Now this is nothing but the average value of phi. This is nothing but the average value of, sorry, average value of x, right? So that's why this particular formation, this particular statement is certainly true. Now what about this statement? What will happen to here? You will say here also, sir, this will be same only. Yes, you are, but for a certain condition. What is that condition? So how do I define the RMS value? So this is called as the average value of x. How do I define the RMS value of x? That will be equals to, RMS is what? Root mean square. So first I will square the signal, then I will take the mean of the signal 0 to t 1 by t, then I will take the root. Okay, obviously dt is there, right? So root mean square. So that is what my RMS value is, right, for x of t. Now let us define what is the RMS value of y of t. Everything will be same, root mean square. This would be equals to, now what is y of t? Y of t is k into x of t. Y of t is k into x of t. So let me replace k into x of t here in this particular equation. 1 by t integration 0 to t k square into x of t square dt, right? So simply again this k square is just constant, I can take this k square outside, so this will become k under root of this value, right? And which is nothing but k into x RMS, and you will say your answer is option A, and you will be wrong. Why? The moment I had done this step right here, some information was lost. What was that information? That information was regarding your k. Okay, so if your k, let's say, was 2 plus 2, then what would have happened here? It was plus 2 whole square, then plus 2 under root of 4, sorry, plus 4 under root of 4, basically that will be 2. So this is fine, there is no problem, k is k only. So k was 2 and outside also I am getting k. But if your k is minus 2, it can be anything, right? They have not mentioned. They have mentioned k and t are independent values. Nothing has been mentioned. K can be minus 2 as well. If k is minus 2, if k is negative, what will be minus 2 whole square? Again plus 4. What is under root of plus 4? That is 2. So here I am getting 2 and I am writing k. K is minus 2. So these are not matching. What went wrong? So whenever you square and then take the under root, that basically means you are taking the absolute value of that number. You are losing out information regarding the sign of the number. Whenever you square a number and then take the under root, you are losing out on the information regarding the sign. So your proper formula is this. It should be mod of k into x of r. So certainly your y-RMS will not be equals to k into x of r. Your y-RMS will be mod of k into x of r. Hence your option 2 will be correct in this question. Very beautiful question, very simple yet very conceptual. Let's solve the next question. This one. The period of the discrete time signal x of n is described by the following equation below. And it is a discrete time signal. Now they are asking me, you will basically have to calculate the fundamental period. Again, as discussed earlier, that your 2 pi upon omega must be equals to n by m. It must be a proper rational number. Okay, so we will have to define the rational number. So so certainly again this is DC, so it won't matter here, and these are all my omegas, individual omega of this particular frequency. So how do I calculate the rational? So here what you can do is you can calculate the period of the first signal, that is n1, and period of the second signal, and then simply take the LCM of those and you will get your answer. So if you want to compute in terms of period, you will have to take the LCM because period comes in the bottom. If you have to calculate in terms of frequency, you will take the HCF of both the frequencies. So this is the very basic thing, very basic concept that we study in signals. So what is N1? Period of the first signal. So yeah, here if I replace everything, right, 2 pi, and this is basically 15 pi by 8. So this will be 2 pi just give me a second. Is equals to n1 divided by m. So this comes out to be 16 divided by 15. So your n1 would be 16 simply. Okay, n1 would be 16. And what about your n2? So same equation if I use in n2, so 2 pi divided by pi by 3, that is equals to n2 divided by m. So again your n2 would come out to be 6. So all I am doing is, this must be rational. So what is the minimum value? So this is 16 by 15, right? So I can choose m to be 15. That's all. That is all I am doing. If this has to be rational, m has to be 15. Okay, and here m has to be 1. M can be 1 because this is already 6. This is a proper integer, right? So now n1 by n2 must also be rational, right? For the signal to be periodic, like you can do it like this as well. You can check here or you can check here. n1 by n2 must be rational. Are they rational? Yes, they are rational. So certainly my signal will be periodic. Anyways, it is a NAD type question, so certainly it will be periodic. So what I have to do, I have to simply calculate the LCM of n1 and n2. So it is the lowest common multiple between 16 and 6. So 32 is not a multiple. 48 is certainly yes a multiple, right? 48 is a multiple of both, so it will be 48. So your period will be 48. Okay, that is your period, that is 48. This is the answer for this particular question. Yeah, let's solve this question. The x of t and the output y of t are related, of a system are related as such. The system is non-linear. Now is it non-linear? For it to be non-linear, it must not follow the property of homogeneity or yeah, additivity, right? So I see, if I replace my x of t tau with k into x of tau, so this k is just a constant number that can come outside the integration and that will still be there. So your y of, so what happens if I am replacing my x with k into x? So your output also should be replaced by from y to k into y dot if the system is homogeneous. Is that happening over here? Certainly yes, because if I replace my x of tau to k into x of tau, what will happen? K can come outside the integration property and this will be automatically y of y dash of t would be equals to k into y of t. So certainly it is following linearity property. It is following linearity property, but sorry, not linearity, homogeneity. But what about the additivity, right? What do I mean by additivity? So if let's say x1 of t has a response of y1 of t and x2 of t has a response of y2 of t, then x1 of t, I'm just writing dot because t can be anything, it's just a dummy variable, x2 shall be equals to, sorry, the response to this shall be equals to the response of x1 dot plus y x2 dot shall be equals to y1 dot plus y2 dot. Okay, so that is what should happen. Now is it happening? Is it happening over here? Yeah, x1, I think yes it is happening because yeah, it is just a linear property. So yeah, it is happening over here. Okay, so what is happening is this y of y1 of t is equals to e raised to power minus t minus infinity to t e raised to power tau x of tau d tau. Okay, so yeah, y1 of t is equals to e raised to power minus tau t e raised to power tau x tau d tau. Now uh, sorry, this was for x1 of t, right? Similarly, if I replace my x to x2 of t, I will get the response x2 of t, sorry, y2 of t. Now if I give the input, so in what will be the response, let's say y dash of t, when the input is x1 of t plus x2 of t. So here this should be x1 of t plus x2 of t. So if I break the bracket, this will be essentially, right, integration property can be applied. So essentially e raised to power minus t into the first term, that is this term actually, right, then plus e raised to power minus t into the second term, that is y2 of t. So your response, right, actually is equals to y1 of t plus y2 of t. Okay, that is what your response is equals to. Got my point? Y1 of t plus y2 of t. So certainly it is linear. It is not non-linear. Okay, it is certainly linear. Whatever time invariant, it is certainly not time invariant, because certainly there is a function of time multiplied, right? Whenever there is a function of time multiplied by anything, right, x of tau or anything, so certainly it will be time variant. So it will be time variant certainly. So it is not time invariant, it is time variant. So if it is uh, time variant, then yeah, what can I say? Just hold on a second now. T minus tau, tau, tau. Okay, just give me a second. So it feels like if I have a multiplication of e raised to power minus t, right, it feels like it is time invariant. So it is time variant. So you will tick mark this one. But let us study this a bit more. Okay, let us study this a bit more. This question is actually pretty good. I just realized now. I just remembered something. So yeah, what do we mean by time invariance? So for if x of t, my response is y of t, correct? So my response for x of t plus t naught shall be y of t plus t naught. Okay, that is what should happen. Let's see. So my y of t is equals to this value, correct? Now let's replace our x of t with x of t plus t naught. So basically tau with x of tau plus t naught, right? If I replace my x of tau with tau plus t naught, so this will be e raised to power minus t only, if I'm not mistaken. Yeah, this will be e raised to power minus t only. This will be minus infinity. This will be t. All I am doing is changing the bracket term, correct? All I am doing is I am changing the bracket term. I am going from tau to tau plus t naught, correct? Yes. So tau plus t naught or tau minus t naught, it won't matter. So this will be e raised to power tau x of tau plus t naught d tau. So I'm just changing the input. I'm shifting the input by t naught units. What happens to the output? So again, let me convert this into proper formats. This will be, let me replace with some variable s, okay, or alpha. Alpha is equals to tau plus t naught, right? Then d alpha would be equals to d tau. D alpha is equals to d tau. So what will happen to the limits? So if your tau is going from minus infinity to capital T, right? So minus infinity, your alpha also will go from minus infinity to t plus t naught, right? Because if I replace tau with t, it becomes t plus t naught, right? And your tau is what? Tau is alpha minus t naught. Your tau is alpha minus t naught. Okay, so that is what your tau is equals to, right? So yeah, if I replace this over here, this will be e raised to power minus t integration from minus infinity to t plus okay, alpha will go from t plus t naught, right? T plus t naught to e raised to power tau is alpha minus t naught, alpha minus t naught into x of alpha into d alpha. I have replaced d tau with d alpha, right? So e raised to power alpha is obviously a variable, but e raised to power minus t naught is just a constant number. I can take it outside the integration. So what happens? This is equals to e raised to power minus t into e raised to power minus t naught integration of minus t plus t naught alpha x of alpha d alpha. Okay. Now remember, your alpha is just a dummy variable, right? Alpha is just a dummy variable. I can write here alpha, I can write tau, I can write t, I can write m, n, a, b, c, d, e, f, I, g, does not matter. This integration value will be same, does not matter, right? Alpha is just a dummy variable. So just to be more closer to our proper answer, I will properly write it. So this will be minus t plus t naught integration from minus infinity to t plus t naught e raised to power tau x of tau d tau, correct? Now here is the interesting part. What is this? This is if I replace in the y of t expression to from y of t to t plus t naught. So everywhere wherever I see t, replace it with t plus t naught. So this will be e raised to power minus t plus t naught, that is present here, and this will be integration upper limit will be t plus t naught. So what is happening? The thing that I told you, for a system to be time invariant, that this property must hold. If I am giving an input x of t plus t naught, that is what I am giving here, right? X of t plus t naught. The output, the response is actually y of t plus t naught. So certainly this system is certainly time invariant. So at first glance, yes, I also made the same mistake, but I have already solved this previously. I just remembered, yes, that it will not be time variant, it will be time invariant. Although in the starting uh, glance, it feels like it is time variant, but it is not. It is actually time invariant. So option B is correct, not option C. So this question was actually pretty good. Good question. Let's solve this question. Consider the discrete time signal system T1 and T2. These are discrete time. T1 of x of n, it is a system. T1 x of n is equals to x of 0 plus x of 1 plus x of n. T2 of x of n, right, are this. So basically it discusses the response. So response of the system T1 when input x of n is given is this, okay, and response of the system T2 when input is given like this, right? So if you replace your x of n with u of n, what will happen? If you replace your x of n with u of n, your T1 of x of n will not be absolutely integrable. Got my point? Right? If I replace this with u of n, okay, so that is the case. That is the case over here, right? So certainly your system T1 is unbounded or not absolutely summable. Okay, the proper answer should be it is not absolutely summable. So T1 is certainly not bibostable. So T1 not absolutely summable, right? Basically for for a like bounded input, right, that is u of n, I'm getting a unbounded output. So if you add all this, right, what will happen? Your this will keep on increasing, your t of response will keep on increasing, right? Okay, actually they should, okay, they are, this is actually the impulse response. They should have properly mentioned whether it is what this impulse response or what. They should have properly mentioned. But yeah, I think this is the impulse response, and if your impulse response is not absolutely summable, it will become unbounded. Okay, now yeah, now what can I say for T2? For T2, if you see, if I keep on increasing my n, right, keep on increasing my n, what happens? This value reduces. So the sum, right, summation, if you see, what will happen? It will be something like this. Okay, first I will have here, I will have here. The impulse response will be something like this. The amplitude of the impulse response is reducing as I am increasing the value of n for e of n. If you give your e of n equals to, sorry, if your x of n equals to u of n, you'll see this. If it is your x of n is equals to delta of n, it is something like this, right? So yeah, actually, yeah, this is, sorry, this is not the impulse response, this is simply the response of the system. So for any input, right, you see, because this 1 by 2 is to power n factor is there, your output is always getting bounded for n equals to infinity. So certainly it is a bounded output, right? For a bounded input, I am getting a bounded output. Then certainly this will be bibostable. Your T1 won't be bibostable. Why? Because, okay, I'm sorry, this is the response of the system, and if I'm giving a step input, then what is happening? The output is going unbounded. It is going to infinity. You see that you are adding 1 1 1 1 1. It is going to infinity. It is following n, right? So it is going to infinity. So T1 is not bibostable. T2 is certainly bibostable. So option D will be correct. Let's solve this question. If the energy of a continuous time signal x of t is E, the energy of the signal 2 into x of 2t minus 1 is C into E. What is C? So what happens? There is a property that energy of x of t is E. Energy of A into x of t would be A square into E. Okay, that is what it will be, A square into E. So it will be actually mod of A square into E. Energy of x into cap at, right, that will be equals to 1 by mod of A into energy of x of t, that is E. So that is, these are the few properties of energy. You can derive this, hardly will take 30 seconds. I will not derive, I'll directly use these properties. So energy of 2 into x of 2t, right? So 2 into means it will become 4, that is 2 square into E, and certainly inside the bracket of x I have 2t, so I will have to divide by mod of 2. So this will be equals to 2 into E. So your C is equals to 2. That's it. Okay, I don't think there is much explanation. The answer is C equals to 2. Let's solve the next question. I think we're almost, okay, we're still not almost done. No, I think we're almost done. Yeah, we're almost done. 2 questions are left. Uh, Consider a continuous time signal. X of t is this, where u of t is the continuous time step function. Let delta of t be continuous time unit impulse function. The value of what? Value of this would be what? Okay, simply they are asking me what is the value of this. Now, if you see this, right, your x of t exists from t equals to minus 4. So this is nothing but a rectangular pulse. This is nothing but a rectangular pulse. Minus 4 4 1, right? So uh, yeah. Now if I multiply this, t equals to this, uh, yeah. So actually this integration, right, I don't have to integrate throughout because for the rest of the period it is always 0. So I will have to integrate only from -4 to +4, and your x of t will be minus t square into delta of t plus 3, correct, dt. Now again delta of t, the graph of delta of t is basically it is 0 everywhere else except t equals to -3. At t equals to -3 this exists, otherwise this does not exist. So I see the t equals to -3 is within my limits, rest it is always 0, right. So basically the integration is something like this, it is -3 minus to -3 plus, otherwise it is always 0. So your integration has now been reduced to this value, minus sign can go outside, this will be t square delta of t plus 3 dt, okay. And you can actually so you can change the value of x of t. What happens actually if you are multiply, so let's say there is xt multiplication of delta of t, right. What happens, this function is nothing but x of 0 into delta of t, right. So whatever is the value here at t equals to -3 I will replace. So t equals to -3, so it will be -3 whole square, that is 9, correct. So this shall be equals to minus of 9, and integration from 3 plus or 3 minus, that is equals to 1, right. Delta of t integration is 1. So your answer is simply -9. So they have asked what is the integration of this particular function, that is -9. So -9 would be your answer for the question. Okay, let's solve this question. A continuous time periodic signal x of t is equals to this, right. The period of x of t, t capital T is the period of x of t, then 1 by t magnitude of this. So what are they asking? They are asking me the they are asking me basically the power. Yeah, this is the energy, right, and divided by capital T is the power. So all they are asking me is the power. So there are many ways to solve. What I will do, I will find out the RMS value of the x of t, and from that I can compute the power, because power would be square of RMS. So I hope you know all these signals are orthogonal to each other. How are they orthogonal? If you don't understand orthogonality, you will have to watch the videos that I mentioned. You will have to revise. So all these signals are orthogonal. So I can simply add their RMS value whole square. So what is the RMS value of the first term, that is DC? It is 1 whole square, right? 1 is the RMS value and I will square it. Plus what is the RMS value of the next term? That is 2 upon root 2 whole square. What is the RMS value of the next term? Again 2 upon root 2, that is whole square. What is the RMS value of the next term? That is 2 upon root 2, that is whole square, right. So yeah, these are the RMS values. So if I find out this, this will be 1 plus 2 plus 2 plus 2. So this is under root 9, that is 3. Okay. So your RMS value is 3. But what is your power? Power of x of t would be x RMS whole square. That's all. So that would be 9. So 9 is your answer for the question. Am I correct? Okay, sorry. I'm so much hurry that I added 2 plus 2 plus 2. I thought it was 9. No, it is under root 7, right? Sorry. Under root 7. So actually this will be 7. 7 will be your answer for the question. So with this we are done with the basics of signals. Now we will move on to basics of systems. So this is the first question. The output y of n of a discrete time system for an input x of n is this. Okay, it is simply maximum of magnitude of x k of n. What are they asking? They are asking me the unit impulse response of the system. So unit impulse response h of n would be equals to 1 by x of n is equals to impulse. As simple as that. Correct? So h of n would be equals to maximum max k greater than minus infinity but less than n. And magnitude of x of k. Magnitude of x of k, that is like mod of delta of k. Correct? So what is h of 0? Let me choose h of 0. H of 0 would be okay, absolute value of maximum of this. So h of 0 would be from, okay, is it summation? There is no summation sign here. Okay, whatever is the max value. So what happens essentially is h of 0 would be maximum. Okay, let me copy this to 0. So I will compare all the values. K is k only. What I need to do is I need to calculate maximum of mod of k. So it is basically mod of delta minus infinity, then mod of delta minus infinity minus 1 till what? Till, so it will compare all the values delta of 0. And what is this? This is nothing but 1. Correct? This is nothing but 1. So this actually will be equals to 1. So h of 0 is 1. That's all. Okay, h of 0 is 1. What about h of minus 1? So similarly, if I compare all the values till delta of minus 1, so I know delta of 0 is only 1, otherwise any other value it is always 0. So delta of till minus 1 everything is 0. So maximum of 0 is 0 only. Similarly, delta of minus 2, minus 3, minus 4 all will be 0. What about h of 1? What is happening to h of 1? So h of 1, right, I will compare all these values till delta of 1. So again the maximum value will be delta of 0 only, that is 1, right? So again h of 1 will be 1. Similarly, you can go on till h of infinity, it will be actually 1. So basically the definition of your impulse response equals to 1 for n greater than equals to 0 and equals to 0 for n less than 0. This is nothing but the definition of unit step u of n. Okay, so your answer would be C. That's all. Okay, yeah, let's solve this question. Let x1 of t be this value, right? E raised to power minus t ut. X2 of t be this value, and we are doing the convolution of x1 of t and x2 of t, and they want me to find out the value at t equals to infinity of the convolution of x1 of t and x2 of t. Okay, so technically, give a second. So this can be simply solved with Laplace as well. This can be simply solved with basic terms as well, right? Basic properties as well. So Laplace I will show, but first I will show with basics how we can solve it. So I know x1 of t convolution, x2 of t, that is equals to minus infinity to plus infinity x1 of tau into x2 of t minus tau d tau. Okay. Now it all depends what shall you choose as your x1 of t and x2 of t, because I don't want to perform shifting on a difficult signal. So I would not want to perform shifting here. Okay, that will be a bit tedious for me. I would certainly be okay with performing shifting in this signal. Okay, so this will be equals to minus infinity to plus infinity. So I will assume my x2 of t, it does not matter. So basically x1 of t convolution of x2 of t is same as x2 of t convolution of x1 of t. You can swap them around. Answer result will be same. So this will be x1 of tau. X1 of tau is e raised to power, sorry, u of tau minus 2 into, now here if you see, what is this? This is nothing but a rectangular pulse starting in the tau axis at tau equals to 0 and going till tau equals to 2, that's it, right? So rest this function will always be 0. So my integration, I can replace this, okay, I will replace this in the next line, can be replaced with this, right? So I can delete this and simply change my integration limits from tau equals to 0 to tau equals to 2. That's how simple it is. And I can replace my x2 of t, because otherwise it is always 0, right? So I can replace my x2 of t by this value. So x2 of, so this will be, remember, t minus tau. So instead of t, right, I will have to replace t minus tau. So this will be minus t, t minus tau, and u of t minus tau d tau. Okay, so again we see that e raised to power minus t is just a constant, it is not a function of tau. So e raised to power minus t can be outside. This will be 0 to 2 e raised to power plus tau into u of t minus tau into d tau, right? So now what we can assume is how to solve this. So let us break this down. So I know this function, right, u of t minus tau, u of t minus tau, it is equals to 0 when my t is greater than okay, because right now my t is not varying, right? When my tau is, because ultimately, okay, I will replace this with 2, right? Or let me write this in terms of t and tau. So when my, so because this is u of t minus tau and I am integrating with respect to tau, so I can say when my tau is uh, greater than t, okay, tau is greater than t, what will happen? This function will be 0, right? Because t, let's say, is 1 and tau is, let's say, 2, then 1 minus 2 is u of minus 1, that is 0. So that's why when my tau is greater than tau t, this function will be 0, and when my tau will be less than t, this function will be 1. Okay, these are the things that we will have to take care while the solution. So let's see, let's solve it case by case. Like, trust me, we can easily solve this question, right? With Laplace, this will hardly take you 30 seconds to solve. Okay, and we can certainly solve it, and we will solve it in exam hall. We will certainly solve this with Laplace, certainly. But why I wanted to show this technique, because this might be helpful in some other question. That's why we are learning this. So here my t, yeah, so let's take for the case, like we can take this into two cases, right? We can solve this into two cases where my tau lies between, so here if you see, my tau is lying between 0 to 2, right? That is the range of my tau. So range of tau is 0 to 2, right? And range of t is anything, right? T can be anything, correct? So if I choose the case 1, right? If I choose the case 1, when my so tau is 0 to 2, if I choose a case 1, when my t is negative, okay? When t is negative, what will happen? If t is negative, right, and tau is varying from 0 to 2, so tau is always greater than t, right? So for case 1, this is the y of t, correct? And when my t is negative, when my t is less than 0, you see that uh, your this function is always 0. So 0 into anything is 0. So this whole integration is 0. So your y of t is 0. So for t less than 0, your y of t is simply equals to 0. Your y of t is simply equals to 0. Now in the case 2, in the case 2, for positive t, here something interesting will happen, okay? When my t is positive, then I can break it down into two cases, right? When my t is positive and when it is between 2, when my t is positive and it is less than 2, and when my t is positive and it is greater than 2. If my t is greater than 2, right, that means this equation will always be valid, that my t will always be greater than tau. Then if my t is always greater than tau, this will always be 1, okay? So for t greater than 2, this equation, this will be converted into 1. So let's first solve the simpler case when my t is greater than 1, sorry, greater than 2. If my t is greater than 2, your y of t would be equals to e raised to power minus t 0 to 2. This will be tau, okay, hold on, tau u of this will be 1 only, right, into t tau. That would be equals to e raised to power minus t, this will be e raised to power tau only, and going from 0 to 2. So this would be e raised to power minus t e square minus 1, okay, e square minus 1. So that is the definition of the function when it is when t is greater than 2. But what happens when t is, so when t is greater than 2 and it is, it is simply greater than 2, this is the definition, right? But what happens when t is less than 2? Then something interesting will happen, okay? When t is between 0 and 2, there is bit of overlapping, right? So when t is less than 2, right, how will I solve this integration? How will you solve this integration? So if I replace t is greater than 0, right, and it is less than 2, so t, the range of t is between 2 to 0 to 2. Now again I want to remind, so both t and tau, both, so tau is also varying from 0 to 2, t is also varying from 0 to 2. Now how will you solve it? So if I consider the case when my tau is greater than t, in this region when my tau is greater than t, so this will always be 0, so there is no overlapping area, so this problem is solved. So I will solve for this case when my tau is less than t. When my tau is less than less than t, this will be replaced with a 1. If it is replaced with a 1, what will happen? If it is replaced with a 1, this will be simply integration from 0 to 2 e raised to power tau d tau, right? And this 2, right, will be converted to t. Why this will be converted into t? Because I will say both are varying. T is also varying from 0 to 2, tau is also varying from 0 to 2. But I will take this case. What is this case? Where my tau is less than t. If my tau is greater than t, it is 0. Does not matter. So if my tau is less than t, this will be 1. So this integration can be solved like this. Y of t is equals to e raised to power minus t integration of 0 to t. Why t? Because t is also getting to 2 only, that is fine, but I will use this particular thing, this particular relation. Okay, so a very good visualization has been given by Himanshu sir. It is, I think, on the systems chapter. So I think it is the third or fourth marathon, I don't exactly remember. Wherever you see the name convolution, the exact visualization of convolution, you can go into the signals playlist. There Himanshu sir has very well explained this visually. I am doing this mathematically. He had explained that visually what is actually happening in the convolution. Okay, you can watch that video. I think it's the third marathon in the signals playlist. I don't exactly remember, but it should be third or fourth marathon. I don't remember, right? I think the first, like whatever he has explained the term convolution in that marathon. So e raised to power minus t 0 to t, this will be simply e raised to power tau only, and your u of t minus tau will be replaced with 1 t tau. So this will be equals to e raised to power minus t into e raised to power minus t into e raised to power t minus 1. Okay, yeah, 0, yeah. So it will be equals to e raised to 1 minus e raised to power minus t. That's all. Yeah, now I can actually write what is my y of t. So actually we don't even need to do all this, right? Our solution is very simple. Okay, solution is very simple, but I wanted to explain this part. This part was important. So it will be broken down into 3 parts. Y of t will be equal to 0 for t less than 0. It will be equals to 1 minus e raised to power minus t for t lying between 0 and 2, and it will be equals to e raised to power minus t e square minus 1 for t greater than 2. What have they asked? They have asked limit as t tends to infinity, it is 0. Okay, so your answer is 0, because if t tends to infinity, we will use this definition, and that is simply 0. So it is certainly 0. It is certainly 0. This is our answer. Now how you would have solved if you don't want to use all this and you don't want to use Laplace? What you would have done, you would have solved till this point. Now here you would have stopped, and then see what have they asked. They have asked t tending to infinity. So t is infinity, right? So if t is infinity, then I know certainly this will go to 0. So certainly the answer will be 0. But again, if t is tending to infinity, your tau is going from 0 to 2. So certainly this value will be 0 only. So ultimately this whole thing will be 0 only. That is the case 3. The case 3, right? So this whole thing will be 0, right? So it won't even matter to me. All this won't matter. Okay. Sorry, hold on a second. So sorry, if t is greater than 2, oh sorry, this whole thing will not be 0. This whole thing will be 1, right? This whole thing will be 1. You will solve this integration, right? You will solve this integration, and then you will see that t tending to infinity, this coefficient is going to 0. So certainly this will be 0 only. Certainly this will be 0 only. Okay. So yeah, that's the thing over here. That's the solution, right? So now of course Laplace, very easy, very simple to solve. Method 2, that is Laplace. Laplace you can solve. So now let me take x1 of t and x2 of t. So if I solve for Laplace, this will be equals to yeah, if I solve for Laplace, this will be equals to what? So ultimately, what is my y of t? Y of t is x1 convolution of x2. So basically, my y of s would be equals to x1 of x, x2 of s. So this will be equals to, so what is the Laplace transform of e raised to power minus t ut? It is 1 by s plus 1, right, into Laplace transform of u of t, that is 1 by s, minus Laplace transform of u of t minus 2. So it is applying the shifting property. So on the Laplace domain, there will be a multiplication of e raised to power minus 2s by s, e raised to power minus 2s by s, right? That is what will happen. So if I solve for this, this will be, okay, sorry for the this irritation, I will have to stop this. I have to stop this. This will be 1 minus e raised to power minus 2s divided by s, and they have asked what is the value of y of t as t tends to infinity. So that would be, according to the final value theorem, s tends to 0 s into y of s. That would be equals to, if I multiply this by s, right, this s will be cancelled and I will have 1 divided by s plus 1, don't forget to write the limit, into 1 minus e raised to power minus 2s. So this would be 0, 1 minus 1, that is 0 only. So your answer is 0. So like it is simply a 2-line answer in Laplace. I do agree. I completely agree. But understanding this part, right, is actually pretty important, because I know 90% of the students, they might not have studied signals from us. If they have, they certainly know this concept, right? And if you don't know, like if you have not, then you must not have studied this, and now you know, right, how to solve convolutions in different kinds of limits, how to solve these questions, right, if you did not have the option of Laplace transform. So yeah, now let's solve this next question. So this is the next question. The outputs of 4 systems S1, S2, S3, S4, S1, S2, S3, S4 corresponding to the input signal sin t. Okay, I am providing an input signal sin t for all time t are shown in the figure. So the response are shown in the figure. Based on the given information, which of the following system is slash r definitely not LTI? Is slash r definitely not LTI, that is linear time invariant. So here sin t I'm getting sine of minus t. So you might feel that there is a scaling in the t function, that is t is replaced to minus t. Certainly this will be time invariant, but is it so? Your sin t can also be written as sine minus sine of t. Sine of minus t can be written as minus sine of t, right? Sine of minus t can also be written as minus sine of t, right? So if it can be written like this, then I am just scaling the coefficient, and that is totally valid, right? I can scale. So your input has been scaled by minus 1, and this is totally valid in a LTI system. So certainly S1 is LTI. S1 is certainly LTI. What about S2? S2 again is certainly LTI. What I am doing, I am just shifting in time domain, that's all. And shifting is totally allowed. Like my input signal can totally be shifted if the system is LTI. That is totally valid. So again, S2 is also LTI. Here we are scaling the time. We are scaling the time, right? Scaling t. T is becoming 2t. Again, this is not allowed. Even if you replace, like if you do the same kind of observation like option A, that if you replace sine 2t with 2 sine t cos t, You see 2 sin t is totally fine. I can give input sin t and I can get the output as 2 sin t for a LTI system. But there is a product of a time signal, right, cos t. So this makes a time invariant. So time variant. This makes the system a time variant system. So this is certainly, S3 is certainly not a LTI. Okay. Okay. Which is, okay, sorry, they have asked which is definitely not an LTI. I'm sorry, they have asked which is certainly not LTI. So read the question. You can make these mistakes as well. Not LTI. Not is in capital. So S1 and S2 are certainly LTI. So they will not be my answer. S3 is certainly not LTI. So they will be my answer. Here, sin square t. I'm squaring. So input is getting squared. Again, if input is getting squared, certainly this will be a non-linear operation. Certainly this also will not be LTI. Again, if you reduce your answer, if you want, again you can reduce your answer. So what is sin square of t? So I know cos square of t minus sin square of t cos square of t minus sin square of t, that is cos of 2t, correct? Cos of 2t. So that is my cos of 2t. Now this will be 1 minus 2 sin square of t equal to cos of 2t. So sin square of t would be 1 minus cos 2t. I'm just writing in shortcut, okay? This c2t basically means cos 2t by 2. So sin square of t is 1 minus cos 2t by t. So I can replace sin square of t here, right? Again I see there is a scaling in cos, right? So in the time function of cos, so certainly this is time variant. Certainly this will not be LTI. So certainly option D will be my answer for this question. Let's now solve the next question, right? This is the next question. So consider a system with input xt and y of t, where y of t is equals to x e raised to power t. X of e raised to power t, the system is causal, time invariant, non-causal, time varying, causal, time varying, non-causal, time invariant. So what I can do, the system is so for the system to be causal, for t less than 0, my output, right, y of t must be equal to 0, right? Because if I'm providing a causal input, that is x of t equals to 0 for t less than 0, then output as well also will be causal, right? If the system is causal, if the system is causal, if the input is causal, output also will be causal. That is happening. Let's see. So my y of t is equals to x of e raised to power t, right? So if t is, so t negative, right? Let's choose a value t equals to minus 2. If I choose t equals to minus 2, this will be x of e raised to power minus 2. And I know, like, if I plot the graph of exponential e raised to power t, so it is equals to 1 at t equals to 0, right? And for t less than 0, your e raised to power t is always less than 1, but it is certainly greater than 0. So your e raised to power t is a positive function. For any value of t, it will always be positive. So this will always be some x raised to power positive. And I know, I have told you, when t is negative, then this is 0. If t is positive, this can be 0, this can be non-zero as well. So y of t for t less than 0 can be 0, can be non-zero as well. Certainly the system is non-causal. Certainly the system is non-causal. It is not causal. Okay, I can, so because I cannot guarantee for negative values of t my output is 0. Even if my input is causal, then also I cannot guarantee. What about time varying? Is the system time varying or is the system time invariant? Okay, so what does time varying basically means? The definition of time varying basically means that if my input, right, is replaced with x of t plus t naught, if the, for an input of x of t, right, the response is y of t, then for an input of x of t plus t naught, the response shall be y of t plus t naught. Then only the system will be time invariant. Is that happening over here? Let's see if that is actually happening over here. So when my input is x of t, my output is x of e raised to power t. Okay, my output is when my input is x of t, my output is y of t, that is x of e raised to power t, right? And when my input when my input is yeah, so now if I replace my input, right, from x of t to x of t plus t naught, so what will be your input? Your input will be x of t plus t naught, right? This is your input. Cool, this is your input, right? What is happening to your output? If this is your input, what is the output? Y dash of t. Y dash of t is equals to x of e raised to power t plus t naught. This is your output, right? If you replace your x of t with x of t plus t naught, basically this t is just a dummy variable, we're replacing it with t plus t naught, right? Whatever is inside the bracket, I will give a shift of t naught, that's all. Okay, now what is y of t plus t naught? Y of t plus t naught, so whatever is there at t, replace it with t plus t naught. So instead of t, I will replace this with t plus t naught. So this will be equals to e raised to power x of e raised to power t plus t naught. Okay, so are these two values same? Is my y dash of t, that is the response of x of t plus t naught, is it equals to y of t plus t naught? Is it equal? No, they are not. So certainly my system will be time variant. It will be time varying. So it will be non-causal and time varying. This will be your answer for the question. Let's now solve this question. Right? Let's solve this question. A causal and stable LTI system with impulse response h of t produces an output y of t for an input signal x of t. Okay, so a causal and stable LTI system with impulse response h of t, okay, it produces output y of t for an input x of t. A signal x of 0.5 t is applied to another causal and stable LTI system. Another, okay, it is a different LTI system with impulse response h of 0.5 t. The resulting output will be what? Okay, uh, okay, interesting. So its impulse response is h of 0.5 of t, right? Another causal system that's whose impulse response is h of 0.5 of t. So I know this, that my, for the system 1, right, S1, my y of t is equals to x of t convolution of h of t. Okay, that is what my y of t is equals to, right? Now they are telling me that now they are applying a signal in the system 2, they are applying a signal that is x of 0.5 of t and whose impulse response is h of 0.5 of t. So what will be the response of the output basically due to this? So do you remember a property? Do you remember a property that if there is a scaling in both the, so there must be a scaling in both the time signals, okay? It cannot be in a single time signal. There has to be scaling in both the time signals. If there is scaling, this is the property basically, that if I am scaling both the input and the impulse with A, then your response would be 1 by mod of a y of t. This was a property of convolution. So they are using the same property. If you see, this line and this line is almost same, but with a scaling of 0.5. Basically your a is 0.5. So this will be 1 divided by 0.5 into y of t, that is equals to x of 80 convolution, sorry, x of 0.5 into convolution whatever this value is, right? So yeah, this will be 2 into y of t, that is equals to this. So your answer actually is, sorry, this also, I'm sorry, just give me a second. Sorry, this also will be scaled by 0.5, right? Don't forget, there will be scaling in this as well, right? This also will be scaled by 0.5. So yeah, your answer would be this. This is your y dash of t, 2 into y of 0.5 t. This is your y dash of t, that is 2 into y of 0.5 t, that is present in option A. So certainly your answer would be option A. Okay, just basic property of convolution. Let's solve this question. This was a kind of a discrete system, and this is a good, seems like a very good question. Okay, what are they asking? I think, let's see. Consider the discrete time system below. Input x of n and output y of n, right? In the figure, h1 of n and h2 of n denote the impulse responses of LTI subsystems 1 and 2. Also, delta of n is the unit impulse. Delta of n is the unit impulse where b is greater than 0, b is positive. Assuming h2 of n not equals to delta of n. Okay, h2 of n is certainly not equals to delta of n. They have properly told us it is not equals to delta n. The overall system denoted by dashed box is what? Overall system, assuming the h2 of n is not equal to delta of n, the overall system is denoted by dashed box, right? So what is the overall system denoted? Is it linear time variant? Is it invariant? Is it non-linear? So all these things they are asking me. So yeah, let's think about it. So let me mark few points. So this is my y1 of n, correct? And here I'm adding these two signals. I'm getting some signal, and this would be my y2 of n, correct? And again I'm adding these signals and getting the output as y of n, right? So yeah, now if I solve this, if I solve this, uh, what is your y1 of n, right? So basically, right, I want to find out the relation between y of n and x of n, and that will give me whether my system is linear, linear, time variant, whatever it is, correct? So this would be equals to, what is y1 of n? Y1 of n is basically x of n convolution, right? There is a block diagram. In Z transform there will be multiplication, but in time domain there will be convolution. So x of n convolution of h1 of n. Have they given us any information below impulse response of it? So h1 of n and h2 of n are certainly LTI. That is known. h1 of n and h2 of n are certainly LTI. Cool. So this will be h1 of n convolution of x of n. And okay, now what we do, we add this, right? So basically our y2 of n will be equals to h2 of n convolution h2 of n convolution into this, right? Whatever is the input is y1 of n plus b into delta of n. So y1 of n plus b into delta of n. So this would be equals to h2 of n convolution of y1 of n plus h2 of n uh, into b convolution of delta of n, correct? And okay, the interesting part is that okay, so first thing is so for the whole system to be LTI, the impulse response must be linear and time invariant, right? So I will replace my x of n with the delta of n, right? Because my impulse response must also be linear and time invariant, right? So simply my y1 of n would be h of n impulse into convolution of delta of n. So convolution will delta of n with will always give me h the same value only, right? So I hope you know this. So let's say in time domain, in continuous time domain, if I have a signal x of t and I am convolving with delta of t, so that would be equals to x of t only. You can always verify this property. This property always can be verified. It will be integration of let me do delta of tau into x of t minus tau d tau from minus infinity to plus infinity. So again for tau greater than 0, this is 1 for sorry for okay, this value, right, will be equals to what? Delta of t into any signal, right, will be the value at delta of t equals to tau, correct? So that would be equals to minus infinity when my tau, so this is a function of tau, right? When tau is equals to 0, this is activated. When tau is equals to 0, this is activated, right? So I will replace my tau with tau equal to 0. That would be simply okay. I hope you know these things, right? So if I have a function x of t plus 2, right, into delta of t, what you will do? You just replace your t with t equal to 0, right? So your function will be 0 plus 2, that is 2 into delta of t. Just here what is happening here, it is not t, it is tau. So I will replace this is tau minus 0, right? So I will replace here tau with 0. That's all I am doing. I am replacing tau with 0. So this will be x of t delta of tau d tau, correct? And x of t is just a constant number that can come outside of the integration, and this integration is nothing but 1, right? Integration of delta of tau from minus infinity to plus infinity is 1. So this actually will be x of t. So that's how this property is derived. I don't want to get into that, but yeah. So convolution of delta of t with is the same function itself, and for discrete time sequence as well, it will be same. There will not be much of a difference. So this will be h1 of n. Okay. So your y1 of n is actually simply h1 of n. Okay, again here I'm convolving this and delta of n. So this will be equals to h2 of n only. This will be h2 of n, h2. So this will be h2 of n. So let me mark this as h3 of n, which will also be LTI, right? Because I am convolving two LTI systems, right? The combination, yeah, that okay. If I'm convolving two LTI systems, will the combination be LTI? Yes, that combination also will be LTI. Yes, convolving two signals, basically two systems are in cascade. That essentially means two systems are in cascade. Is it? Yes, two systems are in cascade. So when two systems are in cascade, if both of them are individually LTI, then certainly the overall system also will be LTI. Yeah, that will happen. Certainly that will happen. So this will be A3 of n. So this would be B into H2 of n. Okay, so B into H2 of n, right? H2 of n plus B into H2 of n. Now if we solve this, right, if we solve this, okay, till this point is fine. Then ultimately your y of n is actually not even, that is the impulse response, is actually equals to this value minus B into delta of n. Okay, minus, okay, all these things are there actually. It's fine. Let me take this to the other new page. Minus B into delta of n. Correct. So this is your this is what, this is the overall impulse response of the system, right? When my input is impulse, this is the overall impulse response. So my h of n, right, overall impulse response of the whole system, that is equals to this, right? Because my input is impulse. Now for us to understand linear, maybe I will do one thing. I will write this in terms of y of n only. So what was this term? This term was equals to, because that will be easier for us to understand, that's why. Okay, I will explain. So this, right, first term, this was nothing but h3 of n is nothing but h2 of n convolution of h1 of n, and there was a convolution with x of n. Remember, right, there was a convolution. So for now let's keep x of n as it is for the time being. So this will be h1 of n convolution of h2 of n convolution with x of n. Then this uh, plus, right, this was b into h2 of n convolution of x of n minus b into delta of n. Okay, so minus b into delta of n, right? Okay, so now what does linearity mean? Linearity basically means if my input x of n has a response y of n, then the input k into x of n shall have a response k into y of n. So replace your input with k into x of n, right? So here if I replace with k into x of n, this k can come outside. Again, if I replace my input k into x of n, this k can come outside. But this one is a problem. there is no x of n term here. If there is no x of n term, you're finished. Okay, you are finished, because you cannot take k common overall. This is a constant term. This does not depend on x. So the problem is I can now take k common, and then hence my response will not be equals to k into y of n. So certainly this system is not linear. Certainly this system is non-linear. This system is certainly non-linear. Again, what about time variancy, right? Again, this part is time invariant, right? This whole part is time invariant, because individually all of them are time invariant, there will be no problems. This part is also time invariant, no problems. But this part again will cause a problem, because what will happen? What should happen basically? What should happen? What should happen? Basically, this whole thing, right? If let's say this part was not there, okay, so your impulse response was only this part. So if you change your x to x minus n naught, all of this will remain constant, okay. But this will, I will explain. So let me explain. So again, for time invariancy, if x of n has a response of y of n, so your x of n minus n naught shall have a response of y of n minus n naught. Okay. So anyways, right, how to solve this quickly? You can see that here I have minus b into delta of n. That is always in constant. So whenever there is any constant, certainly this will be non-linear. Right? Why? Because for a system to be linear, it should follow this curve y equals to mx. Then only we call it linear. Right? Got my point? Okay. So yeah. So y equals to mx plus c. It does not follow the property of linearity, because linearity consists both the additivity and homogeneity, right? So this does not follow the property of homogeneity. Okay, got my point? Now, if I give the input as x of n minus n naught, what will happen? What will happen? If the input is x of n minus n naught, what is the response of the system? Response of the system would be, this will be replaced with n minus n naught. Okay, let me do one thing. Let me mark this response. Let me mark this response f as y 1 of n, and this response as y 2 of n. Got my point? Now tell me this thing. If y 1 of n is equals to this, and so what will be if I replace x with n naught, right? What will happen? Do remember the property of convolution, that if I provide a shift of n naught in one of the inputs, right, your output also will be shifted if given the system is LTA, right? Actually, no, this property was no. I think this does not even depend on the condition of LTA. Even if your system is not LTA, right? Even if these values are not LTA, I think this property still holds. So your output will be replaced with y of n minus n naught. Right. So what will happen over here? So same thing, right? If I'm replacing my x with x minus n naught, right? So this response will be, so your y dash of n, basically when the input is x of n minus n naught, this will be equals to y1 of n minus n naught. I hope the property of convolution holds, plus Again this response will be y2 of n minus n naught. But will there be any changes here? Will there be any changes here? No, right? This is not even dependent of uh, this is not even dependent of your x of n. This will not change, right? So this is the response, okay, and this is your y of n. This is your y of n when the input was x of n, right? Sorry, your y of n when the input was x of n, it was y1 of n plus y2 of n minus b into delta of n. Okay. Now, what shall we do? What shall we do? What shall we do? What shall we do? Now, what is y of n minus n naught? So, wherever there is n, replace that with n minus n naught. So, this will be y of n y1 of n minus n naught plus y2 of n minus n naught minus b of delta of n minus n naught, right? Are these two same? No. So, for a time shifted input, right, x of n minus n naught, I am not getting y of n minus n naught, I am getting something else, right? Again, that states that the system is certainly time variant. So, this has a shortcut. If you know all these things, right, you will be able to solve this in a quicker manner. Instead of solving everything in a good manner, you will be able to solve this. So, it feels like I am writing a lot of stuff just to explain you, but actually this will not take you much time in the actual exam hall. So, it is non-linear and it is time variant. Okay, it is non-linear and it is time variant, right? So, yeah, let's solve the seventh question. So, support for input x of t, a linear time invariant system with impulse response h of t produces output y of t. Okay, so input for an input x of t, a linear time invariant system, impulse response h of t, output y of t. So that x of t convolution of h of t is equals to y of t. This is given. The convolution of x of t with h of t is y of t. Further, if magnitude of x of t, convolution of magnitude of h of t is z of t, which of the following statements is true? For all t belonging to, okay, h of t is the impulse response. Okay, it is the impulse response. Okay. For all t belonging from minus infinity to plus infinity, your mod of, your z of t will be less than equals to y of t. Okay, I will have to figure this out. So your y of t, right? Y of t is nothing but the impulse response. Okay. Sorry, y of t is the convolution of x of t with the impulse response. Okay. So your y of t is equals to from minus infinity to plus infinity x of t into h of t minus tau d tau. Okay, so that is what your y of t is equals to. Now what is your z of t? Your z of t is equals to minus infinity magnitude of x of t into magnitude of h of t minus tau d tau. So I am taking the mod. So whatever are my negative values, those are becoming positive everywhere else, right? So certainly if there will be, so there will be some negative area, right, by this multiplication, but all of it is positive here. Always these two numbers are always positive, right? So certainly I can say my z of t always will be greater than or equals to y of t, because here, right, my x of t can be negative positive, my h of t minus tau can be negative positive, so multiplication can be negative positive, right? Now what will happen? what will happen? This can be negative, positive, right? So overall your area can be negative sometimes, can be positive sometimes, but this always will be positive. So I'm only adding positive areas. So this will always be, 0 of t will always be greater than or equals to y of t. This will always happen. Okay. So this option C is certainly correct. So for all t belonging to minus, uh, for all t belonging to uh, minus infinity to plus infinity, your z of t will always be greater than y of t. Why? Because I am taking the absolute value. So always there will be some positive times positive, right? So always this integration will be, I'm adding positive values. I'm always adding up positive values. But here sometimes x of t can be negative, sometimes h of t can be positive, h of t minus tau can be positive. So negative plus positive will be negative. Sometimes I'm adding up negative values. So it is reducing the overall answer. Sometimes I'm adding up positive, it is increasing, but there are some negative values, right? So overall negative positive somewhat it will be in the middle, right? But here I am always adding positive values. Certainly this will always be greater than or equals to, at max if both are always positive they can be equal, but certainly I can say your z of t will be greater than y of t if for some interval of tau they are negative, one is negative, one is positive, correct? So I hope that makes sense here. So yeah, option C will be correct for this particular question. So let's solve this next question. If the input x of t and output y of t are related by this particular relation, maximum of 0 comma x of t, then the system is linear, time invariant, variant. They are asking these things, right? So what do I know? That if the input, right, so input is, sorry, output y of t is maximum of 0 comma x of t. Okay, so what will happen? So your output, right, you can divide it into a piecewise function. It will be equals to x of t when x of t is greater than 0, correct? When x of t is greater than 0, it will be certainly equals to x of t because it is maximum value is, so maximum, if x of t is greater than 0, let's say 2, so maximum of 2 comma 0 will be 2 only, right? So it will be x of t when x of t is greater than 0. It will be equals to 0 when x of t is negative. That is the point to note here. And whenever we divide our output in a piecewise function in terms of x of t, we know, sorry, it is 0, right? Certainly this is not linear. This is non-linear function, right? It is not following the curve y equals to mx relation, right? Certainly this is not linear. Okay, that is what I feel. Hold on, it is 0 because if I replace my input k, so what will happen? Why is it not linear? This is the first thing. If it is divided in piecewise function, it will not be linear. Second thing is, you might have a doubt, sir, what if I replace my x of t with k into x of t? So the response also will be, if it is linear, it will be k into y of t, right? Let's see what happens. Let's replace our x of t with k into x of t. For that the response is y dash of t. So y dash of t, this would be equals to k into x of t. This also will be replaced by k into x of t greater than or equals to 0. This will be 0. This will be k into x of t less than 0. So you might say, sir, I can write this k into x of t, right? So if I divide by k on both sides, nothing will happen because it is 0, right? So this can be written as x of t greater than or equals to 0. This can be written as x of t less than 0. Okay, so this will be, this also can be written as k into 0, right? K into 0 is 0 only. So ultimately I can take k common from everywhere. So this will be k is common from everywhere, x of t this I can rewrite x of t less than equal to 0, this is 0, x of t less than 0. This is what? You will say this is y of t. So this will be k into y of t. So your response actually is equal to k into y of t, and you will say it is linear. But you did not consider one case. So the moment you moved from this point to this point, you made a mistake. When you divided by k, you assumed your k is positive, and that will not change the sign of inequality. But what if your inequality has what if your k is negative? If your k is negative, then the sign of inequality will change once you divide by k, right? And if the sign of inequality changes, this equation will totally change. So hence it is not linear, right? So this part is only valid when my k is positive. If k is negative, then certainly your response y dash of t will not be equals to k into y of t. Okay, so certainly your system is not linear, right? It is not linear. What about time variant and invariancy? So certainly your system is time invariant. How it is time invariant? So again, for time invariancy, what do we have to do? We have to replace, if I replace my x of t with x of t minus t naught, this will be y of t, this will be y of t minus t naught. So this will be equals to, this will be equals to, yeah. So if I replace my x with x of t minus t naught, what will happen? This will be x of t minus t naught, x of t minus t naught greater than equals to 0, 0, x of t minus t naught less than 0, right? This is your response. And what is y of t minus t naught? That is equals to, so just replace wherever there is t, right? Replace it with t naught, t minus t naught. Wherever there is t, replace that with t minus t naught, and that is carbon copy ditto of whatever we got in this case. So certainly your response y dash of t is equals to y of t minus t naught. So certainly you can say that your system is invariant. Your system is time invariant. So it is non-linear and it is time invariant. Okay, so option D is the correct answer for this question. Let's solve this question. This one. Two discrete, I think this is the last, no, there are a few more questions from systems. Okay, so yeah, but I think this will not, should not happen here. Let's see, let's see. Okay, we have more questions. Oh, we have a lot. Okay, we are only starting with double E, right? I think this is double E 2024, 2023. Okay, this is double 2023, I guess. So there are a lot of so we have not even covered the double E questions. All we are doing is covering the EC questions, I'm guessing, right? Or we are, I don't know. Lot of double E questions. Okay, there are a lot of double E. So what are we covering right now? I don't even remember. Yeah, this is a double E question only. Okay, we just started the double E. Oh, we are covering a lot of double E questions. Okay. So yeah, for this two discrete time linear time invariant systems with impulse responses this and this are connected in cascade, where delta of n is the Kronecker delta. Simply it is the delta function. Okay, impulse function, that's it. The impulse response of the cascaded system shall be, what is the impulse response of the cascaded system, right? It's very simple. So impulse response of the cascaded system will be simply h1 of n convolution of h2, that is equals to delta of n minus 1 convolution. So it is n minus 1 plus delta of n plus 1 into delta of 1 plus delta of n minus 1, right? So this will be equals to delta of n minus 1 convolution of it with delta of n, that is nothing but delta of n minus 1 only. Am I correct? Hold on a second. It is x of n. Yeah, anything convolution with delta of n is the same function only, right? It is delta of n minus 1. Okay. And delta of n minus 1 convolution of delta of n minus 1. What is it? So what is happening is that so we know this property, right? Y of n is equals to x of n convolution with h of n. Here y of n minus n1 minus n2 will be equals to x of n minus n1 convolution with h of n minus n2, right? H of n minus n2. So now, yeah, now what is happening here is that how do I solve this? So how do I solve this? How do I solve this? Yeah. So now we know this, right? So basically, in our case, both x of n and h of n are both delta of n. Okay. So if both x of n and h of n are delta of n, so delta of n convolution with delta of n is nothing but u of n. Okay. Okay, one small mistake. Yeah, delta of n convolution with delta of n is u of n. Yes, I forgot this actually. Yeah, delta of n, because it is nothing but oh yeah, it will be integration, right? Hmm. Hold on a second. Delta of n convolution. No, sorry. Delta of n convolution, delta of n. That will be not u of n, right? That will not be u of n. It will be the same function only. So yeah, sorry. That is I was talking about something else. Sorry. So what we are doing in our case, both x of n and h of n are delta of n. So in that case, your y of n also is delta of n, right? But what if I shift my impulse, right? So in the case 1, what I did, I give a shift of n minus 1 in the first term. So that's why the result also is delta n minus 1, right? There will be a shift of 1. But in the case 2, what I'm doing, I'm giving shifts both to this and the second term, both to h of n and x of n. So in this case, I will get a shift of 2 by the property of convolution. Similarly here, there is a shift of plus 1, right? So this will be plus delta of n plus 1. And similarly here, there is a shift of what? Plus 1 minus 1. Overall shift is 0. So this is actually equals to plus delta of 1. Okay. So, so I see that it will be delta of n minus 1. I see delta of n minus 1. So certainly there will be no product of delta n. So certainly this option and this option are automatically gone. This is again gone, right? Only two terms are here, not possible. Delta of n should be there. And here I see delta of n minus 2 is there. Delta of n minus 1 is there, right? Delta of n is there. Delta of n plus 1 is there, right? So certainly option C will be correct. Option C will be correct answer for this question. Okay, so let's solve this question. Let's solve this question. Let a causal LTI system be this, but I think if the input and output response is this, what is the impulse response? They're asking what is the impulse response. Okay, this can be solved without Laplace as well. So this should have been in the Laplace part, but I think I forgot to take this to the Laplace. So certainly you can easily, there are no initial conditions. So what you will do, method 1 is with Laplace. So if I solve with Laplace, what will happen? This will be y of s plus 1 by 4 s into y of s, that is equals to 2 into x of s, right? Y of s plus 1 by 4 s y of s, that is equals to 2 into s into x of s. So your y of s is equals to y of s by x of s, right? They are asking me the impulse response, that is basically the Laplace inverse of h of s, that is equals to that is equals to 1 divided by s by 4 plus 2. So Laplace inverse of this would be, okay, let me multiply by 4 on both sides, numerator and denominator. This will be 4 into e raised to power minus 8t, right? That is the Laplace inverse basically. Hold on, oh, by 2 is there, right? So there is a 2, so if I multiply by 4 sides, what am I doing, this is 8, so this will be 8 into 4. So this is your solution, right? And of course ut will be there because it is a causal system they have mentioned, so of course your response, impulse response also will be causal. So 2 into e raised to power 8 into e raised to power minus 40 is your answer. Okay, if you want to solve it without Laplace, how will you solve it? So impulse response is basically the response of the system, that is y of t, when your input is impulse. So it is 1 by 4 1 by 4 dy upon dt, that is equals to 2 into delta t, right? So here if I solve this, this will be, now this is a linear differential equation, so this will be dy upon dt 4yt equals to a delta of t, right? So this will be, so I hope we know how to solve linear differential equation. Integrating factor if is equals to e raised to power p dx, that is 4 dt, so that is e raised to power 40, that is my integrating factor. So this will be solved, so your y of t would be equals to, so y of t into integrating factor, that is e raised to power 40, is equals to integration of q into integrating factor, so it is 8 into delta of t into e raised to power 40 dt. And yeah, we'll start from, I will integrate for 0 to infinity, right? So essentially again I'm multiplying delta t, so this will be basically 0, right? Because multiplying anything with delta t, that will make activate the function at t equals to, so it is t minus t naught, here t naught is 0, so we'll activate at t equals to 0, so this will be 0. Okay, I'll not explain, these are covered in basics of signals and I hope you know all these things. So this will be 8 into e raised to power 0, that is 1, integration of simply from 0 to infinity delta of t dt, right? It is nothing but the step function. So essentially your y of t equals to 8 into e raised to power minus 40 into e of t, okay, e raised to power minus 40 into e of t. So that is what your y of t is equals to, that is your answer, and that is what we can see from here as well, right? So that's a different approach, that is how you can solve it. Let's solve the next question. Consider the system, again this is the exact same question, right? So what is this? This is certainly linear, right? Certainly linear, I think this question has been solved, certainly it is linear. but certainly it is not time varying, right? It is non-causal. It is linear and it is non-causal. This already has been solved previously, so I will not like waste my time. I think exact same question has been solved. Okay, this is the next question. Which of the following statements is slash R2 if an LTI system is causal? It is stable. Causality, does it mean stability? No, it cannot. It can be stable. It cannot be stable as well. It does not mean like if a system is causal, it will be stable only. A discrete time LTI system is causal if and only if its step response u of n is 0 for n less than 0. No, we don't discuss about step response. We discuss about LTI impulse response. So certainly we are if it was written impulse response, then this statement would have been true, but they have written step response, so I cannot comment on this. If a discrete LTI system has an impulse response h of n of finite duration, then the system is stable. Okay, if the impulse response is finite duration, that means if it is finite duration, right? But they have not told me what are the values of each of the system. Okay, what are the values of each of the system? And they have not told me. Hold on a second. They're telling me that it is a finite duration signal, right? If it is a finite duration signal, I can assume that at n equals to certain value 1, right, it exists and the value is infinity, right, and all other places the value is 0. So is my impulse response absolutely summable? No, it is not. Is there an example? You can take this example, right? Tan of n pi by 4 or n pi for n equals to, okay, n pi by 2, right? So n pi by 2 for n equals to 1, this function only exists, let's say, for n equals to 1 only, right? So I know tan pi by 2 is what? Tan pi by 2 is infinity. So this function is not absolutely summable. Certainly this will not be stable. Okay, this is not true. The impulse response, if the magnitude of the impulse response always lies between 0 and 1 for all n, the LTI system is stable. If the magnitude, this again is not true, right? It is a infinite duration signal, and if h of n is an infinite duration signal, even though your magnitude always lies between 0 and 1, right? So it's not like it is always reducing. Sometimes it is 0.5, sometimes it is 0.6, sometimes it is 0.4, sometimes it is 0.7, sometimes it is 0.8, and so on, right? It is changing. So again, it is not absolutely summable. If it is not absolutely summable, certainly option D is wrong. So here all the 4 options are wrong. Now you are stuck. In the exam hall, I would have solved like this. I would have unchecked all the options, then I would have been stuck. So must be somewhere I'm making a mistake. Where am I making the mistake? I feel these are all certain, right? They are not absolutely summable. These are all certain. But this, maybe I can revisit this point more again. So if I revisit this point, a discrete LTI system is causal if and only if its response to a step input u of n is 0 for n less than 0. What is a step response? Basically, step response is s of n would be equals to your impulse response h of n convolution with e of n. Okay, h of n convolution with e of n, that is what your step response is equals to. Okay, now how do I solve it? 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 Yeah. So if I'm doing the convolution, so if your a discrete time LTI system is causal if and only if its response to a step input u of n is 0 for n less than 0. So what will happen if, let's say, if your impulse response is not causal. Okay, let's assume for the case where your impulse response is not causal. If it is not causal, right, then for n less than 0, this will be 0, right? This will be non-zero. So this will be non-zero, correct? Then what will happen? So uh, because then there is a bit of problem, right? You cannot certainly say that your s of n will be 0. You cannot certainly say that. You certainly cannot say that s of n will be 0 if it is non-zero. Okay, why? Let us take bit of examples, right? Let me take a very basic example. So let's take, not talking about step response, just talking about a very basic example, right? uh, let's say this is x of n, h of n is x of n, convolution with delta n. What is this convolution? This is x of n, right? So for n less than 0, what is happening? Your delta n is 0, but is the convolution 0? No. So you cannot say, sir, this is 0, so 0 is there, so 0 convolution will be 0 only. No, it is not multiplication, it is convolution. So don't get confused by the fact that if it is 0, so 0 convolution with anything will be 0. No, you're wrong. Okay, don't get confused. So if it is non-zero, I cannot comment what will be the step response. It can be non-zero. So for n less than 0, what is happening? My step response is coming out to be non-zero. Then certainly I can comment, if it is coming out to be non-zero, then certainly I can say that your step response will be, sorry, your impulse response will be non-causal. If it is causal, if it was supposed to be causal, then both are 0. Now if both of them are 0, right, then certainly your x of n is also 0, so this will be 0 only, this will result in 0 only. So ultimately your answer is coming out to be 0, and 0 convolution 0 is 0. Don't worry about that. 0 convolution 0 is 0. So your step response is coming out to be 0 for n less than 0. That means if my step response comes out to be 0, basically if my step response is causal, that is what they are telling me. If my step response is causal, then certainly my LTI system will be also causal, because step itself is a causal function, and if step response is coming out to be causal, then this has to be causal, right? This has to be 0, right? That means basically h of n is causal, and if h of n is causal, that means my system is causal. So option B is correct. Initially I told you, no, I don't know whether this will be true or not, so I marked it incorrect. Then we corrected it. So that's how you can solve these kind of questions. Let's solve this question. For the signal x of t and y of t shown in the figure, z of t is equals to x of t convolution of y of t is maximum at t equals to t1. Then the value of t1 would be, what is the value of t1? Okay, pretty interesting. It is maximum at t equals to capital T1. They are asking me what is the value of capital T1. Okay, I can observe that this function is 0 from -3 to 1, and it is 1 from here, right? And this function is just equals to t from t equals to 1 to t equals to 5, and this function is 0 during that duration. So sorry about that. So let's calculate it part by part, right? So let me calculate this thing part by part. Can I calculate this thing part by part? That is what I'm thinking about. So let's say z of t is what? X of t convolution of y of t, that is equals to integration from minus infinity to plus infinity. This will be y of tau to x of t minus tau d tau. Now how do I solve this? now here, right? uh, hmm, y of tau is, so y of tau exists from t tau equals to 1 to tau equals to 5. So that is equals to, basically, what is this value? This is, what is the slope? Slope is capital small t only, that is tau only in this case, if I replace t with tau, and this will be tau minus, so the slope would be tau, so now the y of tau would be tau minus 3. Yeah, that is what my y of tau is equals to. Yes, so I can, so the integration will be from minus 2 to 2, so this is z of t, basically this will be tau minus 3 x of t minus tau. So x of t minus tau, right? So this will be basically, yeah, let's keep it x of, so this is what is this? This is simply u of t plus 1 minus u of t minus 1. Okay, so that would be equals to t minus 1. Okay, so that is equals to d tau. So yeah, okay, this is actually t plus 1 t minus 1. Actually this will be replaced with t minus tau. That will be again bit tedious for us to compute. Okay, okay, let me keep it x of t minus tau only. We'll see how we can solve. So here what we can see is, now again let's put the ranges, right? If my tau, so tau range is from minus 2 to 2, correct? If tau ranges from minus 2 to 2, what is this function from minus 2 to 2? That is what they are asking. This is not unit step, right? So when my t is, let's say, less than minus 2, okay? No, actually, when is this function 0? So if my, this, right, let me write this x of alpha. So whenever my alpha is less than minus 1 or my alpha is greater than 1, x of alpha is 0, right? If you see from the graph, alpha is greater than 1 or alpha is less than minus 1, this is 0. So basically they are saying, if my t minus tau is less than minus 1, then it will be equal to 0 and this will come out to be 0. So whenever your t is less than tau minus 1, it is 0. Okay, cool, that is a good point to note. And in the second relation, again I replace alpha with t minus tau. Whenever my t is greater than tau plus 1, then also this function is 0. So and what is the range of tau? The range of tau is from minus 2 to plus 2, minus 2 to plus 2, right? So if I put the lowest value, minus 2, so whenever my t is less than minus 3, then this convolution will come out to be 0. Whenever, if I, now I will not put the minus value, I will put the highest value because I have to calculate the upper limit. So whenever your t is greater than 2 plus 1, that is 3, then also the function will be 0. So ultimately, right, your output y of t is within a rectangular pulse, that is u of t plus 3, like t equals to plus 3 to t equals to minus 3, because after that and before that, sorry, before this and after this, right, the function is 0. Your integration is 0 because x of t itself is 0 and this product will come out to be 0. What we are concerned is between t equals to minus 3 to t equals to 3. That is what we are concerned about, right? We're concerned about t equals to 3 to t equals to minus 3. Okay. So between t equals to 3 to t equals to minus 3, your x of 3 is always 1, right? So whenever your tau is, so if my tau is minus 2, this will be minus 3, right? Then also it will be 0. Whenever your tau is 1, this will be again 0, that is fine. If your tau is minus 1, this will be minus 2, this will be again 0, right? Okay. That is the lower limit, but if tau equals to minus 1, then also this is 0, right? Uh, sorry, I'm making a mistake. Sorry, I have to, if I want to calculate the lower limit for t, right, I will have to put the maximum value of tau, because if I choose a lower value, so that is anyways less, that will be anyways less, that will be, am I correct? If I choose a lower value, so your t has to be less than this, right? If I choose t equals to 2, that is 2 minus 1, so that is 1. So if your t is less than 1, then this will be 0. If your t is less than 1, this will be 0. No, we have chosen the correct ranges. Now we have to calculate basically. So your t is varying from minus 3 to 3, because that is the value of t, that is what we have computed. Okay, now what I want to do, I want to see, now in this case, right, whenever your, so if my t, so if my t is between 3 to minus 3, then this will be non-zero, am I correct? Because my tau itself is ranging from minus 2 to 2, this will be non-zero for what values? Whenever my t minus tau is lying between minus 1 to tau. Whenever my t minus tau is lying between minus 1 to tau. So actually I want to convert this integration in terms of tau only, but when will it help me? Actually there is this negative. So okay, one thing we can see that from minus 1 to 1, if I am integrating, right, I am doing some integration from minus 1 to 1, the area will be added, then there is some negative value. So if there is some negative value, then the area will be subtracted, then again it will be added, right? So my assumption would be, I am getting a maximum value at t equals to 1. Okay, that is my assumption, but I can be wrong as well. Okay. Because yeah, I can be wrong as well, right? No, that is not a good way to assume. That will just, that is not a good way to assume, right? So ऐसे करके मत सॉल्व करना, काट इसको भाई पूरा। मैक्सिमम एरिया चाहिए भाई, क्या है मैथमेटिकली कर रहे हैं इसको, आसान से कर सकते, विजुअलाइजेशन से करना, इतना कितना कुछ कर दिया भाई। वो चाहता नहीं ना, वो चाहता नहीं है ये चीज़ करना, चाहता है तो सिंपल से करे, इसको कोइंसाइड करवा देना यहाँ से। सो बेसिकली टी माइनस सी, तो So let's solve the next question. This is the next question. For the signals x of t and y of t shown in the figure, z of t equals to this, x of t convolution with y of t is maximum at t equals to capital T1. Then T1 in seconds is what? So basically they're telling me at what value of t, right, my convolution is maximum. So your z of t is x of t convolution with y of t, and what at what particular value of t it is maximum. Do understand it? It is basically telling me that z of t is maximum at t equals to capital T1. It is nothing but the area. Area of what? So area of what? So your convolution is simply integration from minus infinity to plus infinity into x of tau into y of t minus tau, right? In this case, this function is very complicated to shift, right? This function is much easier for me to shift. So I will keep this as, I will swap the variables here. Okay, it is basically the area, and this is my z of t. So z of t will be maximum for a particular value, let's say at t1. So this area, right, area of the product of two functions, area of product of two functions, area of product of two functions is maximum at t1. So what is, let me plot the graphs. Y of tau is very simple, y of tau is this only, right? Y of tau is this. What about x of tau? X of t minus tau, right? So x of t minus tau, so it is t1 minus tau, it is x of t1 minus tau. So first what I will do, I will plot x of tau. X of tau is this, right? Just t is just a dummy variable. I can write x of tau, I can write x of alpha, x of beta, gamma, don't care, right? So it is just a dummy variable. Now I am writing x of minus tau, right? You are writing x of minus tau. If you are writing x of minus tau, what will happen? This is an even function, so nothing will change. Now you replace with your tau minus tau, you add a shift. Okay, let us shift first, then do the scaling, right? That's how we do it. Yeah, actually plus t, right, or plus t1. This is the, like, basically what I'm doing. So my function is x of minus tau plus t1. So first I will shift by t1, give a positive shift by t1, then I will scale by minus 1. So plus t1 basically means I am, this is leading, right? So this will come here. So your x of t will be shifted by plus t1, so it will be coming somewhere here. All the points will be shifted somewhere here. So this will become shifting by t1. So this will be 1 minus t1, and this will be minus 1 minus t1. Okay, because I'm making it early. If it was minus, then if it was minus t1, then this would have lagged. Okay, so yeah, then I will scale by minus 1, right? Scaling basically means inversion. So everything will be inverted. So if I scale it by minus 1, inverted about the y axis, so this will come here. Just give me a second. This will be, so this will be inverted. This will become what? T1 minus 1, T1 minus 1, and this will be T1 plus 1, right? All the time values, right, tau values will be inverted. Okay, that is what this function, that is the graphical representation of this function, right? So let me keep it. Now I want this area to be maximum, right? So product of these two functions, right? And I want this area from minus infinity to plus infinity to be maximum. So certainly I don't want any negative part, I don't want any negative area. So certainly I want to start from this part. So when my tau is 3, right, this also should be 3. So basically what will happen then before this, so what is happening, let's assume a very basic case. Let's assume that t1 is equals to 2. If t1 is equals to 2, what will happen? This will start from 1 and this will end at 3, correct? So 1 is somewhere here, right? 1 is here exactly. So 1 is somewhere here. So 1 is somewhere here. I'm starting from here. I'm multiplying these two values, correct? So what is happening? This is negative and this is positive. So ultimately negative into positive is negative, and I'm integrating that area. That will give me negative, right? I don't want that. I want the maximum value, highest value. So I always want the multiplication to be positive. And when will the multiplication will be always positive? If I start from here. So if these points are same, right, then the multiplication will always be positive. Then the area will be maximum, will be highest. I will not get any negative area. So that is what is happening over here. So basically my t1 minus 1 will be equals to 3. So my t1 will be equals to 4, right? That is your answer. That's it. So actually this question is pretty easy, pretty simple, but you will have to analyze this question graphically. If you try to do mathematically, you will be stuck. Let's solve this question. Suppose signal y of t is obtained by the time reversal of signal x of t. Okay, so y of t is obtained by time reversal of signal x of t. That is this, right? They have already given us. Which one of the following options is always true for the convolution of x of t and y of t? Okay, so they want to calculate the convolution of x of t and y of t. So y of t is nothing but this, right? X of minus t. Okay. So I'm convolving with myself. Now telling me that the convolution is always an even function. Is that so? Convolution to be an even function. Yeah, because if I replace t with minus t, what will happen? Everywhere here also t will be replaced with minus t. So certainly your z of minus t, right, is same. So it is simply x of minus t convolution with x of t. So order does not matter in convolution. So certainly your z of t is equals to z of minus t. So it is an even function. Is it an odd function? I cannot comment. I cannot comment. Is it a causal function? No, it is not a causal function. Why? Because if x of t is a causal, first of all, have they told us x of t is a causal? They have not even told us x of t is causal, right? If it is not causal, then again certainly you cannot comment whether your z of t will be causal or not. But again you can say that, let's say this is a causal signal, right? And x of minus t is here, it will be here, and I am doing the convolution, then it will be something non-causal, right? It will certainly be not causal. Certainly you cannot comment it will be causal, it will certainly be non-causal. Is it anti-causal? No, it is non-causal. It is not anti-causal. It will exist for t greater than 0 as well as t less than 0. So it will be non-causal, it will not be anti-causal. So it is an even signal. That is the only correct answer over here. Okay, and this I guess is the, okay, this I guess is the next question where we have to consider the discrete linear time invariant system S, where y of n is basically the response of x of n, like this. So the response of delta of n, right, basically the impulse response is equals to 1 for n equals to 0, 1, 2, and it is 0 otherwise, where delta of n is discrete time unit impulse for an input x of n and output y of n. So basically they are asking me what is the impulse, what is the what do you call, y of n for any random input x of n, right? So basically your response to delta of n, right, is this. So let us replace that. Let us see what is happening. If I change my x of n to delta of n, what is the first answer? What is the first response? It is delta of n plus delta of n minus 1 plus delta of n minus 2, okay, which is nothing but 1, 2 and 3 for n equals to 0, 1, 2, otherwise it is 0. So the first option is certainly seems correct, okay, seems correct. Let's do it for the other options. So here what is happening, this is delta of n minus 1 and delta of n plus delta of n plus 1. Okay. Right. So this means what? Like here my response y of n is equals to 1 for n equals to 1, for n equals to 0, for n equals to minus 1. Response is 1. Is it true here? No. It is only 1 for n equals to 0, 1, 2, right? It is not equals to, uh, it is not true. So this is again not correct. This is not the proper impulse response. Similarly, if you do it for here, you will see it is non-zero for n equals to minus 1 and minus 2. Again incorrect. Again same thing will happen over here as well. So only option A is correct, and certainly your answer would be option A. Let's solve the next question. Right. So yeah, this is the next question. Let the continuous time signals x1 of t and x2 of t be this. Okay, and this, consider the convolution, then then integration from minus infinity to infinity y of t. Okay, you have to compute the integration from minus infinity to infinity y of t. So that would be, okay, there is a easier way out, I think. X1 of n, v of n. So if you go like that and that, if you actually it would be much easier if you solve it by, I think, Fourier transform, but I think you can solve it without Fourier transform as well. But for that, first you will have to calculate what is the convolution of x1 of t into y1 of t, right? 0. Okay, so how do I calculate it? So I will have to calculate from minus infinity to infinity, right? So I think we have a area property. Yes, we have a area property. Yeah, that is the area property of convolution. Yeah, this is what, this is basically telling me area, calculate the area of y of t. So if my y of t is x1 of t convolution of x2 of t, right, then the area of y of t is equals to area of x1 of t into area of x2 of t. Okay, that is the area property. So yeah, we essentially have to calculate the area of x1 of t and area of x2 of t. So what is x1 of t? X1 of t is equals to x1 of t is equals to 1 between 0 to 1, and again from t equals to 1 it is 2 minus 1, that is 1 only, then it is increasing, so it is decreasing, it follows this curve. So it is t equals to 2, that is 1, it is equals to 0, this is equals to 1, right? Okay, cool. Now yeah, if I solve this, what is the area? Area would be 1 into 1 plus half into base into height, so that is equals to 1.5. What about x2 of t? X2 of t would be equals to t, right? Then again it is 2 minus t, so 1 to 2, so it is simply a triangle, right? Yes. So what is the peak? Peak is equals to 1, so the area would be half into base into height, so this is 1. So basically it will be 1.5 into 1, that is simply 1.5. So your area would be 1.5, that is your answer. So your answer is option A. Option A is your answer for the question. Let's now solve this question. I guess this question is the last question of systems. Systems went a bit long than signals because there are a lot of things, right? In systems, a lot of things are involved. Both signals and systems, both are involved. The continuous time unit impulse signal is applied as an input to a continuous time linear time invariant system. The output is observed to be continuous time unit step signal. Which one of the following statements is true? Every bounded input, okay, hold on a second, continuous time unit step signal. If I am applying an unit impulse signal as an input, so my input is unit impulse and the output is observed to be ut. Okay, that is fine. So for a bounded input, output is getting bounded, that is fine. So basically the impulse response, right? Impulse response h of n, sorry, not h of n, h of t is what? H of t is simply u of t. The impulse response is u of t. Okay. So if impulse response is u of t, is the impulse response absolutely summable? Oh, sorry, absolutely integrable? No, it is not absolutely integrable. So this statement, right? So it is not a Bibo stable. Bibo stable? No. So every bounded input signal applied to S results in bounded output? No. It is not Bibo stable. So bounded input, bounded output, it will not be stable. So this statement is wrong. It is possible to find a bounded input signal which when applied to S result in an unbounded signal. Valid. This is possible. Right? Because it is not Bibo stable, this is possible. This is true. It is possible. You can calculate, you can choose any value, certainly you will get. So how can I verify? So this is the impulse response, right? So if the impulse response is this, it will be basically 1 by S, correct? 1 by S, or okay, let me keep it ut only. Let me keep it ut. Okay. So if it is ut, and let's say if I'm providing the input, so h of t is ut. So what will be your y of t? Y of t would be always x of t convolution with u of t. And let's say I am providing a bounded input, that is u of t. If it is u of t, so u of t convolution with u of t, what is it? It is simply integration, right? Integration of, so basically whenever I'm convolving with u of t, I'm simply integrating the input, right? So it will be integration of u of t dt, that is nothing, running integration, that is nothing but t ut, right? So for a bounded input, the output is going unbounded. So yeah, it is possible to find a bounded input signal such that the output will be unbounded. On applying any input signal S, output is always bounded. No, again, right, it is not reversible, it will not always be bounded. On applying any input signal S, output is always unbounded. Again, this statement is also incorrect, right? Again incorrect, because it is not always unbounded, right? So if I apply any input, if I apply delta of t, will it be unbounded? No, right? Your response will be u of t, that is bounded. So that is fine. So option B is the correct answer for this question. With this we are done with the systems. Now we will start with Fourier series. Yeah, let's start with Fourier series. So this is the first question. Let x of t be a periodic function with period 10. Okay, so period is 10, that is capital T is 10. Right, the Fourier series coefficients are denoted by this. So generally we denote it with ck. Here they are denoting it with ak. Does not make any difference. Okay, don't worry about it. The same function x of t can also be considered as periodic with period t dash for t. Certainly it can be, because if it is periodic with t equals to 10, certainly it will be periodic with t equals to 40 as well, right? Similarly, if a sine wave, right, sine t, what is the period? The period is 2 pi. So certainly it will be periodic with 4 pi as well, right? It will repeat after 4 pi as well. If it is repeating after 2 pi, certainly it will repeat after 4 pi. Essentially it means the integer multiple of the fundamental period will also be a time period, right? That is what we learn in signals. Let bk be the Fourier series coefficients of that particular one period is taken as t dash. Okay, if summation of absolute value of ak is 16, then what is the summation of absolute value of ck. That is what they're asking, right? That is what they're asking me. So okay, what is the summation of absolute value? That is pretty interesting. It is periodic with Fourier series coefficients. This okay. Mm, so what? How do I calculate the absolute value? So if then mod of this. So what do I know? So x of t is this, right? X of t is already given. So what is my uh, x of t can also be written like this, isn't it? That this will be k from minus infinity to plus infinity. The Fourier series coefficients will be bk. This will be e raised to power jk 2 pi over t. Now t is 40. Okay, it is not 20 anymore, it is 40. Okay, make sure. Previously your t was 10. So yeah, this is your x of t. That is also equals to this value. That is equals to ak k equals to minus infinity to plus infinity e raised to power j 2 pi by 10, right? Of course t is there, don't forget t is there, right? Now what are they doing? They are summing up all the possible values of k, right? And they are taking the absolute values, they are taking the magnitude. Okay, they are taking the magnitude. So okay. How do I compute this? So can I find any relation between bk and ak? I'm thinking about it. So when bk at k equals to 1, right? K, so essentially these two things are equal, right? These two things are equal. If I'm adding this up, so inside whatever the summation is, that must be equal to each other, right? So if they're equal, I can write, are they equal? No, they are not equal, right? Because I'm doing k equals to 1 2 3, and that case, this case is different, right? Okay, but okay, if I equate the first coefficient, right? So this is just a summation. If I break the summation down, so this shall be at k equals to 1, this is b1 e raised to power j 2 pi by 40t, and b of minus 1 would be, this will be of minus 1 e raised to power minus j 2 pi by 40t. Okay, but here we will never get that value of k, right? So I want to so on the left hand side, I want to see what are the coefficients of e raised to power j 2 pi by 40. The coefficient of e raised to power j 2 pi by 40 is b1, and on the right hand side I should have the same coefficient. Do I have that? E raised to power j 2 pi by 40. Will I be able 2 pi by 40t? Will I be able to reach to this coefficient? Never, because you see that this, right, will be k equals to 0, k equals to 1, k equals to 2. So for any integer value of k, I will be never be able to get to this term, right? So the coefficient of this term on the right hand side is 0, hence this will be 0. Okay, when the coefficients will be matched, so if I do b of 4, if I calculate b, what is k equals to 4? K equals to 4 will be, this will be 4, so 4 and 40 will be cancelled. This will be b4 e raised to power j e raised to power j 2 pi by 10 t, and this exact term is present here, right, when k is equals to 1. So basically you will see a pattern. What pattern? That b4 will be equals to a1, similarly b8 will be equals to a2, and so on, and rest of the terms, that is b1 b2 b3, all these will be 0. So only multiples of 4 will be non-zero, rest of the terms will be all 0. So essentially what you are saying that you are padding up your Fourier series coefficient, right? You're padding up your Fourier series coefficients with zeros, and the multiples of the period, right? That is multiples of 4 are equal to a1, a2, a2, a1 only. So essentially if you are adding up all the Fourier series coefficients and taking the absolute value, you are getting 16. Here also if you add all the Fourier series coefficients, you will get 16 only, because essentially what you are doing, so you are doing mod of a of 1 plus mod of a of minus 1, then mod of a of 0, then mod of a of 2, and so on. Similarly, here also we will do the same thing, mod of b1 plus mod of b of minus 1. But the thing will be here, b of 1, b of minus 1, this will be 0, b of 2, b of minus 2 will be 0. Your b of 4 and mod of b of minus 4 will not be 0, those will be these values, right? That's the thing here. So these will be non-zero, hence they are same. Essentially you are adding up the same thing, just you are adding up extra zeros, that's all. So your answer would be 16 only, nothing will change. Your answer would be 16, it does not affect. Okay, scaling does not affect the Fourier series coefficients. Okay, that's a very good property if you want to remember it. If you don't want to remember, just solve with basics, solve with basic equation, you will get to your final answer. Okay, so here option C would be a correct answer for the question. Let's move on to the next question. The exponential Fourier series representation of continuous time periodic signal is given like this. Omega naught is the fundamental angular frequency and the coefficient of the series are ak. The following information is given, xt and ak. Xt is real and even. Okay, xt is real and even. So if xt is real and even, do you know what how will be my conjugate, so what will be my Fourier series coefficients ak? They will be conjugate symmetric. My Fourier series coefficients will be conjugate symmetric. So if xt is real and even, so your Fourier series coefficients also will be real and even. Certainly they will be real and even. Okay, these are properties with a fundamental period of 6. So your t is equals to 6. The average value of xt is 2. The average value of xt is 2, right? So average value of xt, what do I mean by average value of xt? Average value of xt is 2. So that essentially means the a naught value. So basically the Fourier series coefficient a naught, right? When k is equals to 0, that is a0, that is equals to 2. So a naught represents the DC value or the average value of the signal. Okay, right? So uh, the average value of xt is 2. That, okay, that is fine. A naught is 2. Ak is this value, ak is equals to k 0, for k equals to 1 to 3. Rest of the time for k greater than 0, it is always 0. And as it is real and even, so ak is also real and even, so a of k will be equals to a of minus k, right? So this much information is known to us. Okay, so a of 0 we know, a of 1, a of 2, a of 3 we also know, that is equals to k itself, and all other values are 0. Okay, all they are asking me is the average power of the signal. So average power of the signal by Parsifal's theorem, we know that power of x of t, power of x of t, okay, will be equals to energy of x of t upon the fundamental time period. That is what that is what the, like, this is not Parsifal's theorem, sorry, this is the power, right? And by Parsifal's theorem I can compute what is the energy of x of t. This will be basically magnitude of sum of all the Fourier series coefficients. So magnitude of a naught square, magnitude of a1 square, plus magnitude of a of minus 1 square, and so on. In our case, our a naught is 2, our a of 1 equals to a of minus 1, that is equals to k, that is 1, right? That is k here, that is 1. Our a of 2 is equals to a of minus 2, that is equals to k again 2. A of 3 is equals to a of minus 3, that is equals to 3. Okay, that is equals to 3. Right. we got this. We got this now. Now that's what we need to do. Ultimately, we will have to add all these up, right? So this will be 1 square plus 2 square. Now remember, a of minus 1 and a of 1 are same. So I'll multiply 2 and then we'll do 2 square, because a of 1 and a of minus 1 are same. So this will be, sorry, this will be, hold on a second, hold on. A of 0 is 2 square, sorry. Now this will be 2 into a of 1 whole square plus a of minus 1 whole square, that is 1 square only. So I'm adding up 1 square twice, that's why I kept a 2 outside and I'm doing 1 square, plus a of 2 equals to a of minus 2, that is 2, that is 2 square. Then plus a of 3, a of minus 3 square, that is 3 square. So this is nothing but the n square formula. N square formula is, if I remember it properly, a square, sum of first and natural numbers, then sum of, okay, let's not do it, let's, like, we can simply solve it, right? So this will be 4 plus 2 into 1 plus 4 plus 9, right? So this will be 13, 14, 14 into 2, 28, that is 32. So 32 is your energy, and your power would be energy divided by the time period, that is fundamental time period, that is 6. Okay, so power of x of t would be 32 divided by 6. Yeah, okay. I just made a small error. Yeah, power is energy over time period. Actually, the Parseval's energy over power theorem for Fourier series actually directly gives us the power over a period only. Okay, I was just a bit of error on my end. So this is energy, like we compute the energy over a period, right? And then we divide it by time period. So this is the identity of Parseval's theorem. I just forgot this. I just like forgot the formula. That, yeah, for Fourier series it will give us the power over a period. If I add up all the Fourier series coefficients, if I take the magnitude and square them and add them, that will give me the power, not energy. Sorry. So make sure you revise this. Don't forget this. Right. So this part is wrong. So power would be 32. 32 is your answer. That's it. So yeah, let's solve this question. Let f of t be periodic signal with fundamental period t naught greater than 0. Consider the signal y of t is equals to f of alpha t, where alpha is greater than 1. The Fourier series expansion of f of t and y of t are given by this particular equation. Okay, alpha t, right? If I'm scaling, so definitely the t naught, okay, they have also written here alpha. So they have also changed this alpha t. So that is an interesting thing that they have done. So as they are scaling, right, alpha t, they are here also they are writing alpha t. So here also if they are writing alpha t, what will happen? Essentially these two will be same. We will see. Okay, because in the first question you saw that if we are performing some scaling, you are padding zeros, right? They are equal. Yes, Fourier series coefficients are equal, but not to the number, right? Here b4 is equal to a1, but here something interesting will happen, because here they are writing alpha t. All Fourier series coefficients of f of t and y of t will be equal. How? Let's check it. Right, so they are asking in the first statement, c of k is equals to d of k for all k, for all k. Okay, so let me check this one out. So what is your y of t? Y of t is simply is equals to your f of alpha t, correct? So let me replace here y of t with f of alpha t. So f of alpha t is simply equals to k of minus k equals to minus infinity to plus infinity dk of e raised to power j 2 pi upon t naught alpha k into alpha into t. Now I will do a bit of trick, right? So I can assume alpha into t to be tau. So I will replace wherever there is alpha into t, I will replace it with tau. This will be tau. Just mathematical. It is nothing but mathematical. Now tau is just a dummy variable. It can be tau, it can be alpha, it can be beta, it can be gamma, it can be ohm, anything, right? So again I will replace tau with t. Does not matter because it is inside the function, right? does not matter. All you are doing is just scaling. Okay, so this will be f of t is equals to k tending to minus infinity to plus infinity dk e raised to power j 2 pi by t naught into k into t, which is exactly same as this. So your ck and dk will be equal for all k. So option A is correct. Yt is periodic with fundamental period of alpha into t naught. Okay, is that true? Let's see. So let's take a very basic function, sine of t. What is the period? Period is 2 pi. Period is 2 pi, right? It is omega naught is 1, so 2 pi upon omega naught, that is 2 pi only. So what is, this is my f of t. What is my y of t? Y of t is sine of alpha t. Y of t is sine of alpha t. So if y of t is sine of alpha t, then y of t is sine of alpha t, then what can I say? Yeah. So what is the period? Period, what is omega naught here? Omega naught is alpha. So what is the period? Period would be 2 pi upon omega naught, that is 2 pi upon alpha. That is, so this is your period. So previously your period was 2 pi, now it is 2 pi upon alpha. So it will be scaled by 1 by alpha, not into alpha. So it will be t naught by alpha, not alpha t naught. So this is wrong. This is also wrong because ck is equals to dk for all k, and this is correct. Y of t will be periodic with fundamental period t naught by alpha. Okay, so yeah, that's how you solve this question. Let's solve this particular question. A periodic function f of t with a period of 2 pi. So t naught is equals to 2 pi as its Fourier series is represented as its Fourier series. F of t is equals to a naught plus this, right? F of t is also equal to this. Between 0 to pi it is a sin t, and between pi to 2 pi it is 0, and then again it repeats the same thing, right? So which is a. Okay, now the Fourier series coefficients a1 and b1 of f of t are the Fourier series coefficients of a1 and b1. Okay, we can solve it actually. a1 and b1, what will be the Fourier series coefficients a1 and b1, right? a1 and b1. So this function, it is neither even neither odd, correct? So both will be certainly non-zero. Okay, they can be. It is neither even neither odd. Certainly they will be non-zero. Okay, and they are asking a1 and b1. So what is a1? A1 would be period is 2 pi. Okay, so this you will have to use, like if you want to use bit of intuition you can use it, but I think okay, one can be 0 as well, right? They can be 0, it can be cos, they can be 0, a1 b1, one of them can be 0. So I think you can use the inverse Fourier series formula. So this is the formula. Okay, they are asking me a1 and b1, right? So they are asking me the value of a1 and b1, so I will find c1 basically. That will help me out. So c1, so if you remember, c of n is equals to an minus j bn by 2. So if you ever forget this formula in the exam hall, right, I also tend to forget. So what you'll do, you'll derive it from the basic equation. Okay, so I know we have this equation, right? So c of n e raised to power, so if I have j here, this will be j to, or I can say omega naught into n into t, right? And will go from minus infinity to plus infinity, that will be there, right? Now this will be equals to this thing, trigonometric Fourier series coefficients. So let's just equate it for n equals to 1. Okay, for n equals to 1 this will be c1 into e raised to power j omega naught t, right? And for n equals to 1, the right hand side trigonometric Fourier series, this will be a1 cos of n into omega naught t, that is omega naught, plus b1 into sine into omega naught t, right? So what is your this value? E raised to power j omega naught t. So e raised to power j omega naught t c1, this will be cos of omega naught t plus j sine of omega naught t. So from here directly you can say that your a1 will be equals to hold on, sin theta, right? By 2 trigonometric series. Yes, cos this cos omega naught t plus j sin omega naught t, that is what your exponential Fourier series coefficient is, right? If I remember correctly, I think there is to be by 2 as well. I think they have not put the by 2 here. They should. I think they really should put the by 2. They forgot to put the by 2. So here I am getting that a1 is equals to c1 and b1 is equals to j into c1, right? So if I want to write, if I multiply by minus j on both sides, if I multiply by minus j on both sides, this will be minus j b1 equals to c1, right? So if I add these two up, this will be 2c1. So ultimately your c1 will come out to be a1 plus j b1 by 2. Actually what happens, yeah, it is coming out to be b1 by 2. Yeah, that is correct. Yeah, what have I done? Simply multiplied by minus j both sides, then I added these two up. So your c1 is coming out to be a1 plus j b1 divided by 2. So this is certainly correct, right? Or you can see from here as well what are the relations. So that's how you can remember this thing. Cool. Okay. So yeah, even if you forget, you can derive from here. Now what needs to be done? Lot of stuff. So we have to calculate a1, right? How do I compute a1? So I know my c of n. How do I compute c of n? So c of n, if this is the formula of x of t with respect to c of n. Now if I swap the values, x of t here and c of n here, so then this sign will change. Certainly this sign will change. This will be negative, and because I cannot do summation to a continuous signal, I will have to perform integration. So minus infinity to plus infinity, there will be integration, and this will be basically x of t e raised to power minus j n omega naught t and 1 by t naught also will be there, because okay, you will not be integrating from minus infinity to plus infinity, because your signal is periodic. You will integrate for one period with respect to dt. Okay, this is how you calculate. Now we will have to calculate c of 1, that will be equals to, what is the fundamental time period? Fundamental time period in this case is simply 2 pi. So it is actually equals to 1 by 2 pi integration 0 to 2 pi x of t. In that, so x of t, right, can be divided into two parts. From 0 to pi it is this value, from 0 pi to 2 pi it is 0, right? So only I will integrate from 0 to pi, that is equals to a sine t e raised to power minus j, n is equals to 1. So it is j, omega naught is 1, right? Time period is 2 pi, omega naught is 1, so it is essentially jt dt. Okay, so your c1 would be a by 2 pi into 0 to pi, and your sin t is nothing but e raised to power jt minus e raised to power minus jt divided by 2j. So that would be equals to a by 2 pi 0 to pi this would be 1 minus e raised to power minus j2t by 2j is there, so this will be 4j pi. That's it. Integrating this from 0 to pi. So this will be a raised to the power of 4j pi. This will be pi minus e raised to power minus j2t by minus j, so that will make it plus j2, and I will have to vary for 0 and 1, so for 2 pi t, so this will be e raised to power j2 pi t. Okay, that is interesting. Okay, this is a function of time. Okay, sorry, this is e raised to power minus j2 pi. j2 pi, 2 pi is simply 1. 1 minus 1, that is 0. So this value is anyway 0. So 0, this is 0. Okay, does not matter. So your answer comes out to be minus j a by 4. Okay, so this is the coefficient of what? So you only have an imaginary part, you don't have a real part. So your an is certainly 0. An is certainly 0. So a1 is 0. So a1 is 0. So a1 non-zero will be cancelled. A1 will be 0. What about b1? So b1 would be, so you go no this, right? So b1 divided by 2 minus j b1 divided by 2 will be equals to minus j a by 4. So minus j b1 divided by 2 would be equals to minus j a by 4. So your b1 would be equals to a by 2. Okay, so option D would be the correct answer of this question. Okay, so your b1 would be equals to minus b1 would be equals to a by 2. Option D would be correct, right? A by 2. Yeah, so this is the simplest way with which you can solve, right, without memorizing any formula. As little, like we, of course we have to memorize some formula as little as possible. Of course there are ways with which you can calculate. So you have this formula, an is equals to 2 by time period integrating 1 time period into x of t cos of n omega naught t. Okay, this is one formula, right? And your bn formula is again 2 upon t naught, 0 to t naught, you will do x of t sine of, I'm just telling you another method to solve this same question dt. So you can use this and you can calculate your result faster. Okay, I solved like this because I wanted to do a bit of basic things as well. I wanted to revise you few things as well. That's why I solved using this method. But in exam hall, if you remember these formulas, simply use this. Directly you will get your answer. Yeah, so let's solve the next question, the discrete time Fourier series. So they have given the discrete time Fourier series. Okay, representation is given with n. So I am solving few DTFS questions as well. Just let's see if we can solve it with the basics. Let's see if we can solve it with basics, right? Is given by this. This is the representation of discrete time Fourier series. A discrete time periodic signal with period n equals to 3 has a non-zero Fourier series coefficients a of minus 3, a of 4 as this. The signal is what? Okay. So a of minus 3 is 2. A of minus 3 is 2. That is interesting. So we know if the signal is periodic with period n, our discrete time Fourier series coefficients also will be periodic with period n. Okay. So basically your ak will be equals to a of k plus n. They will also be periodic. So if you have been given a of minus 3, correct, then if I add, so essentially how many terms I have? So capital N, period is 3. So I will go from, so my Fourier series coefficients will exist for k equal to 0, k equal to 1, k equal to 2. That's all. And that is my signal. Yeah, sorry, my Fourier series coefficients will always exist throughout from k equal to minus infinity to plus infinity, but they will be periodic and they will be repeating. So k of 0, right, basically a of 0 will be equals to a of 3, it will be equals to a of minus 3 and so on. They will be repeating. These are just the unique 3 values that I need to consider. So here what needs to happen, what needs to happen, what needs to happen. So yeah, they will be periodic. If they are periodic, how can I solve it, how can I solve it, how can I solve it? So I know a of minus 3, that is 2, that will be equals to my a of 0. Cool. I know a of 4. If I know a of 4, I know a of 1, right? So a of 4 will be equals to a of minus 3, because I can subtract or add a time period, and that will be the same value. Sorry, a of 1, I can subtract 3 from this, that will be same, right? Because your Fourier series coefficients are also periodic. So this will be equals to 1. Okay. What about the other things? So has the non-zero Fourier series coefficients a of minus 3 and a of 4. Rest all of them are 0, right? So basically your a of 2 is 0. That is essentially what they're telling me, right? Non-zero Fourier series coefficients are this, rest all of them are 0. So I don't care. So my unique Fourier series coefficients, right? A of 0 is 2, a of 1 is 1, a of 2 is 0. That's all. Now I can form the signal from this, right? So what does DTFS tells me? DTFS tells me x of n, it is a periodic signal, that will be equals to a of uh, a of n or a of k. K will go from 0 to capital N minus 1 e raised to power j k n pi by capital N, right? That is what is written over here. Sorry, it will be 2 pi, 2k pi, right? So 2k pi, right? 2k pi, yeah, that is the formula. Now just replace your k. So this will be equals to a of 0, k is 0, so k, this will be 0, this will be 1, right? So simply a of 0 is nothing but a of 0 is nothing but 2. So it will be 2 plus a of 1. Now what is a of 1? A of 1 is 1. So this is 1 into, if I put k equals to 1 here, this will be e raised to power j 2 n pi by capital N. What is capital N? It is the time period. Time period is given to us, that is 3. So n is 3. Right? And obviously a2 is 0, right? A2 is 0, that is given here. So certainly this will be equals to, okay, j2 pi n, j2 pi n by 3. Okay, cos 2 pi n by 6 is also there. Okay. Capital N, j2 pi n by 3. Okay, so 2 pi n by 3. Okay, am I missing something here? Just thinking about that. No, it is a2. Thinking what is a2? A1, a2. I'm just thinking what is a2? What is a2? Yeah, a2 is this only, right? 2 and pi by 3, 2 plus this. So okay, okay, they have 1 plus something, right? So they don't have 2 here. So they want to write this in more simpler format. How they would want to write this? Okay, this is some 2 pi n by 6. They want to write in terms of that. Okay. Okay, so you got your answer, e raised to power j 2 n pi by 3. Okay, this is your answer. But they want you to simplify it further. How shall I simplify it? That is what I'm thinking about. How shall I simplify? So I see everywhere there is 1. So this 2 plus j will not work. 2 plus this thing certainly is not correct. So I see 1 plus something. So let me keep it as 1. Okay. If I keep it 1 plus 1 plus e raised to power j 2 n pi by 3. Okay, now let me do one thing. So I see here, I see cos of j to pi n by 6. So what I can do, I can do bit few things a bit smartly. I can take common e raised to power j to n pi by 6. If I take this as common, right, if I take this as common, this will be e raised to power minus 2n pi by 6 plus e raised to power plus 2n pi by 6. So this would be equals to 1 plus 2 divided by 2. So 2 into e raised to power. So now this format, right, is nothing but, if I multiply and divide by 2, this format is cos of 2 pi n by 6. So what essentially they are doing, they are just changing the format, that's all. So I multiply and divide by 2. So this e raised to power j to 2n pi by 6 will be there, and this will be cos of 2n pi by 6. So they just wanted to change the format. So it will be j 2n pi by 6 into 2 cos 2 pi n by 6. So yeah, option B will be correct. But once I was here, right, my question was done. All you had to do now is to properly format it. So from discrete, if they will ask some question, try to remember the first few formulas of discrete and try to solve with that. If you're not able to solve it, it's fine. Leave it the question. Okay, that should be your purpose for discrete Fourier series. And with that, we are done with the Fourier series. Now we will begin with Fourier transform. Let's begin with Fourier transform. So this is the first question. X of omega is the Fourier transform of x of t shown below. The value of integration of magnitude of x of omega whole square throughout omega is what? So we know, according to Parsible's theorem, that it is basically it states the energy, right? So energy of x of t, that is, just give me 1 second, this will be mod of x of t whole square from t minus infinity to plus infinity equals to 1 by 2 pi. Why 2 pi? I will just explain. Mod of x of omega whole square d omega. Why 2 pi? Due to this. Due to this omega, yeah, 1 by 2 pi will come. If this was f, right, then no 1 by 2 pi term would have came, right, if we had integrated with respect to f. Okay, f is in hertz, correct? But we will remember only one thing. Okay, we'll convert everything into f later on, but we'll remember only one thing. Cool? Yeah. Okay, so yeah, I guess this is this. Now let's begin. Let's begin. Mm, let's solve it. So ultimately we have to find out this value, right? Because x of t is given, I will not obviously convert this. I will not transform this into Fourier transform and then convert. No, no, no. I will not do that. What I will simply do is I will compute this value, right, and then multiply by 2 pi. If I multiply by 2 pi, then I will get my desired result. So I have to compute the energy of this signal. How do I calculate the energy of this signal? Not that easy. I am observing it is not that easy to calculate. So what we can do, we can break this into multiple parts. Let's say this is the part 1, this is the part 2. These two are certainly orthogonal, right? Certainly I can add the energies, no problem. But let's say this is the part 3, this whole rectangle, and this is the part 4, this triangle. So what will be the overall energy? Overall energy would be equals to overall energy right, of x of t would be equals to energy of part 1 plus energy of part 2 plus energy of part 3 plus energy of part 4 plus, now because these two are overlapping, do remember what used to come in the formula? It would have been 2 into area of x3t into x2t, x4t, simply the multiplication, that's it, right? So yeah, I will not explain these things because these things I hope you remember that if they are non-overlapping, right, they are orthogonal. So I can simply add the energies. If they are overlapping, I will add their individual energies. Certainly, I will do that. I will add their individual energies, but certainly I will have to find out the area of x3 into x4. So what is x3 and x4? So x3 is just a rectangle starting from 0 ending at 2. And x4 of t would be a rectangle. Remember, it is a rectangle starting from 1 ending at 3. Basically the delta is 2, right? So it will be, if I'm simply, what is this whole thing, right? It is addition of x3 plus x4. So there will be a delta of 2 and the width also will be 2. 0 ending at 2, this will be 2. Okay, drawing is not proper to scale, but I hope you get the point. Okay, 0 to 2. So yeah, what will be x3 into x4? So simply it is multiplying this by 1, which is nothing but the same graph of x4 only, no changes. Again, drawing is not to scale, so don't judge me here. x3 x4. Okay, yeah. Now let's compute the values. E1 is energy of the this waveform and energy of this, right? So it is basically a square tau by 3, right? Half width is 1, a square tau by 3, a is 1, right? So 1 square into tau divided by 3, 1 square into tau divided by 3 plus E3 plus energy of x3. X3 is a square into tau, that is 1 square into 2 plus energy of E4. It is a square into tau half width. Remember, tau is the half width for a triangular waveform, that is 1 into 2 divided by 3. Why 2 by 3? Because it is a complete triangle, it is not a half triangle, plus 2 into area, 2 into area of this particular graph, right? x3 x4, that is half, 2 into half into base into height. So this will be equals to simply 2 square, correct? This will be 2 square. So 1 by 3, 1 by 3, that is 2 by 3 plus 2 plus 8 by 3 plus this will be 4. So this will be 10 by 3, 10 by 3 plus 6. So 3.33 plus 6, that is 9.33, and of course this is the energy, right, of the signal xt. I will have to multiply by 2 pi as well. Don't forget, you will have to multiply by 2 pi as well, correct? 3.33 plus this is 6, right? I hope I'm doing this correctly. 3 plus 6. Just checking. Let's compute this. This will be equals to 9.33 into pi. So this comes out to be 58.64, right? 58.62, because your answer, like magnitude of xt whole square integration from minus infinity to plus infinity, is 9.33, and I will obviously multiply this by 2 pi, which gives me 58.62 to 1, and they have asked us to round off to 2 decimal places, so your answer would be this 52.62. okay, so yeah, the Fourier transform of x of j omega of the signal, this is what. So again, it seems like I know something here. What do I know? I know the Fourier transform of this signal. Do you remember? E raised to power minus a, where a is positive, certainly a is positive, mod of t. This Fourier transform was equals to 2a upon a square plus omega square, right? Now this was in omega, but here I am observing this is in t. This is in t. So if this is in t, let me use the property of duality. So this will come here, that is 2a upon a square plus t square, and the Fourier transform of this will be 2 pi into e raised to power minus a x of minus omega basically. So if I replace t with minus omega, because it is mod, it won't matter. So this will be e raised to power minus a mod of omega. That is the Fourier transform of this particular term. But again, I observe this is not present. It is in a square format. How can I make this in square format? If I differentiate this, if I somehow differentiate this, then I can make it in square format. What is the differentiation? Differentiation of this would be with respect to time, obviously. This would be 2a is just a constant minus 1 by a square plus t square whole square into 2t. Correct? Into 2t. Okay, that will be the differentiation of this. Again, I see t here, but negative sign is not there. That is fine. That is fine. We can like, these are all constants. We can work with them. We can do something. But do you remember what is the differentiation property in CTFT, continuous time Fourier transform? So if I have a signal x of t whose Fourier transform is x of omega, what will be the Fourier transform of differentiation of x of t? How to calculate that? It is actually equals to j omega into x of omega. If you ever forget this, how do you like derive the property? Simply use the basic equation. What was the basic equation of CTFT? Xt was equals to integration from minus infinity to plus infinity x of omega e raised to power minus j omega t dt. Right? So not dt, sorry. So this is plus, right? Hold on a second. D omega, and yeah, if there is d omega here, then there will be 1 by 2 pi. Then there has to be 1 by 2 pi here. Yeah, and if there is omega here, this will be plus. Whenever there is omega, this will be always plus, right? If it was x of t, then this would have been minus. So that's how I used to remember this basic formula. So now we got to this formula, correct? If I know this formula, then let me differentiate both sides with respect to t. So this will be 1 by 2 pi. Now, if I am differentiating this equation with respect to t, this is not a function of t. Only this part is a function of t, right? So this differentiation d upon dt can come inside. And if I differentiate this one with respect to t, what will I get? It will be j omega, right? J omega is the constant for this particular term, right? T is the variable. So j omega can come outside here. So this will be j omega x of omega, and yeah, nothing else will change. This will be and e raised to power plus j omega t d omega. So what is happening? Basically, this is my new Fourier transform, x dash of omega, right? So that's how I remember the property, right? So it will be j omega into x of omega. If you ever tend to forget any property, use basic equation and try to derive on the exam hall, because signal there are unlimited properties. It's very difficult to remember every single thing. So just whenever you're revising, make sure you practice the derivation so that in the exam hall you can pull off the derivation in a fast manner. Of course, it is not recommended for all subjects, only for signals, because signals has lot of formulas. You will not be able to remember all the formulas. So this part you will have to make sure you understand the derivation. So we got to this point. So ultimately our answer would be this particular answer would be j omega into x of omega. So simply I will have to multiply j omega here. That's all. I have to simply multiply j omega. So the Fourier transform of 2a minus 2at upon a square plus t square whole square would be 2 pi j omega e raised to power minus a omega. Right, 2 pi j omega e raised to power minus minus mod of omega square. Don't forget there is a square as well. Sorry, I forgot to. This will be square, right? Sorry, mod of 80 square. I forgot. Sorry, this will be mod of 80 square. Sorry. Right? I know you guys are screaming. Yeah, but what we will have to calculate. So for our case, a is 1. So a is 1. If I put a is equals to 1, right? This will be minus 2t, which is again I don't want minus 2t. So if a is 1, this will be minus 2t. I don't want minus 2t here, right? I only want t. If you see, I only want t. So I will divide by minus 2 on both sides, because I can divide by constants. That will not change anything. So this will become minus pi j omega, because I'm dividing by 2 on both sides, minus 2 by both sides, e raised to power, again a is 1 minus omega square. Okay, sorry, minus 80 square. Hold on, it was, oh sorry, no, it is not square. Sorry, it was not square. That was for a separate thing. Sorry, it was not square, right? That was for Gaussian function. Yeah, for Gaussian function, that's sink of t. No, sorry, this was not cos square. Sorry. So there are two things. Like one is this particular thing. Another one is the Fourier transform of a Gaussian function, e raised to power minus mod of 8. So e raised to power minus 80 square. So for this, the Fourier transform was sink function, right? So remember that one as well. Okay, yeah. So yeah, this will be pi minus pi j omega e raised to power minus 2. I don't see pi anywhere. Okay. Okay. One small mistake. Here I have 2a and here I have 2, right? So this should be actually 480. So actually I will have to divide by 4, not 2. Minus 4, I will have to divide by minus 4, not minus 2. So this will be minus pi by 2. Now I see a lot of similarities, but I don't see negative. But I see j in the denominator. So what I can do, I can take this j in the denominator. Then the sign will change, right? Because minus j, if I take the inverse, it will be plus j. So this can be also written as pi by j2 omega e raised to power mod of omega. So pi by j2 omega e raised to power minus mod of omega, that is present in option A. So option A will be answer for this question. Question seems very difficult, right? But if you follow step by step, if you don't even remember some properties, you can use it, right? Here again I forgot that. Okay, I forgot, like was this mod of t square or mod of omega square, but options were there to help me out. So it cannot be mod of omega square, mod of t square, right? Why? Because everywhere I see it is mod of omega only. So options were there to help me out. Whatever I mentioned, that was for a Gaussian function. E raised to power minus t square, what will be the Fourier transform? I think it is sink of t. The Fourier transform of e raised to power minus t square, right, is sink of t. So Yeah, like that you can remember. Now we can do scaling and stuff, you can bring out the property. Okay, cool. Yeah, let's solve this. Oh, okay, we have this next question only, right? So we have to, the Fourier transform of x of omega of x of t is equals to this is x of omega. What they want me to calculate this area from minus infinity to infinity e raised to power minus y square dy, okay, is under root pi. Then what are they telling me? Okay, they're asking me what is the Fourier transform. Basically they're asking me what is the Fourier transform, right? So this is what the area property, right? So area over the whole graph of x of t basically is under root pi. Okay, so do you know what does it mean? It essentially tells me that this is the value of x of 0. Why? So again, if we apply the property, that my x of omega is equals to minus infinity to plus infinity x of t e raised to what? Because t is there, this will be minus j omega t dt, right? Now if you put omega equals to 0, this is nothing but this particular value, right? So your x of t is e raised to power minus t square. It does not matter if you put t or y, all these are dummy variables, does not matter. They will ultimately evaluate to the same value. So essentially this is telling me the value of my Fourier transform at omega equals to 0. So if I put omega equals to 0, I see this is same. I see these are different. Okay. Oh, sorry here. Okay, I mentioned it wrong. So I also tend to forget. If you tend to forget the formulas, it's okay, go and revise. I think it was the Fourier transform of e raised to power minus t square was e raised to power minus omega square. It was same. That was the speciality of Gaussian function. Sorry, hold on a second. It was e raised to power minus f square. The Fourier transform of e raised to power minus t square was e raised to power minus f square. But what will happen? What will happen in omega? If I want to convert this in omega, right? So what is your f? F is equals to omega by 2 pi. Okay, this will be omega by 2 pi whole square. Okay, now one thing, so here, right, I think I told you a bit wrong thing here, that e raised to power minus 80 square, the Fourier transform of it is a sinc. I was wrong. Okay, so I also tend to forget the formulas, but make sure you revise those things. Like there are mostly three things that you need to revise. What is it? What are those three things? First thing is this one, right? This particular formula, and obviously for step and signum you remember it. Now for a rect function, okay, if I have a rect function, let's say this kind of function, minus tau by 2 tau by 2, this is a. So this is nothing but a rect of t by tau. The Fourier transform would be, what would be the Fourier transform? That would be a tau sampling of omega tau by 2. This you will have to remember. This you will have to remember. You can derive this as well. It is not that difficult, trust me. It is not that difficult to derive. If you want to derive, just use this formula. Not that difficult, trust me. You feel like it is very difficult? No. Just put the value. So it is on non-zero from minus tau by 2 to plus tau by 2. Minus tau by 2 to plus tau by 2. Integrate a. Very simple, very simple. And what is the other one? So this one I will highly recommend you to remember. This one will be helpful to you everywhere. So I also forget this. That is e raised to power minus pi t square. The Fourier transform of this will be e raised to power minus omega by 2 pi whole square. Okay, and here there will be a pi as well, right? I think yeah, there will be pi. Yeah. So this you will have to remember anyhow. You will have to remember anyhow. E raised to power minus pi omega square by 2. Yes, I think I had, so I had made few notes from Himanshu sir. Yeah, I think if you see, yeah, there will be a pi here. So these are just the notes of Himanshu sir. That's it. Okay, so Yeah, let me bring it back. So here you will have to uh, remember like this. So actually the best format is e raised to power minus pi f square, right? So Fourier transform of e raised to power minus pi t square is e raised to power minus pi f square, and what is f? F is basically omega by 2 pi. So all I am doing is replacing f with omega by 2 pi. Okay, because we will remember all formula with respect to omega, that's why I am doing it. Okay, so that's it. Okay, these things you have to remember. Now if I know this Fourier transform, can I use it to calculate the Fourier transform here, e raised to power minus pi t square? So we know this, right? So we know the Fourier transform of e raised to power minus pi t square, that is e raised to power minus pi omega by 2 pi whole square. Now what I will do is I will scale my time. So we know this property, right? X of at Fourier transform would be 1 by mod of a into x of omega by a. So I will use this property. So I will scale my time by what? Your t will be changed to t by under root pi. So your a is 1 by under root pi. So here what will happen? What will change? This will be x of omega by mod of a, that is under root pi e raised to power, this pi will be same, but your omega will be changed to omega under root pi. Okay, by 2 pi will always be there whole square. So all I am doing is I am replacing omega by e. A is 1 by under root pi, that is all I am doing. So this will be equals to under root pi e raised to power minus pi omega square. So this is omega, okay, this is under root pi omega by 4 basically. Yeah, this will be omega square by 4, under root pi omega square by 4. Yeah, option C. Okay, so just remember these three, right? There is another one for triangular. Triangular you can derive. For triangular you can derive. If you don't want to derive, you have the option to remember the formula. But for triangular, what you can do, if I have a triangular, right, I can differentiate that. I can differentiate x of t, and I can use this property, differentiation property of x of t, and also the differentiation, this will be a rect function, and I know the Fourier transform of a rect function. So I can easily compute the Fourier transform of a triangular function if you are feeling uncomfortable remembering the triangular function, right? Okay, so yeah, that is the solution here. I also tend to forget formulas, so you will have to revise them daily. There is no other way. You will have to revise them. If you don't revise them, you will forget the formulas. You will. Let's solve the next question. In the table shown below, match the following signal type with their spectral characteristics. If the signal time is continuous and aperiodic, if it is continuous and aperiodic, what exists for it? Continuous time Fourier transform, right? We know CTFT, and CTFT is what? CTFT is also continuous and aperiodic. So if it is aperiodic, right? If the signal in time domain is aperiodic, its frequency domain signal will certainly be continuous. And if the time domain signal is continuous in time domain, then its frequency domain signal certainly will be aperiodic. So these two will match. If you see here, so first one will always match option A, that I can see in the three options. Let's check it for the second part, continuous and periodic. Continuous and periodic, for this what exists? CTFS, continuous time Fourier series. So it is a series, right? So it is a discrete quantity. It is a series. So C of 0, C of 1, C of 2. It does not exist for all the frequency components. It exists at n equals to 1, n equals to 0, n equals to 2. So if it is periodic in time domain, it will be discrete in frequency domain. And if it is continuous in time domain, again it will be aperiodic in frequency domain. So this, okay, got my point? It is are C of n periodic? No, C of n, we have never discussed periodicity of the Fourier series coefficients. All we know is the time domain signal is periodic. Signal time, again for the third point, it is discrete and aperiodic, right? Discrete and aperiodic. So if it is discrete and aperiodic, so if it is aperiodic, right, if it is aperiodic, then again it will be continuous in frequency domain, and if it is discrete, again it will be periodic in frequency domain. So discrete will be connected to periodic. So basically your 2 will be connected to C, right, and your 3 will be connected to B. So 3 is connected to B, 2 is connected to C, 1 is connected to E. So option B will be correct. 4 will be connected to D. We can see as well, if it is discrete in time domain, it will be periodic in frequency domain. If it is periodic in time domain, it will be discrete in frequency domain. So discrete and periodic, these are always match with each other. So option B certainly will be correct for this. So that's how you connect the dots, okay, and that's how you can remember certain properties as well, that whether my Fourier series coefficients will be periodic, aperiodic, continuous, discrete, that like this you can remember, right? So let's now solve the next question. Now this is the best question, I think till now, whatever we have been solving. So they have given you this x of t, and it must be passed through an LTI system having the impulse response this, the output of the system shall be. So I observe that I am given a co-sinusoidal input, and they're simply asking me what is the output. So it is from which topic? It is from the LTI system's eigen function topic. So if I have a co-sinusoid input s of t, let's say, is equal to some co-sinusoid input, cos or something, right? Then what happens? Your response, your y of t would be h of omega at omega equals to omega naught into your x of t. That's it. Given omega naught is what? Omega naught is the frequency of the input. Given your h of omega is, hold on for the plane, is even in the given point. Now if you don't understand all this, you will have to revise the eigenfunction. So this video is meant to tell you that where are you lagging, which part, which portion do you need to revise. So you need to, if you are not able to understand whatever I'm saying here, that simply means you will have to go open your notes and revise the eigenfunction topic. Okay, so one more thing, this is the part. So I just need to compute what is my h of omega. I will be sorted. Now here, right, it is given sine square of pi t. So it is like sampling square of t. I told you to remember these formulas, and then you can derive for the triangular from differentiation. But now I feel that if you remember it, it will be easier, and it's not even that difficult for you to remember. Again, these are the few things that you should remember. So this is another thing, that is a triangular of t upon tau, the Fourier transform of this would be a tau sampling square omega tau by 2. There are multiple ways to derive this. You can convolve two rectangular functions, you will get a triangular function, right? From that you can solve. There are multiple properties that you can use, but directly if you remember this formula, it will help you out a lot. Okay, and this is similar to the previous one. What is different? Here I have sampling square, that is only difference, and instead of rectangular I have triangular. That is the only difference. So you just remember these two formulas, and obviously this Gaussian one you will have to remember anyways. So remember these three formulas, okay, and obviously the basic formulas you need to remember. Okay, so let's start. So let me first of all, I don't like this. I like sampling of t format. I don't like this format. So this will be equals to pi sine wt upon, okay, pi I can take common, I can multiply and divide by w. So this will be sin wt upon wt whole squared. So this will be equals to pi w by pi, so w will be cancelled. So this will be basically pi also, this will be basically w square by pi. So first of all I am computing for only this part, the Fourier transform. This part is easy, I will explain, don't worry. This part, multiplying by cos tan wt, what happens, I will explain. Let us first compute the Fourier transform of this part. So w square into sampling square wt. Okay, so we already know this. What do you know? We know what is the Fourier transform of a tau, not a tau, sorry, a triangular t upon tau. That is equals to a tau sampling of omega tau by 2 whole square, right? So I can obviously cancel the a, that is not a problem. Now I will use the duality principle. If I use the duality principle, this will be tau sampling square by omega, sorry, not omega, t into tau by 2. Just give me 1 second. Tau by 2, that would be like Fourier transform of that would be 2 pi into triangular of minus omega upon tau, which is same as triangular of omega upon tau, because triangular function is an even function. So we got to this result. I can divide by tau on both sides, that will give me sampling of t tau by 2. Its Fourier transform would be 2 pi upon tau triangular of omega upon tau. I got to this result, but I don't need to calculate this. I need to calculate omega w square by pi, not omega, sorry, w square by pi. So first of all, let me compute this. So in this case, what do I have to compute? I have to compute sampling square of t w by sorry, yeah, I have to compute for sampling square of wt, right? That is present sampling square of wt. So technically my tau by 2 is w. So if tau by 2 is w, that means my tau is 2w. So the Fourier transform of sampling square of wt would be 2 pi upon 2w triangular of omega upon 2w. Okay, 2 pi upon 2w triangular of omega upon 2w, that's it, right? So yeah, we got to this result, but actually I don't need this, right? What I need is w square by pi. So I will multiply by w square by pi on both sides. So w square by pi, this will be equals to w, that's it, this will be equals to w triangular omega by 2w. So what is this? So this, what does this w represent? This w represents the value of my function at omega equals to 0, right? That's all. So if I plot this in the graph with respect to omega, my x of omega, so this will be like this. So the half width is 2w, half width is 2w, and it will increase and then decrease, right? So this will be equals to w, right? The value of the function at omega equals to 0. This is the Fourier transform of this particular function, but I don't need this. I need this is my x of omega. I need, let's assume this is my h of some h dash of t into cos of 10 wt. What happens here? So if I'm multiplying by cos is nothing but summation, combination of complex exponentials, that is plus j 10 omega 10 w t minus, sorry, cos is addition, so it is minus j 10 w t divided by 2, correct, divided by 2. Now what happens when we multiply complex exponential in the time domain? In the phase domain, in the frequency domain, not in the phase, sorry, in the frequency domain, they will be shifted by the opposite amount. If I'm multiplying by plus 10 j omega naught, then they will be shifted by minus 10 omega w, so not omega, w. And if I'm multiplying by minus j 10 w, then they will be shifted on the right hand side by plus j, sorry, yeah, minus, sorry, I'm telling you the opposite. If I'm multiplying by minus 10j, then there will be a shift of plus 10w. So basically your, for due to this term, your x of omega will become x of omega plus 10w, and due to this term your x of omega will become x of omega minus 10w. So this essentially means that there will be a lag of 10w and there will be a lead of 10w, that's it. And of course you have to divide by 2, you'll have to divide by 2, right? So this is how the graph will be. Minus 10w plus 10w minus 8w minus 12w plus 8w plus 12w. Okay, and this value will be multiplied. So whatever was the previous peak, that will be multiplied by half. So this will become w by 2. This will be my actual h of omega. Okay, I know it is very difficult, I know, but now okay, let's now finally solve, right? Let's now finally get, we need to see that whether our function is even or not. Certainly our function is even. If our function is even, then this will follow the eigenfunction property. Then certainly what is our omega naught? It is 10.5 w. So where is 10.5 w? Somewhere here, right? 10.5 w is somewhere here. What is the slope of this line? The slope of this line would be, there is a reduction of w by 2 in the range of 2w, right? In within 2w I am reducing by w by 2. So the slope is minus 1 by 4. That is the slope basically. The slope is minus 1 by 4. Now if I am moving from 10w to 10.5w, how much will my value reduce? So I am changing in the x axis 0.5w. So delta x into the slope, that is minus 1 by 4, that will give me the delta y. So that is equals to w by 8 minus w by 8. So total my magnitude will reduce by w by 8. From w by 2 it will reduce by w by 8, right? So basically what is the magnitude here? It will be w by, this is a change in y, right? So w by 2 minus or plus change in y, that is minus w by 8, that will give me my actual y value at h of omega. Omega equals to 10.5 w. So this will be equals to 3w by 8. So I hope you can calculate these values. These are very basic class 12 things. Okay, so 3w by 8 is my answer. So not my answer, is my magnitude of the transfer function, and there is no phase here. It is all real, right? Your h of omega is all real, so we will not add any phase. So what will be my final answer? It will be whatever is my x of t, that is 10 cos 10.5 w t into the h of omega at omega equals to 10.5 W, that is equals to 3 by 8 W. Now rearranging the terms, this will be multiplied by 2, this is 5, this is 4, so 5 into 3, that is 15 by 4, 15 by 4 W into cos of 10.5 W. Okay, 15 by 4 W into cos of 10.5 W T. Okay, so your answer would be option A. Question is pretty good. I do agree. Question is very good. If you remember the formulas, then it will not take you much time. But if, of course, everyone does not remember this thing, right? So everyone will not be able to remember this. So ultimately, you will have to derive from the basic things. Okay, and it's good actually. It's fine if you take timing signals. That is totally fine. So option A will be your answer. Let's now move on to the next question. This is the next question where we'll have to compute x1 of t is given and x2 of t is shown in the figure. Then for y1 of t, yt equals to x1 convolution of x2 of t, the integration of this, right? Basically the area of yt. So if I am doing the convolution, we know that convolution follows a area property. That essentially what they're asking. They're asking me the area of yt, that is the convolution of x1 of t and x2 of t. So area according to the convolution property would be area of yt will be equals to area of xt into area for x1 of t into area of x2 of t. This is simply the convolution property, that's it. This is simply the convolution property. Or you can use Fourier transform here. What you will say, you will have to, so what is the function in Fourier transform domain? So it is y of omega would be equals to x1 of omega into x2 of omega, right? And they are asking you to find out the area, and we know area in time domain is the value of the Fourier transform at omega equals to 0. So you will basically find y of omega at omega equals to 0. So that will be equals to x1 of omega equal to 0, x1 of 0 into x2 of 0, and we know simply x1 of 0 and x2 of 0 is nothing but area of x1 at omega, area of x1 basically function in time domain and area of x2 in time domain, right? Or you can simply find out the Fourier transform as well and then multiply that at omega equal to 0. Anything works. Okay, I will solve it using both methods. So first, what is this? This is simply a rect function, right? That starts from minus 1.5 to plus 1.5. T x1 of t, and this is 1, right? So 1 minus 1.5 to plus 1.5, right? Yeah, so now if I solve this, yeah, so what is the area of this? Area of this is 3. And what is the area of this particular function? It is area of this impulse is 1, area of this rectangular function is 2, area of this impulse is 2. So it is 5, right? So 5 into 3, so your area of y of t would be 15. So 15 is your answer. Okay, you got to your answer. But you can again convert this into the Fourier transform format as well. You can do it. So okay, this is the Fourier transform of this one. So what is the Fourier transform of this? Something sampling, right? So it is simply sampling. You can convert this into sampling. You know the Fourier transform of an impulse. It will be what? It will be 2 pi. Yeah, simply it will be 2 pi. This also will be 2 pi. Will this be 2 pi? Hold on a second. So Fourier transform. So I know the Fourier transform of 1. Sorry, I know the Fourier transform of del of t, that is simply 1. Right? So the Fourier transform of 1 would be okay. Oh, sorry. The Fourier transform of delta of t is 1 only, right? So the Fourier transform of delta of t is 1. So this is 1, right? Where? Now remember, where is this function? So this is essentially the Fourier transform of delta of t minus, so t plus 3. So this would be e raised to power j 3 omega into 1 simply, right? So I hope you know what is the shifting property. So and the Fourier transform of this would be what? So this is the Fourier transform of the signal 1, then Fourier transform of the signal 2, this is delta 2 into delta t minus 2, right? So 2 into delta t minus 2, the Fourier transform of this would be e raised to power j 2 omega into 2, and the Fourier transform of this, right, is again sampling. So you can do it, you will get the same answer. That's the homework assignment for you. Please do it and you will get the same answer. Okay, I applied the convolution property. Now this is a very interesting question, and unfortunately in the year of 2024 they had to give this as an MTA, because what they did, they simply forgot to provide a negative sign here. That's a very silly reason, but yes. So consider the two continuous time signals x of t and y of t. If x of f denote the Fourier transform of x of t, then what will be the Fourier transform of y of t? Okay. So I see that there are certain similarities between x of t and y of t. I see that okay. So this is my triangle, right? This is my triangle. Okay. So what do I need to do? First, if I multiply this by minus 1, then I will get this particular function, right? So multiplying x of t by minus 1, this will be minus of x of t. Okay. Minus of x of t. Okay. And then yeah, this will be minus of x of t, and I need to shift this on the right hand side by how much? By 0.5. Yes, if I shift this, so this is actually this function minus 1 to 0, and this is 0.5, and now I need to perform the shifting, correct? Now I need to perform the shifting by 0.5. So first we need to perform the shifting, then the scaling. Yes. So I need to take it and to delay it by 0.5. So this will be x of t minus 0.5. That the graph of for this would be this, right? I'm just simply delaying it by 0.5. So this will be minus 0.5 plus 0.5 and 0. That is minus of x of t minus 0.5, right? Now what I will do, I will scale. I will scale by what? I will scale my time axis to uh, t by 2. To t by 2 or what? Hold on a second. So if I scale my time axis to, what shall I scale? So this is my t, right? This is my t. I want to get to my yt. For getting back to yt, what do I need to do? So for this, I need to multiply by the time axis by what? By 4 actually. I need to multiply by the time axis by 4. So this will be x of. Do I need to multiply or divide? I need to multiply, right? If I multiply, sorry, I need to divide. This will be t by 4 minus 0.5. Why do you need to divide? So essentially, if I put t equals to 4, let's put t equals to 4, right? So at t equals to 4, or let's put t equals to 2. So at t equals to 2, what is the value? 0. So if I put here t equals to 2, this will be 2 by 4, that is 0.5. 0.5 minus 0.5, that is 0. So x of 0 is here 1. Okay, making a mistake. Okay. Not multiplying this by 4. certainly not multiplying this by 4. What do I need to multiply this by? If it is 0, right? Okay, if it is 0, okay, then there I'm making. So first I think I need to scale the axis. Yeah, sorry, first I think we need to scale. First we need to perform the scaling. So this is minus of xc, right? Then what I will do, I will expand the axis. So I see here the width is how much? Width is 4. Here how much is the width? It is only 1. So I will divide this time axis by 4, so that will increase the width, that will expand the width. So this will be t by 4, right? So I will expand the width now. So first actually you should not do shifting, and you can always verify by putting the values of t and whether whatever you have done is correct or not. So if I increase the width, that is equals to minus 4, 0, that is equals to 2. Now you shift this. Now you shift this x of minus t by 4 and you add a shift of minus 2. I think now we will get to our correct format, minus 2 plus 2. So let me check, right? Let me put the values over here. If I put t equals to 4, if I put t equals to 4, what will I get? This will be 1 minus 2, that is x of minus 1, and x of minus 1 is here, that is 0. So t equals to 4 is 0, certainly t equals to 4 is certainly 0. If I put t equals, sorry, t equals to 2 is certainly 0. What about t equals to 0? If I put t equals to 0, t equal to 0, what am I getting? T equal to 0, this will be minus of x of 0 minus 2, that is minus of x of minus 2. And what is x of minus 2? X of minus 2 is also 0. Okay, this is wrong. Okay, sorry. This will be shifted like this, right? T minus 2. Yeah, now I think it's correct because we'll change our t to t minus 2. Yeah. So you just verify whatever you have done, right? Verify whether you have properly written the function or not. Now let us put again the values. Let us put t equal to 0. If I put t equal to 0, this will be 0 minus 2 divided by 4, that is 1 by 2, minus 1 by 2, and minus 1 by 2 is somewhere here, right? That is equals to 1, correct? So t equals to 0, y of t should be 1, and if I put t equal to 0 in this expression, I am also getting 1. Now put t equals to 2. At t equals to 2, this will be x of 0, and x of 0 is 1. Let's put x t equals to minus 2. T equals to minus 2, this will be x of minus 1, and x of minus 1 again is 0. So hence this is the proper representation of my yt. So if you know any other methods, feel free to let me know in the comments below. I think there are few other methods, but you need to remember those things. If you remember, it's good. So this is the actual y of t in terms of x of t. Let me rewrite this bit properly. T by 4 minus 1 by 2. Okay. So if x of t has a Fourier transform of, I will not do x of f, I will do x of omega, okay, because I know properties with respect to x of omega. So if x of t has a Fourier transform of x of f, what will be the Fourier transform of y of t? So first I will do slowly. I will start from here. I will start from the left hand side. First I will shift. If I shift first, this will be x of t minus 1 by 2. So on the, sorry, let me do it in the omega domain, not in the f domain. So this will be simply multiplied by a complex exponential of j omega by 2, x of omega, correct? Now if I am performing the scaling operation, that is I am making t to t by 4. So if I am making t to t by 4, then on the omega domain, omega will be changed to 4 omega, and I will also divide by mod of a. Here what is your a? A is 1 by 4, right? Scaling factor is 1 by 4. So 1 divided by mod of 4 into e raised to power minus j 4 omega, 4 omega, right? 4 omega would be, this will be 2 omega x of 4 omega. So this would be equals to 4 e raised to power minus j2 omega x of 4 omega. Right. So this will be equals to uh, yeah, we got it. So yeah, yeah, now we just need to multiply by minus negative sign. So if I need to multiply, because I have to compute, then I have to take care of the negative sign. So negative sign, if I multiply, your answer would be minus 4 e raised to power minus j 2 omega x of 4 omega, right? Now replace your omega with f. So wherever there is, so inside x, you will always replace your omega directly with f. But whatever is outside x, bracket of x, right, that will replace with 2 pi f. So these thing also you need to remember. So this will be minus 4 e raised to power minus j, omega is 2 pi f, so this will be 4 pi f x of, now inside bracket you will replace omega with f, that's all. So this will be 4 f. Okay, so minus 4 into e raised to power minus j 4 pi f into x of 4f, right? So option B, option B is correct for this question. Again, uh, not super difficult, but you will have to go step by step. I was getting stuck here, right? So whenever you're getting stuck, go by basics. Okay, just put the value of t and check whether the functions are matching or not. So use your brain. So let's solve this question. I think this question also somewhat similar is in our test series. Consider the continuous time real valued signal f of t whose Fourier transform f of omega is this. Exist. Okay, Fourier transform exist. If Fourier transform exists, then certainly I can say that my function f of t is absolutely integrable. My function f of t is certainly absolutely integrable. Now what are they telling me? That magnitude of f of omega will be less than or equals to this. Okay, so is always true. So if I apply magnitude of f of omega, right, magnitude of f of omega on both sides in this equation, so this will be magnitude of the integration of f of t omega t dt, right? But yeah, now what is the important point here? The important point is you are first integrating, then you are calculating the magnitude. And you see in the second statement, they are first taking the mod and then they are integrating it. Which one will be greater? So once you take the mod inside, so what you are doing, you are first calculating this function, then you are integrating, and then you are taking the mod. That means this multiplication can be sometimes negative, can be sometimes positive, right? And then you're adding up the areas and overall you're calculating. But if you would have taken the mod of this function first, mod of this, right? What is the mod of this? So it is simply mod of f of t into mod of exponential, that is simply 1, e raised to minus j omega t, this mod is 1. So it is simply mod of f of t. Then actually first you would have changed the values, right? You would have made all of it positive because that is what mod means, absolute value. So all of this value, whatever was the negative, that also would have been positive, and positive would have remained positive. Now if we compute the area integration, if you add all these areas, that will be higher. So the point that I am coming to is my mod of f of t dt integration from minus infinity to plus infinity will always be greater than or equals to this value, this particular value, right? And this value is nothing but mod of f of omega. So this will be mod of f of omega. So mod of f of omega will be less than or equals to mod of f of t dt. So this is always true no matter what. So mod of f of omega will always be less than or equals to mod of f of t. This will always be true. So option A will be your correct answer for this question. Mod of f of omega will be greater than this? No. It will never be greater than, it can be equal to, but it can never be greater than this. Mod of f of omega is less than or equals to integration of from minus infinity to plus infinity f of t. No, again it is wrong, right? Because there is a mod function. You cannot comment about this. You cannot comment. This will not always be true. Here also this will be not, again you cannot comment. Is it greater or less? You cannot comment. But we can comment certainly regarding this statement. So option A will be your correct answer for this question. Let's solve this question. Let f of t be an even function. F of minus t is equals to f of t for all t. Let the Fourier transform of f of t be defined as f of omega this. Okay, we already know this. Suppose d f of omega by dw is minus omega f of omega. They have already given me all the properties. Okay, for all omega, and f of 0 is 1. Then they are asking me what is the value of the function at t equals to 0. So f of t is an even function. Okay, Fourier transform. Okay, differentiation of the Fourier transform is minus omega into f of omega. Okay. What is f of 0? So what I can comment is that my f of t is an even function, right? That is fine. So f of omega also will be an even function. Okay. So if f of t is an even function, f of omega also will be an even function. So you can say that your f of omega, okay, I cannot comment about this. Okay, let's not do that. Let's see what is my f of t. F of t would be integration 1 by 2 pi from minus infinity to plus infinity f of omega e raised to power plus j omega t d omega. Correct. So what is f of 0? F of 0 would be 1 by 2 pi into from minus infinity to plus infinity. This will be f of omega only, and this will be 0. So this will be d omega. So simply it is the area of my uh, f of omega. Correct. Now f of 0 is given to me, that is 1. So f of 0 is given. What does f of 0 means? So f of 0 basically means that this, if I put here omega equals to 0, what will happen? This will be the area of f of t from minus infinity to plus infinity, that is equals to 1. And I know f of t is an even function. So area from 0 to plus infinity of f of t is equals to 1 by 2. Correct, because it is an even function. So area from minus infinity to 0 and 0 to infinity will be simply 1, will be same. Okay, I know this particular relation. Will this help me anywhere? So area is half, A is positive. Okay, area is plus, area is half. Now how do I solve it? 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 Minus f of 0. F of 0 is this 1 by 2 pi. They are asking me about f of, okay, this particular thing is this minus infinity to plus infinity, t equal to 0. So okay, omega equals to this. How do I compute f of 0? Okay, also this particular relation is given. Okay, this relation is given. df of omega is j omega. Okay, I think we can use this. We can use this. So I see if I'm differentiating my f of omega, I'm getting minus omega into f of omega. So do we remember the differentiation property? So my f of omega is this, right? So if I differentiate here, what will happen actually? What will happen? If I differentiate, this will be, if I differentiate this equation with respect to omega, so I'm differentiating with respect to omega, so this minus jt will come here, right? Minus jt will come, correct, into f of t into e raised to power minus j omega t dt. So ultimately this is equals to minus omega f of omega, correct. I'm differentiating with respect to omega. I'm differentiating with respect to omega on both sides. So this will be minus jt. Yes. So minus minus will be cancelled certainly, and your omega into f of omega, right? Omega into f of omega will be equals to, from minus infinity to plus infinity, j t f of t e raised to power minus j omega t. Will this help me anywhere? I'm just thinking about that. Let me think. Let me think a bit. This information is given to me, right? Can I use this information anywhere else? Uh okay, I can solve the differential equation here, right? So I can actually compute the f of omega from here. I think yes. So what is my f of omega? So d, let me solve this. D f of omega upon omega is equals to minus omega into f of omega. So this, if I want to solve, right, this will be d of f of omega upon omega is equals to, sorry, d of f of omega upon f of omega. If I integrate this, this will be equals to minus omega to t omega. So this will be ln of f of omega, that is equals to minus omega square by 2. So your f of omega actually equals to e raised to power minus omega square by 2. Okay, yes. So we got our f of omega. Cool, we got our f of omega. Now yeah, now I think we are on to something. So if you remember this property, e raised to power minus pi t square, the area, correct, area is simply 1. The area of e raised to power minus pi t square, this area is 1. Okay, this can be derived from the property that e raised to power pi t square has a frequency domain expression of omega by 2 pi whole square, right? And if I put omega equals to 0, this will be 1, right? So that's why the area property holds here. So yeah, this is 1, correct? So actually, yeah, if it is a Gaussian function, right? If it is a Gaussian function, the other part also will be Gaussian, but certainly there will be some coefficients, because I know this property. So I know this property that e raised to power minus pi t square, the Fourier transform is e raised to power minus pi omega square by 2 pi, but omega by 2 pi whole square. But here I see I have omega by, this is basically e raised to power minus omega by under root 2 whole square, right? So I will have to perform some scaling. So what kind of scaling I will have to perform? That would be, I will have to change omega by, so if I write this properly, right? If I write this properly, this will be yeah, let me keep it as it is. No, this is actually what? This is actually minus omega square by 4 pi. Okay, and this is actually what? This is minus omega square by 2. So what kind of scaling I will have to perform? So let's write this as omega has been performed with the scaling of a omega, right? So a square omega square by 4 pi minus should be equals to this particular term, right? Minus omega square by 2. So the scaling that I need to perform would be a will be equals to, this will be 2 and this will be pi. So under root 2 pi. That is the scaling that I need to perform. A is equals to under root 2 pi. Cool. A equals to under root 2 pi. Right. So yeah, A is equals to under root 2 pi. So if I perform a scaling of A equals to under root 2 pi here, what will happen? So just the inverse, right? So if I am changing my omega to a omega here, then the t will be replaced by t by a, and there will be a okay, let me think for a second. In time domain, right? You have to think. So what happens if I replace my t with at? So then in the frequency domain it is omega by a and 1 by a, correct? So if I'm dividing by a, then here I will multiply. So if I just take this a on the other side, right, mod of a on the other side, okay, I am taking the mod of a on the other side. So if I'm scaling, so what is the Fourier transform of x of at? It is this, correct? Don't do anything, just take this mod of a on this side. So actually mod of a into x of at, the Fourier transform is x of omega by a. So if I am dividing by a, right, so I will have to multiply by mod of a and I will have to multiply by a in the time t of the x bracket. So if I am multiplying by a, if I am multiplying by a in the frequency domain, I will have to divide by a in the time domain from t. So it will be e raised to power minus pi t upon under root 2 pi whole square, and also I will have to, so if I am multiplying here, right, it is getting multiplied, so I will have to divide by 1 by a, that's all. So you can, like, you can derive these properties, but I think it should not be that difficult. So ultimately, right, you will have to compute at t equal to 0. At t equal to 0 it will be 1 by under root 2 pi, which is less than, certainly which is less than 1. So option A is certainly correct. Okay, option A is certainly correct, which will be less than 1. If you can think of okay, there is one more way to solve this without all this scaling, right? But I think no, you will need to do some of it. You will need to do some scaling. You need to do some scaling. Okay. Yeah, I think that's how you solve it. So just use some properties and you will be able to figure this out. So use your brain. Don't just see my solution. Use your brain, because ultimately in the exam hall you will have to solve it, not me, right? So use your brain. Think what properties can you use. Derive these properties, right? I'm deriving. So this property is not a standard property, right? This is. Then I multiply by mod of a and then I made my own property. So use all these things in the exam hall. So option A will be correct for this question. Let's solve this question. Consider a continuous time signal x of t defined by x of t equals to 0 for mod of t greater than 1. So consider a continuous time signal x of t is defined by x of t equal to 0 for mod of t greater than 1. Okay, so basically the signal exists only between these points. It is nothing but a triangular signal, right, where t is changing from -1 to +1. Okay, it is 0 otherwise. Let the Fourier transform be this. So they are asking me the maximum magnitude of x of omega. So what is the Fourier transform of this particular signal? Maximum magnitude, they are asking me the maximum magnitude, right? Fourier transform of this. So this is simply triangular of t upon tau. And what is the Fourier transform of triangular of t upon tau? It is basically tau sampling of square omega tau by 2, right? So simply what will be the maximum magnitude? Maximum magnitude will occur at omega equals to 0 when this sampling function will be 1, right? At omega equals to 0 it is nothing but tau. What is tau? Tau is the half width, that is simply 1. So 1 is your answer. Okay, 1 is your answer. So all you need to do is remember the formula and you're good to go. So 1 is your answer. Let's solve the next question. This is the next question. So input is this sinusoid cosinusoid and it is passed through LTI system having filter response this, right? And again it is exact carbon copy ditto same question. Output of the system shall be, what is the output of the system? So of course here, right, what you can do is you actually don't need to exactly compute the coefficients. You can just take bit of intuition because options are given here, right? Options are given and here there are multiple frequency components, so you don't need to worry. So what is this? Do you remember what is this? So if you again are forgetting, no problem, derive it from basics. Okay, derive it from basics. So this is simply sampling. So this is not even sampling squared, this is simply sampling of t, right? So I will multiply and divide by 10. If I multiply and divide by 10, this will be sampling of 10 pi t, right? Multiplying and dividing by 10. So this will be converted into 10 sampling of 10 pi t, and 2 is already there at the starting. 2 into this, I will come into that. So let this will be 20 sampling of 10 pi t. Okay, ignoring the cos 40 t for now. Ignoring the cos 40 t for now. What is the Fourier transform of this? So it is simply, okay, I know the Fourier transform of a rect of t upon tau, that is a sampling of omega tau by 2. A tau will be there, sorry. A tau sampling of omega tau by 2. Okay. So now what can you do? A tau. So this would be equals to, yeah, now I can apply the duality again. So this will be A tau sampling of t tau by 2. This would be a rect of omega by tau. So this would be this. Okay. So yep. Yeah. What is the answer here? What is the answer? Yeah. So sorry, I have to multiply by 2 pi as well. So sometimes I go into some other Zen mode. So we'll have to multiply by 2 pi. So if 2 pi is multiplied, then what will happen here? 2 pi is multiplied, then yeah. But we will have to compute this, right? 20 sampling of 10 pi t. So from here I can directly see what is my tau by 2. Tau by 2 is simply 10 pi, right? So my tau is actually equals to 20 pi. So in frequency domain, the width, right, is 20 pi, that is 10 pi on the left hand side, 10 pi on the right hand side. I got my tau. Now what about your this? So 2 pi will be multiplied with a. So what is my a? If you see, what is your a tau? So a tau actually is equals to a into tau is actually equals to 20. Correct? So tau is 20 pi. So your a would be 1 by pi. So a is 1 by pi. If I multiply by 1 by pi, this will be 2. So the height of this rectangular pulse is 2. Okay. Now what you're doing, you're simply multiplying by cos 40t, and this I have already explained in one of the previous question. If I'm multiplying by cos, right, the frequency domain Fourier transform will be just shifted by how much? By 40 pi on the right hand side and 40 pi on the left hand side, and the magnitude will be multiplied by half. So this will be 40 pi shifted on the right hand side. So this will be 50 pi minus, sorry, this will be 30 pi. This will be 1. Okay, and this is half, right? This half. So yeah, that's how we solve it. We got our h of omega. Now what you need to do is just need to pass all these components. So 2 sine 10 pi t. So 10 pi, will it be passed? No. If I see in 10 pi, it is again a question of eigenfunctions. Already has been discussed in the previous question. So 10 pi is not, it is 0. So my h of omega is non-zero between 30 pi to 50 pi. So whatever are the frequency components between 30 pi to 50 pi, those will be passed like this and this. So 42 pi and 45 pi will be certainly passed. So option C will be certainly correct. Okay, you can exactly compute the magnitudes as well, because magnitude is 1, so simply it will be scaled by 1, so it will be 7 sine 42 pi t and 4 cos 45 t. You can see magnitudes are also matching, so we have solved exactly everything correctly. So if you don't remember, if you remember the least kind of things, still you can solve this question. I do agree, if you remember everything, this will not be taking you more than 1 minute, but that's the problem, you will not be able to remember every single thing. You remember this part and then you use duality and then solve. It's fine, it will take you time, it's fine, you will save time in other questions. Let's solve this question. The Fourier transform of x of omega of the signal x of t is given by this, right? It is nothing but a rect function. Fourier transform is nothing but a rect function. Again, if it's a rect function, we know in the time domain it will be a sampling function, right? So minus omega naught, not omega, so minus w naught to w plus w naught, it is 1 and rest it is 0. So x of t tends to an impulse as omega tends to infinity? No. If I know the inverse Fourier transform, it is a sampling, right? We have a basic idea, it will be a sampling function, correct? So as, okay, hold on. Yeah, I think it makes sense. So if it is telling me that as omega naught tends to infinity, right? If omega naught is tending to infinity, this is simply 1. And which function has a Fourier transform of 1? Impulse. Delta of t has a Fourier transform of 1. So simply yes, this statement is correct. A statement is correct. X of 0 decreases as omega naught increases. If omega naught increases, x of 0 x of 0 decreases as omega naught increases. This statement, sorry, as omega naught increases. As omega naught increases, x of 0 will decrease. This statement is wrong, right? Because if I increase w naught, right, what is happening? My time domain signal is getting to impulse, right? So this value is increasing. So x of 0 will increase as w naught increases. So this statement is wrong because it contradicts the first statement. If w naught goes to infinity, my time domain signal is an impulse. So whose magnitude at t equal to 0 is infinity. So magnitude should increase at t equal to 0, not decrease if my w naught is increasing. At t equals to pi by 2 omega naught, x of t is minus 1 by pi. So for this you will have to actually calculate. Okay, so yeah, we know that a rect of t upon tau has a Fourier transform of e tau sampling of omega tau by 2. Now its dual will have a tau sampling of t tau by 2, and this will be 2 pi a tau, sorry, not sampling, sorry, 2 pi into a into rect of omega upon tau. So in our case, our 2 pi a, our tau is what? Tau is w naught. So tau is 2 w naught, right? Tau is 2 w naught because that is the width, 2 w naught, and our 2 pi a is basically 1. 2 pi a is 1. So a is equals to 1 by 2 pi. So the time domain signal would be 1 by 2 pi. So a tau is w naught by pi sampling of t w naught. That's it. Okay, and they are asking me the value at t equals to plus 1 by pi and minus 1 by pi. So as it is an even function, it won't matter. So both will be same. Let us compute. So sorry, they're asking me t at t equals to pi by 2 omega naught. So t equals to pi by not 2 omega naught, sorry, pi by 2 w naught. So at t equals to pi by 2 w naught, this would be w naught by pi sampling of pi by 2 w naught, that is pi by 2. A sampling of pi by 2 is basically sine of pi by 2 by pi by 2. Sine of pi by 2 is 1. So this is basically w naught by pi into sine of pi by 2, that is 1 by pi by 2, right? So this will be, okay, sine of pi by 2 by pi by 2, that is something else. Hold on. So 2 pi into a, 2 pi into is this, so a is 1 by 2 pi. Okay, great. Tau is 2 w naught, tau is 2 w naught is 1 by 2 pi. That actually is equals to 2 w naught by pi square. Okay, so it is 2 w naught by pi square. Am I correct? Just give me 1 second. So at t equals to, oh sorry, t equals to pi by 2 w naught, not pi by 2, sorry, pi by 2 w naught. So yeah, pi by 2 w naught will be, hold on a second. 2 w naught by pi square. It will be 2 w naught by pi square. Yes. Oh no, sorry, sine of this. So sorry, t equals to pi by 2 w naught, right? So w naught will be cancelled. It will be sampling of pi by 2, that is this. Yeah, that is correct. So it is 2 w naught by pi square, which is again incorrect. So because they have given me that it is 1 by pi, which is wrong. 1 by pi is not correct. I'm just trying to think whether I'm making any other silly mistake here. So actually this a can be cancelled, right? This a cannot be, okay, this a does not need to be there, right? Okay, this a can be cancelled if it is, so this will be actually only 2 pi into this. So, and it is rect of omega upon t, so this 2 pi can be divided here. Yes, so actually this will be simplified. So tau is 2 omega naught or 2 w naught, yeah, tau is 2 w naught, yeah, that is fine. Okay, 2 w naught, yeah, tau is 2 w naught, right? So 2 will be cancelled, this will be t into w naught. Okay, sampling of, so this would be pi upon 2 w naught will be cancelled. Yes, yeah, this is fine. So this will be 2 w naught by pi square, so which is not correct. So option A is only our correct answer. Yeah, let x of omega be the Fourier transform of the signal this. The value of the derivative of x of omega at omega equal to 0 would be, what is the value of the derivative of x of omega at omega equal to 0? So basically they are asking me dx of omega upon d omega equals to 0, right? So yeah, so if I'm differentiating in omega domain, what happens in time domain? There is a multiplication by t, correct? So how can you derive it? So we know what is x of omega. X of omega is equals to integration from minus infinity to plus infinity x of t e raised to power, because I have t in brackets, so here I will have minus j n omega t dt. Okay, that's why if you have t in brackets, this will be minus. This, I think, if you have studied the lectures, you will remember it. So this will be, now if I differentiate this with respect to omega on both sides, what will happen? Simply, not n, sorry, n will not be there, sorry, n will not be there, right? So simply what will happen, this omega will, this t will come in front, minus jt will come in front. So your signal will be multiplied by minus j into t, okay, minus j into t, that's all. In the time domain, your signal will be multiplied by minus j into t in the time domain, okay. Yes, so I am differentiating by omega on both sides, so this will be d of x of omega upon omega would be equals to integration of minus to plus. I'm differentiating with omega, these are all independent, right? So this is the only term that I'm concerned about, so that would be equals to minus j omega. So I'm differentiating with respect to omega, this will be xt, this will be t into e raised to power minus j omega t dt, correct? Now I need to compute this value at omega equals to 0, right? Omega equal to 0. So let me put omega equals to 0. If I put omega equals to 0, this value will be minus j into t x of t dt omega is 0, right? So I'm integrating from minus infinity to plus infinity. Okay, now this is a odd function. T is an odd function. Xt, what is xt? Xt, if you see, is an even function. So multiplying an odd function and even function, ultimately I will get a odd function. This will be odd and this will be even. So multiplying an odd and even, you will always get a odd function. Take an example. T is a odd function, t square is an even function. Multiply these two, you will get a odd function. So integration from minus infinity to plus infinity of an odd function is 0. So your answer is simply 0. Okay, not that difficult, but you need to understand these things. Okay, otherwise you will be totally blank. How will you solve this? You will directly solve this? Yes, you can solve this, but it will take you huge amount of time if you don't know how to apply the properties. So make sure you are applying the properties. Okay, so this is the last question of Fourier transform, where we have been given an ideal low pass filter whose frequency response is given by this. Okay, ideal low pass filter whose frequency response is given by this. H of j omega is equals to 1 0 magnitude of this. So it is nothing but again a rect function. So rect function will be used everywhere else. So make sure you remember the properties of rect function. It is one. Let h of t be its time domain expression, then h of 0. H of 0 is nothing. So h of t is what? H of t is basically 1 by 2 pi integration of minus 2 infinity to plus infinity x, or h of omega e raised to power this will be plus, because I have brackets in omega, this will be plus. So this will be plus j omega t d omega. Okay, now if you put omega equal to 0, that will give you h of 0, sorry, not omega. If you put unit h of 0, that is t equal to 0. If you put t equal to 0, that is nothing but the area of h of omega d omega divided by 2 pi. How to remember? 2 pi will come because I have d omega here. That's how you remember 2 pi will come. So make sure you watch the whole lecture. Every point I have said you something that will help you in remembering the formulas. So this will be 1 by 2 pi, this will be d omega. Hence, if I compute the area, of this thing, right, and divide by 2 pi, I will get my answer. So what is the area? Area is simply 400 pi, and if I divide by 2 pi, that would be 200. So your answer is 200. Okay, 200 is your answer for the question. So with that, we are done with Fourier transform. Now let's begin with Laplace transform. Let's begin with Laplace transform. So this is the first question. Input is given, output is given of an LTI system are related by the differential equation. If the system is neither causal nor stable, okay, it is neither causal nor stable, then the impulse response shall be what? Okay, so first of all, we will solve this in Laplace domain. So if I solve this in Laplace domain, we know that y double dash of t will be converted into s square of y of s, and of course we don't have any, so this is bilateral Laplace transform, right? And we don't have any initial condition, so we will do the bilateral Laplace transform. If it was unilateral, then the Laplace transform of y double dash of t would have been s square into y of s minus s into y of 0 and minus, sorry, into y dash of 0 minus y double dash of 0. Okay, that is the formula, right? If it was unilateral Laplace transform, but as all these are like we are doing bilateral, so we will directly convert this into s square into y of s, then minus s into y of s minus 6 into y of s, that is equals to x of s, right? That is equals to x of s. And if I compute, so they are asking me the impulse response, so that is nothing but y of s upon h of s, y of s upon, sorry, x of s that is h of s, right? That is equals to 1 upon s square minus s minus 6, right? Now this will be equals to 1 by s minus 3 into s plus 2. So yeah, now I can do partial fraction. So at s equals to 3, it is basically 1 by 5 s minus 3, and s equals to minus 2, this is minus 1 by 5 s plus 2. Now they have told me that it is neither causal nor stable. Okay, it is not causal. So how can I identify? So how can I take the inverse Laplace? Inverse Laplace can be taken according to the ROC. So if I draw the ROC, right? So I see I have a pole at s equals to 3 and s equals to minus 2. So s equals to 3, I have a pole. Sorry, s equals to, hold on a second, hold on. S equals to minus 2, I have a pole, and at s equals to 3, I have a pole, right? Now they are telling me it is not causal. If it is not causal, certainly my ROC will be left sided. It will not be right sided, right? It can only be causal if my ROC was right sided, that is greater than s equals to 3, right? If it is not causal, it will be less than, like it will be left sided, right? ROC will be left sided. Okay, if it is not causal. Now it is not stable. So there are two possibilities. Either my ROC can lie in this region, or my ROC can lie in this region. It is not stable, that means it shall not include the j omega axis. If it shall not include the j omega axis, my ROC should be here. ROC should be here, lying on the left hand side. So my ROC would be real of s less than minus 2. That is my ROC. Okay. So if that is my ROC, then of course I will have to take the Laplace inverse for both of these signals as left hand side signals, right? Left hand side signals, left sided signals. Okay, the Laplace inverse should be for both of them should be left sided signals. So what is the left sided Laplace inverse of this particular term? So 1 by 5 is just constant. The right sided term is, it is actually e raised to power 3t u of t, correct? It is e raised to power 3t of u of t. What is the left sided? For left sided, all you have to do is just change the sign of t inside the u function as minus t and put a negative sign at the starting. Okay, that is all what you need to do. If you want to understand it more, so you can understand it like this. So let's say your e raised to power at into ut had a Laplace transform of 1 by s plus a, correct? And its ROC was real of s greater than a, right sided Laplace transform. Now I want to compute the left sided Laplace transform, right? So basically we know this property. What property? That if our x of t is replaced with hold on a second, to compute the left sided Laplace transform, right? X of minus s, so x of s, then x of minus t shall be x of minus s, correct? But okay, this property will not help. Let us compute the Laplace transform of this e raised to power at u of minus t, correct? What will be the Laplace transform of this? So how do I compute the Laplace transform? It is very easy, right? So x of s is actually equals to integration of x of t minus infinity to plus infinity e raised to power minus st dt, correct? Now it is a left sided signal. If it is a left sided signal, what will happen? This will be minus infinity to 0. X of t will be replaced with this value. It is u of minus t, that is why I am integrating from minus infinity to 0. This will be e raised to power at e raised to power minus st dt. This will be equals to minus infinity to 0. This will be a of minus t s dt. So this shall be equals to 1 by a minus s, right? That will be there in the constants, and we will have to put the values. Basically it will be e raised to power 0 minus e raised to power minus infinity. So it is basically 1 only. This is 1, right? So actually this is minus of 1 by s minus a. Okay, so here Okay, sorry, this is s minus a, right? I was sorry, this is minus a. So you are getting basically negative. You are getting basically negative of whatever you are getting here, right? So simply this, right, will be basically the left sided Laplace transform will be minus of 1 minus s by a. That's all. Okay. So yeah, this thing you will have to remember. If you are computing the left sided Laplace transform, you will have to multiply by a minus sign. That's all. Everything else will be same. Okay. Everything else. So simply this u of minus t, this will be, this minus sign will be accounted here. That's all. Right? Yeah. So I was following some other property. This is the property that I was talking about. So now you can replace. So the inverse Laplace transform would be, this will be same, e raised to power 3t, and this will be u of minus t, and a additional negative sign will be connected here, right? Similarly, this is also like ROC is less than s minus 2, right? So ROC is less than this. So for this also I will have to compute the left sided Laplace inverse. So left sided Laplace inverse would be, minus sign is already there, minus 1 by 5. Another negative sign will be there because I am computing the left sided Laplace transform into u of minus t. Sorry, first I will multiply e raised to power, this is s plus 2, right? So right sided Laplace transform is e raised to power minus 2t. So that will be there. Just instead of u of t, I will write u of minus t. Okay, that is the difference. Again, here is a negative sign, two negative signs I have. So negative negative is 1. Three t, 2t minus t. Okay, so yeah, that is the case. So I see minus 1 by 3 e raised to power 3t, minus 1 by 5 e raised to power 3t, u of minus t, 1 by 5 e raised to power minus 2t, 1 by 5 e raised to power minus 2t, u of, this also shall be u of minus t. U of minus t is present here in this option B. So option B is certainly correct for this particular question. So multiple things are revised here. One thing is how to compute the Laplace transform of a LTI system, like if it is in the differential format. Then how to compute the ROC, right? If some information is given, it is neither causal nor stable. Not stable, it will not include the geometric axis. Neither causal, that means your Laplace ROC will always be going towards the left. It will not go towards the right. Okay. How can it be causal here? It can be causal only if my ROC is greater than s equals to 3. Then only this will be a causal signal. Otherwise, this will be a non-causal or anti-causal signal. Again, it is not stable, so ROC should not include geometric axis. So only this is the possible condition that will satisfy both these conditions. And if I know the ROC, then that means I know that for this both these signals, I will have to take the inverse Laplace with respect to left-sided signals. Now, what is the Laplace transform of left-sided signals? If you ever forget it, write the Laplace transform of right-sided signal, then derive it for the left-sided signal. You see that it is same as the right-sided signal, just the difference being there is an additional negative sign. So okay, you remembered, okay, there was a negative sign, so negative sign will be there. Then I just had taken the Laplace transform, inverse Laplace transform. Okay, so many things are here. There are so many things because we are not remembering every single thing, right? We are not remembering every single formula. That's why it feels like there are so many things, but also you don't have to remember the formulas, right? That is the advantage. Here. Okay, let's solve the next question. This is the next question. Like it will take you more time, but you will have to remember less. So you will have to give up on something. Let x of t be equals to alpha into s of t plus alpha into s of minus t. S of t is this, u of t is unit step function. If the bilateral Laplace transform of x of t is this, right, and its ROC is this, the value of beta. So it's very simple actually. So all they are asking me, what is my x of t? X of t is actually alpha into beta e raised to power minus 4t into ut plus beta into e raised to power plus 4t into u of minus t. Okay. So I will compute the right sided Laplace transform of this particular signal, right? What is this? This is simply alpha beta. This will be 1 upon s plus 4. Okay. And this is simply beta 1 upon s minus 4 if I would have computed the right sided Laplace transform. But as I am computing the left sided Laplace transform, there will be an additional negative sign. That's all. Okay. Now, what is the ROC? So I have two poles, one at s equals to 4, one at s equals to minus 4. So ROC is given to me, right? ROC is between minus 4 to plus 4. So ROC is somewhere here. So of course system is stable and it is lying somewhere here. Okay. Now, so I can take beta common. This will be alpha into s minus 4 minus s minus 4 divided by s square minus 16, correct? So this numerator will be equals to 16 and there should not be any term of s, right? So what alpha needs to be? Alpha can be 1, right? Alpha has to be 1 if I don't want any s term in the numerator, right? Alpha has to be 1, and if alpha is 1, this will be cancelled. This will be minus 8. Minus 8 into beta, minus 8 beta must be equals to 16. So beta must be equals to minus 2. So minus 2 shall be your answer for the question. Let's solve the next question. This is the next question. Let the signal f of t equals to 0 outside the interval t1 t2. So f of t is 0 outside the interval t1 t2. So let's say this is t2, this is t1. It is 0 always outside this interval and it is non-zero here, correct? Where t1 and t2 are finite. Okay, t1 and t2 are finite. Furthermore, magnitude of t, f of t, is less than infinity. Okay, the region of convergence ROC of the signal's bilateral Laplace transform f of s is what? Okay, magnitude is less than infinity. That basically means that the signal is absolutely integrable. The signal is absolutely integrable. So what shall be the ROC of a bilateral Laplace transform? So it is a finite duration signal, right? If it is a finite duration signal, the ROC would be entire S-plane. And it is stable, right? If it is absolutely stable, of course it will be entire S-plane and it will include the j omega axis. Okay, it will not be a parallel step. It will not be a parallel step for a finite duration signal, the ROC, and for a finite duration finite amplitude signal, ROC is always entire S-plane. Finite duration finite amplitude signal, ROC is always entire S-plane. Let's solve the next question. By performing cascading or summing slash differencing operations using transfer function blocks g1 of s and g2 of s, one cannot realize a transfer function of the form what? G1 of s into g2 of s. It is simply cascading, right? G1 of s divided by g2 of s. Okay, this is interesting. G1 of s into 1 by g1 of s plus g2 of s, g1 of s into 1 by g1 of s in minus g2 of s, which cannot be, we will not be able to realize. They're asking, cannot realize a function in the form of this. Okay, g1 into g2 of s is certainly realizable because we can simply cascade, right? Cascading, yes, we can simply cascade these two and we can get this. These transfer function also can be, so basically, right, if I am cascading two blocks g1 of s and g2 of s, then the first transfer function is totally possible. This is not my answer then certainly. What about this one? This one, if I simplify it further, this will be 1 plus g1 into g2 of s, right? So what I can do is I can keep this as in the summing amplifier, and also I can take the same signal I can add a adder over here, right? So what will happen? This will have a gain of 1. This is my x of s, right? This will have a gain of 1 x of s plus whatever this transfer function, and that will give me this value. So this is nothing but this particular block diagram. Okay, not explaining too much, but I think it is self-explanatory. This one is the same. Instead of adding, I am subtracting. That's all. This block is same. Here, if you compute what is your y of s, you will see your y of s will be g1 into g2 of s into x plus x. That's all. And if you take the x of s constant, that will be your transfer function, right? If I want to subtract, I will add a minus sign. So all these can be constructed. Only option B cannot be constructed, right? Because it is in inverse, and I don't know how to get 1 by g2 of s. I don't know how to form 1 by g2 of s. You will have to take an inverse block. That is not possible. So with this, option B is correct. Let's move on to the next question. So this is the next question. The Laplace transform of a causal periodic square wave t is given, shown below, right? In the figure below, f of s is this. Okay, what is my f of s? So it is a periodic square wave, right? Square wave with period t. So after every t, it will repeat. So just simply solve it. Simply solve it. How to simply solve it? So what we know? Let's compute only this signal. Let's take a signal fp of t, right, which is an finite duration signal which has 50% duty cycle. So this will be t by 2, this will be t, this will be 1, this will be 0, this will be 3t by 2, this will be 2t. Okay, right? So yeah, we got this value. This is my t. Now, no. Yeah. Oh, sorry. Why am I repeating it? Sorry. We should not. We should only consider till t, right? Yeah. Sorry. Yeah, till t. Okay, till t. Now, how can I form it? How can this be formed? So here, what is the Laplace transform of this? If I, let's say, if this has a Laplace transform of f of s, right? Then essentially, what is this? This part. It is nothing but f of t only shifted by. So this is nothing but f of pt shifted by a period t, right? Again, what is this? This is nothing but f of pt only shifted by a period of 2t. So essentially, my f of t is sum of all these signals. All of them are shifted by 2t. It is a causal signal. Remember, it is a causal signal. Okay, so it starts from this point, fp of t. That's all. Okay, so this is my f of t, right? So what will be the Laplace transform? F of s. It will be fp of s plus fp of s into e raised to power of st plus fp of s into e raised to power of 2st and so on. Just give me a second. Yeah, and so on, right? So ultimately this forms a gp. This will be equals to fp of s into, this is a sum of infinite gp. Okay, sorry, this is not plus, right? This is minus. Sorry, this is minus, not plus. Sorry, minus. Okay, because it is delayed, not advanced, delayed. So this will be initial term, that is 1 divided by 1 minus the common ratio, that is e raised to power minus st. So ultimately we will just compute the Laplace transform of this much part, and then we will multiply it by 1 by e raised to power minus st, and we will get to our answer. I see only this one and this one has 1 by e raised to power minus t term. So only C or D can be correct, but let's verify it. What is my fp of s, right? What will be my fp of s? So simply, right, it is 1 from 0 to t by 2 and it is 0 otherwise. So we will compute this. It is 1. So I hope you know how to compute the Laplace transform. From 0 to t by 2 I will compute this integration e raised to power st. Sorry, e raised to power st, yeah, e raised to power st dt, correct? Because actually the integration is from minus infinity to plus infinity, but my signal is only present from 0 to t by 2, capital T by 2, that's why. Otherwise it is 0. So this will be equals to 1 by s will be there, and this will be e raised to power uh okay, hold on a second, sorry, here I have t, so this will be minus t. So I hope you remember this formula. X of s would be integration from minus infinity to plus infinity x of t e raised to power minus st dt. Because I have bracket t here, right, this will be a negative sign. And anyways, you know, we multiply something with x of t to make it absolutely integrable. That's why it has to be something negative. Okay, yeah. So this will be actually minus of s, 1 by minus of s. St by 2. Actually now it seems like there might not be a term in the denominator. Okay, so yeah, we may have been wrong. So actually it is not correct that only c and d can be correct. Actually these can also be correct, so be careful. So this is my f p of s. So my f of s would be this value multiplied by 1 minus e raised to power minus st, correct? So that would be equals to e raised to power minus st by 2, 1 plus e raised to power minus st by 2, right? So this will be, this can be cancelled, right? 1 by s, 1 plus e raised to power minus st by 2. Okay, so yeah, this will be the answer. 1 by s, 1 plus e raised to power, so that is present here. Okay, so option B actually will be correct. I was wrong initially. Okay, so option I, hold on, sorry, this will be minus st by 2. What I have, yeah, this is minus only, right? This is minus. So yeah, option B will be correct for this particular question. Let's solve the next one. So this is the next question. A low pass first order low pass filter of time constant capital T is excited with different input signals with zero initial conditions at t up to t equal to 0, right? Okay, zero initial conditions, low pass filter of time constant capital T. So first order low pass filter, right? So for a first order low pass filter, the frequency response is somewhat like this. Okay, if the time constant is t, so the frequency would be 1 by t. Beyond 1 by t, it will not pass any filters. Okay, so first order low pass filter, first order low pass filter. So the low pass filter has these kind of uh, first order low pass filter is something like this, right? 1 plus s tau or st, and where t is the time constant. Basically this is the transfer function of a first order low pass filter. So yeah, I think this is about it. Now what are they asking me? They're asking me initial conditions are 0, match the excitation signals with the corresponding time responses. So if impulse response, if impulse is provided, right, if the input is impulse, what will be the response? That is what they're asking. If the impulse is provided, this will be my response, right, which is, this is my h of s, so the Laplace inverse would be my response, that is h of t. So what is the Laplace inverse? This will be 1 by t, so I can take this as common. 1 by t I can take common, right, or t I can take common, that is s plus 1 by t. So this will be 1 by t e raised to power minus t upon capital T u of t. Okay. uh, okay, it may happen that this term is not same. Okay, so what is the response? If I am providing an impulse, it will be in this format, e raised to power minus t upon t into u of t, that I see here. Okay, you might say, where is this 1 by t term, sir? Maybe they are assuming that the DC gain of my transfer function is capital T. Okay, so this is what they are assuming. I had not assumed that. If I assume the DC gain to be capital T, then this will be in proper format, e raised to power minus t upon capital T into u of t, right? So your x will be in the form of r. Okay, x will be in the form of r. Now you might ask, sir, how will we know? Sir, how will we know that 1 by t will not be present? Do you see anywhere else e raised to power minus t upon t like this term present? No. You see here only it is present, right? It is present with 1. Now it is natural, right? If you know that this is the only possible solution, so of course you will try to change your transfer function so that we match it, right? So here, because DC gain is not given, so we have to assume some DC gain. So I assumed a DC gain of t, then it worked, then this properly matched. So certainly x will be pointing towards r. Unit step, if I am providing a unit step, its response will be simply integration of the impulse response. If I integrate this, right, if I integrate this, this will be integration from 0 to t e raised to power minus t upon t. Actually it is from minus infinity to t, but as u of t is multiplied, it won't matter. So this will be multiplied by t again, multiply by, so multiply by t, negative sign, this will be 1 e raised to power, okay, multiply, this will be e raised to power minus t. So again t is there, 1 minus e raised to power minus t upon t. Again I see that this is not in the proper format, right? This is not in the proper format, because there should be a 1 by t term that is not there. Just hold on, this, I'm taking t common from here. That's correct. That's correct. Okay. So yeah, so again, like the, not in proper format, but we can see that I'm getting this term, and this term is present over here in B. So this will be certainly correct, right? And again for unit ramp, it will be this one, right? Why? Although I feel like, okay, few terms are missing over here. So simply for unit ramp, where we have to again integrate this. If I integrate this, there will be some t term. I think there is some plus minus term missing. I can see that actually. So it will be in the form of this. Okay, so like you will simply have to integrate this one again. If you integrate this one again, you will get your ramp response. So our x is pointing towards r, y is pointing towards q. No, x is pointing towards r, y is pointing towards p, and z is pointing towards q. So your option C is correct for this question. I do agree there are few signs missing over here, but don't worry, like you know how to do this now, right? For ramp response, you will simply integrate this function with respect to t. That's all, right? Yes. Yeah. Now let's move on to the next question. This is the next question. The output response of the system is denoted as y of t, and its Laplace transform is this. The steady state value of the y of t is. Simply you will have to apply the final value theorem. You see all options are finite, right? So you don't have to worry whether the final value theorem is applicable or not. It is applicable because all options are finite. So don't worry, blindly apply the final value theorem. Limit as s tends to 0, s into y of s, that is equals to, if I multiply this by s, this will be 10 divided by s square plus s plus 100 root 2. So s, as s tends to 0, this will be 10 upon 0 upon 100 root 2. This is simply 1 by 10 root 2. So 1 by 10 root 2 is option A. So option A will be correct for this question. Let's now solve the next question. The inverse Laplace transform of h of s is equals to this is what? For t greater than equals to 0. Like basically they are asking me the causal inverse Laplace. So this, right? Let's break this down. So it is s plus 3 upon s plus 1 whole square, correct? So this can be broken down. Okay, let us break this down. A by s plus 1 whole square plus b by s plus 1. Okay, b by s plus 1. Okay, now yeah, if I solve this, this will be s plus 3 a into a plus b into s plus 1. Okay, so just give me 1 second. Yeah, b into s plus 1, that would be equals to, so equating the coefficients of s, so b will be equals to 1, certainly b will be equals to 1, and your a plus b shall be equals to 3, right? Because the coefficient of s raised to power 0 is a plus b, so your a will be equals to 2. So actually this will be 2 upon s plus 1 whole square plus 1 by s plus 1. So this shall be equals to, if I take the inverse Laplace, this will be simple, this will be e raised to power of minus t u of t, right? What about this one? So this one, right, if you remember the differentiation property in Laplace domain, right, if I multiply by t in time domain, then there will be a differentiation property in Laplace domain, that will be minus dds of x of s. Okay, how do you remember this property? Again, derive. So you know this thing, right? So you know x of s is equals to x of t into e raised to power minus st dt minus infinity to plus infinity. So now you differentiate with respect to s on both sides. If I differentiate with respect to s on both sides, I will get dd of s will be equals to, now if I differentiate with respect to s, this is, so t is constant, right? So this can come inside, and what will happen? The differentiation of this would be simply minus t into x of t into e raised to power minus st dt. So yeah, so this is minus, right? So this minus sign can come here, right? So ultimately t into xt would be minus dx as x of s upon ds, right? So that's how this property came. Okay, so yeah, so I will differentiate this and multiply by minus. So if I differentiate this particular function and multiply by minus, what will I get? That will be 1 by s plus 1 whole square, right? So the Laplace transform of this particular thing would be this multiplied by t. Okay, but I see I have a additional 2, so this will be 2t. So the Laplace transform of this will be 2t into e raised to power minus t u of t, that is present in option C. So option C would be your correct answer for this question. Yes, option C would be your correct answer for this question. Most of the students remember this thing, but we are deriving. We are deriving everything from the scratch. Let's solve this question. Consider a linear time invariant system whose input r of t and output y of t are related such that this by the following differential equation. Okay, by the following differential equation, the poles of these systems are this this. What are the poles? It's very simple, right? Very simple to calculate the poles. So this will be s square into y of s plus 4 into y of s equals to 6 into r of s. So we have to calculate the poles of the system. That will be basically the poles of the impulse response, that is the ratio of y of s upon r of s, that is equals to 6 upon s square plus 4. So the poles are s equals to plus minus 2g. So that is present in option A. So option A certainly will be the correct answer for this question. Let's solve this question. The causal realization of a system transfer function h of s having poles this and this. Okay, uh, poles. Pole locations are this. S equals to, like these are the coordinates, right? So this is sigma equals to 2 and omega equals to minus 1. Okay, these are the coordinates. The causal realization of a transfer function having poles at 2 comma minus 1. 2 comma minus 1 basically means this is my sigma, this is my j omega. So 2 is the real part is plus 2, minus 1 is here, and then minus 2 plus 1 is here, right? And I have 0 at s equals to sigma equals to 2, omega equals to 1, sigma equals to 2, omega equals to 1, sigma equals to minus 2, omega equals to minus 1, right? So yeah, the pole 0 diagram, right? What is it? Is it stable, unstable? What is it? Okay, how do I comment if it is the causal realization, right? So if they're talking about the causal realization, if I consider only the poles, so what are the possible ROC locations, right? ROC can only be this one, right to the rightmost pole, because it is a causal signal. If it is a causal signal, the ROC must lie right to the rightmost pole. That is, rightmost pole is this one, so it must lie right to the rightmost pole. That means ROC does not include j omega axis. So certainly it will be unstable. It will not be stable. Certainly it will be unstable. Now we know it is unstable. Now whether it is high pass or a all pass filter. So we can see, like all the pole 0 diagram, it is symmetric, right, about the origin. So certainly it will be an all pass filter. And how can you verify? So you will see your poles are basically conjugate of zeros whenever something like this happens. So if you take the conjugate of this, right, what will happen? This will be 2 minus 1, that is this. So your poles and zeros are conjugate of each other. So if your poles and zeros are conjugate of each other, certainly it will behave as a all pass filters. Okay, I hope it makes sense. Poles and zeros are mirror image, basically conjugate, so it will be an all pass filter. So option B will be correct. Let's solve this one. Which of the following statements is true about the two-sided Laplace transform? So two-sided Laplace, okay, bilateral Laplace transform. It exists for every signal that may or may not have Fourier transform. Yeah, every signal that may or may not. No, it does not exist for every signal, right? It does not exist for every signal that may or may not have Fourier transform. Yeah, okay, yeah, bilateral Laplace transform. It, okay, let me read the other options as well. It has no poles for any bounded signal that is non-zero only within a finite time interval. It has no poles for any bounded signal that is non-zero within a finite interval. That is wrong. Basically, it is talking about finite duration signal. It is telling that it has no poles. No, for this signal, right, there will be a 1 by s term. Some exponential will be multiplied, but certainly there will be a 1 by s term. There will be an 1 by s term. Hence, this statement is certainly wrong. It has no poles. Okay. The number of finite poles and finite zeros must be equals. No, who said this? Finite poles and finite zeros must be equal? No, nothing like that. Poles can be greater than zeros. For a causal signal, poles is greater than or equals to zeros. If a signal can be expressed as a weighted sum of shifted one-sided exponentials, if a signal can be expressed as a weighted sum of, okay, if a signal can be expressed as a weighted sum of shifted one-sided exponentials, then its Laplace transform have no poles. Hold on, if a signal can be expressed as a weighted sum of shifted one-sided exponentials. Okay, I think they mean this weighted sum. Okay, if I have a signal xt that can be expressed, let's say this is my m naught value, it will have this. Okay, let me assume a signal xt and xp of t, okay, or x finite duration xf of t. So it is xf of t m naught plus then m1 into e raised to power one sided exponentials. If a signal can be expressed as a weighted sum of one sided exponentials. So I think, yeah, you are multiplying by exponential and then you're shifting it, right? X of t minus capital T, and then you're adding m2 e raised to power minus a a minus t and shifting it. So whatever it is, they're telling it will not have any poles. That is wrong. You will have some poles here, right? Because we saw just in this question, we did see some poles. Where did it go? Yeah, okay, that was, yeah, here, right? If you see, it was sum of basically shifting, and while shifting we were getting some poles, right? We were getting some poles. So certainly we will get some pole, we will get some pole. It's not like we will not get any pole. Certainly we will get a pole. So if you are getting a pole, then this statement is wrong. They are saying me I have no poles, and this was a MCQ, and I don't feel this question was properly defined, should have properly explained. Now it exists, the two-sided Laplace transform exist for every signal that may or may not have Fourier transform. I feel this statement is also no, wrong. Yeah, it exists for signals which does not have Fourier transform, but uh, it may not be existing for all the signals. What is example? E raised to power 4 mod of t. Okay, so Fourier transform for this exists actually, correct? But Laplace transform does not exist. So they are telling me the two-sided Laplace transform exists for every signal that may or may not have Fourier transform. So if it has Fourier transform, right, this for this signal, hold on a second. Okay, it was actually, I think, minus 40 for this signal. Fourier transform also does not exist. Okay, so okay, it does not matter actually. So we know Laplace transform does not exist for this signal, right? You cannot multiply any exponential to make it absolutely stable. So this statement is also wrong, I feel. Although they have given this as answer, but I feel this statement is also wrong. I think this question should have been empty. If you think otherwise, you can let me know in the comments with your proper reasoning why option A is wrong. Sorry, why option A is true. Okay, because I am telling you e raised to power 4 mod of t, right? So it is telling me that Laplace transform exists for every signal that may or may not have Fourier transform. So basically they're telling me Laplace transform exists for every signal. No, right? It does not exist for every signal. It does not exist for this signal. So I feel this statement is wrong. They should have framed the statement better. Okay, let's solve the next question. This is the next question. Let LDI system be causal. It is a causal system and differential equation is given. They are simply asking you the impulse response. Pretty simple, pretty easy. Either you can write your x of t, delta of t, or you can directly convert this into Laplace domain y of s plus 1 by 4 into s into y of s equals to 2 into x of s. So that will be equals to y of s by x of s 2 by s. You can multiply by 4. This will be, I think we have already done this question. I don't know. Multiply by 4. This will be 4. This will be 8. Okay. So this will be 8. I think we have already done this question. E raised to power minus 40 ut that is present in option D. I think we have already done this. That is my assumption. Okay. I forgot to delete this from the previous one. So this question, if u of t is the unit step function, then the ROC would be what? Okay, u of t is a unit step function. What is the ROC? Okay. So I see I have to make this absolutely stable, and it is a finite duration signal. So basically, right, uh, what will be the ROC? So the signal is something like this. So it exists from t equals to 1 and it goes away from t equals to 10, right? Okay, sorry. So signal would be something like this. So it is a finite duration signal, and in that duration the amplitude is also finite. So it will be, RC will be entire. So if it's a finite duration, finite amplitude, if the amplitude here was infinite, then we would have had to think once, right? But as it is a finite duration and finite amplitude signal, right, ROC will be entire spin. ROC would be entire spin. So option A would be your correct answer for this question. With this, we are done with the Laplace transform. Now we will start with Z transform. Let's begin with Z transforms. This is the first question. Uh, a discrete time all path system has two poles. Which one of the following statements is true? It has two more poles at this. It is stable. It is constant phase. It is constant phase response over entire Z plane. So there are two things, right? In Laplace domain, if it is an all pass filter, then your poles will be conjugate of your zeros. In Z domain, if it is an all pass filter, your zeros or pole will be related by this particular relation. Basically, your zero will be conjugate of poles but inverse. Your zeros will be inverse conjugate of poles. So there will be this inverse sign. Okay, this thing you will have to remember, right? So if I have two poles, then this is my pole 1, that is 0.25. So corresponding to this pole, I will have a 0 at 4, and this is my pole 2 at 2 angle 30, right? So if I take the inverse and then conjugate it, if I am taking the inverse, this will be 0.5, right? And this will be minus 30. Its phase will be same actually. This will be 0.5 angle 30. Okay, this will be the location of the 0. If I hope I am correct, right? So yes, yeah, 0 2 would be this, 0 1 would be this, and now I have two poles, two zeros, right? So corresponding to this pole, I have, yeah. Now they're telling me it has two more poles at 0.5 30 and 4 angle 0. Which is it correct? No, right? It does not. So if it has two poles, it will have two more zeros. That's it, right? Yes, that's it. Okay, so yeah, a discrete time all pass filter has two of its pole here, then the other two zeros will be here, right? So does it have two more poles? No, it does not have two more poles. It has two more zeros in these locations. It is stable only when impulse response is two-sided. So let me plot the pole zeros on the Z axis, right? This is my Z plane. So let me just plot the unit circle first to get an idea. So this is the unit circle, right? And this is the unit circle, basically mod of Z equals to 1. Now what happens, it is stable only when the impulse response is two-sided. So let me mark the poles, because that is where we can comment about the stability. So one pole is here, right? 0.25, another pole is at 2. So one pole will be lying somewhere here, 0.25 magnitude of that, other pole magnitude is 2 and angle is plus 30, so it will be lying somewhere here. Okay, so for the system to be stable, my ROC must include the mod Z equals to 1 circle. So hence my ROC must be between these two poles. That means it is in the strip format, right? That means my signal has to be two-sided. Impulse response will be two-sided. It will not be only one-sided. It will be two-sided. So this statement is absolutely correct. Option B is correct. And at that moment in 2018, there was only single option correct. So we know option B will be correct. Certainly option B will be correct. What about the third one? It has constant phase response over all frequencies. It has constant phase response over all frequencies. Certainly it will not have constant phase response over all frequency. For all pass filter, the gain is constant, but the phase response is not constant. Okay, these are not constant. So gain will be constant, phase response is not constant for all pass filter. Option B will be the correct answer for this question. Let's solve this question. H of z be z transform of a discrete time signal h of n if p of z is equals to h of z into h of 1 by z, that is z inverse, has a 0 at z equals to this, and p of z has a total 4 zeros. Which one of the following represents all the zeros correctly? Okay, so basically my p of z is equals to h of z into h of z inverse, correct? Okay, so if p of z total has 4 zeros, okay, and this has a 0 at z equals to 1 by 2, what will happen? Real value discrete signal, I know 1 0. So if I have a 0, let's say I have a 0 at mod z equals to, so z plus 1 by 2 plus j 1 by 2 is a 0. Certainly it is a 0, right? Then that means one of these will have a 0 as this, and what is then, if I know, let's say h of z has this 0, then what will be the 0 of h of z inverse? So I will just replace z with z inverse, right? If I replace z with z inverse, this will be z inverse plus 1 by 2 plus j 1 by 2. So certainly if h of z has a 0 here, then h of z inverse will have a 0 in the inverse of this particular function. So h of z will have a 0 inverse of this. Okay, so h of z will have a 0 of inverse at this. So inverse of this would be 1 divided by plus j 1 by 2. Okay, plus j 1 by 2, right? So that is equals to, if I calculate the magnitude, right, if I calculate the magnitude, this is equals to 2 and divided by under root 2. I'm just computing the magnitude. This will be under root 2. Okay, so under root 2, it's outside the unit circle. So 1 0 will be outside the, certainly 1 0 will be outside the unit circle, and obviously this 0 is inside the unit circle because it is 1 by under root 2, that is 0.707, right? Okay, cool. Okay, what about other zeros? So if I know about this 0, right, then okay, this 0 is inside here, other 0 is outside. Okay, what about the phase? What is happening to the phase? Phase will be just in negative, right? So whatever was the phase, what is the phase here? Phase is plus 45. So the other one will have a phase of minus 45. So it will lie somewhere here, okay. So yeah, if I am lying here, the other 0 will be lying here. If this 0 is here, so it will be basically mirror image about the real axis because the phase will be negative, right? I see this is definitely certainly not okay. This is also mirror image about the real axis, but all the zeros are inside the unit circle, so this certainly is not my answer. I see here this is certainly not mirror image about the real axis because the angles must be negative of each other, right? Angles must be negative of each other. This again is not mirror image about the real axis. This certainly is the mirror image about the real axis, right? And this also certainly is the mirror image about the real axis. But here I see the real part of the both the zeros are at z equals to 2, which is incorrect, right? The real part basically, okay, yeah, because this, right, distance must be mod 2, that okay. Hold on, give me a second. Real part they're telling me it is at z equals to 2, is it correct? So what is the real part? How do I compute the real part? So let me do conjugate multiplication. This will be minus j 1 by 2, 1 by 2 whole square plus 1 by 2 whole square, that is 1 by 2 right? 1 by 2 whole square plus 1 by 2 whole square, that is 1 by 2. So this will be cancelled. This will be 1 minus j. Okay, this will be 1 minus j. Right. Okay, so the real part is actually 1. So its real part should not be 2, real part should be 1, that is present in this particular diagram. So certainly your option D will be correct. Okay, option D would be correct. And I know if I know these two zeros are fine, but other two zeros will be somewhere here because they will be in conjugate pairs. Okay, inverse conjugate pairs basically. Okay, so option D will be correct for this particular question. Let's solve the next question. For a unit step input U of n, the discrete time LTI system produces an output. This is the output for a step input, right? So basically I have a LTI system, LTI, this is my input and this is my output. Correct? Sorry for the noise. Now they're telling me, now if the input is this, what will be the output? Okay, so let us calculate the impulse response. Let us calculate the impulse response h of n. It will be nothing but the derivative of the step response. And what is the derivative in discrete domain? It is not called derivative, it is called difference equation. So it is simply s of n plus 1 minus s of n, right? That is simply equals to, sorry, it is s of n minus s of n minus 1. Okay, this is the difference equation in discrete domain. This you will have to remember. This you will have to remember, the difference equation in discrete domain. Basically x of n minus x of n minus 1. This will be equals to the step response at n equals to n, that is this value, 2 delta of n plus 1 plus delta of n plus delta of n minus 1. Then subtract this with delta. So now we'll put n equals to n plus 1. So everywhere wherever there is n, I will replace this with, sorry, not n plus 1, n minus 1. I will replace everything with n minus 1. So this will be 2 delta of n minus 1. So this will be 2 delta of n only plus delta of n minus 1 plus delta of n minus 2. Okay, so this will be equals to 2 delta of n plus 1 and minus of delta of n. This will be cancelled. This will be plus delta of n minus 2. Okay, so this will be the impulse response. If you want to calculate without this formula, you can use Z transforms. So the step response, right? So my y of z will be equals to h of z into x of z. Okay, so if the input is step, then what is the Z transform? It is 1 minus Z inverse. This very basic formula, use this formula, x of z equals to summation of x of n z raised to the power of minus n. N will go from minus infinity to plus infinity. Use this basic formula and you will be able to calculate what is your Z transform. So you know your Z transform. You know your Z transform. Now what you will do? You know your Z transform, right? Yeah. So this is my Z transform, and what is y of z? Y of z is this, and this again can be written in the Z domain, 2 of z plus 1 plus Z inverse. How have I written it? It's very simple. So basically Z transform of delta of n, again you can use the basic formula, will be 1. So x of n minus n naught, right? Again you can use the basic formula. You will see that you will have to multiply with x of z, z of raised to the power of minus n naught. Whatever was the shift here, the same shift you will have to raise to the power of z in negative direction, right? It's like in the same direction. So that will be same basically, right? So this property we used. So I know the z transform of delta of n, that is 1. So what will be the z transform of delta n plus 1? That will be 1 into z raised to the power of 1. So z raised to the power of 1, and obviously coefficient is 2, that's why it is 2. So that's how you can remember these things. So I know my y of z. So if I know my y of z, this will be equals to 2z plus 1 plus z inverse upon the x of z. What is x of z? X of z is this, right? 1 by z inverse. So basically 1 by 1 minus z inverse. So this will be equals to 2z plus 1 plus z inverse into z 1 minus z inverse. So this will be equals to 2z minus 2, then okay, 2z, yeah, minus 2, then plus 1 minus z inverse, then plus z inverse minus z raised to the power of minus 2. So this shall be equals to 2z minus 1 minus z raised to the power of 2. So that is exactly what we have derived here. If you see the the inverse z transform of 2z is 2 into delta n plus 1. The inverse z transform of minus 1 is delta of n. The inverse z transform of minus, okay, there is a minus sign. Hold on, this should be minus as well, right? Just give me 1 second. Okay, so there was a negative sign here, right? Yeah, just about to mess it up. So there is a negative sign. Yeah, the inverse z transform of this would be this, right? Okay, so you can verify from here itself. Now we will not solve the next part in z transform. It will be a bit difficult. You can solve it. You can actually solve it in z transform as well, but we'll solve this in the time domain only. You can solve in z transform, right? You know, so what is y of 0? So ultimately you will again have to compute y of z when the input is this, right? And you know the z transform of this. So your output would be h of z, you have already known in z domain, and you will have to multiply x of z. That will be equals to simply the inverse z transform of this would be 1 divided by 1 minus a z inverse, where a is half. So you can solve, and then you will do the long division method, and then you will see that the coefficient of z raised to power 0, that is the constant term, is 0. So y of 0 will come out to be 0. But let's, like, that is one way to solve. I want to solve in a bit different manner. So we want to compute what is my y of n when my impulse response is this, and what is my input. So I want to convolute impulse response with my input, that is basically 1 by 2 n u of n. So this is actually a bit easier. This is actually much easier. So what is the convolution of delta n and un? So whenever I am convolving anything with delta n, that is the same function, right? Basically what will happen if I am doing convolution x of n, let's say x of n convolution with delta of n minus n naught. So this will be actually equals to x of n minus n naught, that's all. So you replace your n with n minus n naught, that is all. Don't do anything else, just replace your n with n minus n naught if you are doing convolution. So that is what we will do here. So I am convolving delta of n plus 1 and this, right? So I will replace n with n plus 1, that's all. And of course there is 2, so I will have to multiply 2. So 2 into 1 by 2 n plus 1 u of n plus 1 minus, then I'm multiplying these two. Basically, I'm convolving these two. So I'll replace n with n only. So this will be 1 by 2 n u of n. Then minus sign is there actually here, and then I will replace n with n minus 2. So this will be 1 by 2 n minus 2 u of n minus 2, right? So yeah, now how to solve this? How to solve this? What how to solve? So now you calculate u of y of 0, right? You put n equals to 0. So this will be 1 by 2 raised to the power of 1 into u of 1, right? N is equals to 0. So this will be 1 by 2 raised to the power of 0 u of 0 minus 1 by 2 raised to the power of minus 2 u of minus 2, correct? So u of minus 2 is anyways gone, it is 0, right? U of 0 is 1, u of 1 is 1, right? So it is essentially 2 into 1 by 2, that is 1, minus 1, that is 0. So your answer comes out to be 0. So this is a bit easier than that part. That also is good, this also is good, whichever one is suitable to you. That method, previous method that I discussed in the z domain, that also you can do, but I think this is better because you are directly getting the expression of y of m. That is bit easier. Okay, yeah, let's solve the next question. 0 would be the answer of the previous question. For a causal discrete time LTI system like this, which of the following statements is /R2? It is a causal system, right? And the system is stable, it is minimum phase, initial value is this, final value is this. Let's discuss all of them one by one. So the system is stable, okay, the system is stable. So for that, let us draw the pole diagram, pole zero diagram. So if I see on the z plane, and let me copy the unit circle basically from here. If I see the z plane, so one pole or both the pole magnitudes basically are on the real axis. One pole is here at z equals to 1 by 3, that is before unit circle, and one pole is here z equals to minus 1 by 3, right? Now both poles are lying inside the unit circle, correct? For this system to stable, okay, it is saying that it is causal, right? Causal means I will have to be right of the, yeah, outside of the outsidemost pole, right? So outside of the outermost pole is this is my ROC, correct? If this is my ROC, I see it is crossing the mod z equals to 1, that is unit circle, then certainly my system is stable. Certainly the system is stable, okay, it is correct, system is stable, certainly. Now what about the other statements? The system is minimum phase. Now for my system to be minimum phase, okay, all the poles, so in Laplace domain, in S domain, if I say a system is minimum phase system, right, then that means all poles and zeros must lie on the LHS of j omega axis. This has been taught in control systems. Why is it called minimum phase system? or this must have been taught in the signals and system. Now in Z domain, right, we know in Z domain what happens. Basically your j omega axis is compressed in unit circle, if you know unit circle, correct. Why is it called unit circle? Because if you remember, your basically what happens is, this is your x of, so what is your x of s? It is basically equals to x of t e raised to power minus st dt minus infinity to plus infinity, right? And what is your x of z? X of z is equals to summation of x of n equals to minus infinity to plus infinity z raised to the power of minus n. Now what happens is, this conversion, like when we go from continuous time to discrete time, what do? We sample. So our t is converted into nts, right? So wherever there is t, this will be converted into nts. So this will become e raised to power minus s ts raised to the power of n. So whenever this is converted into discrete time, so this particular term, right, is same as this one. So basically your e, so your z actually is equals to, if I compare these term, this term and this term, so from here I see that my z is equals to e raised to power sts. So whenever we are talking about omega equals to 0, that means basically if I replace my s with j omega, right, if I replace my s with j omega, this will be j omega ts. So omega equals to 0 basically means z equals to 1. That is what we mean by unit circle. That's why all of the omega axis, right, has been converted into the z equals to 1, mod z equals to 1 plane. So if you have, I hope you have already studied the signals from us. If you have, you already know all these things, right? I'm just revising these things. So yeah, these are the things that happens, and that's how you compare, and that's how you equate the values of z. So this is the exact value of z. If the s domain value is given to you, if a pole at s equal to is given, right, you can actually compute the pole in the z domain if you know the sampling period, okay, with this formula. And it's not like you have to remember the formula, you can derive it. Okay, so z domain will be converted into unit circle. So basically all poles and 0 must lie within the unit circle if the system is minimum phase. I see that two poles are lying within the unit circle, but what about the zeros? I see both the zeros here, they are plus minus j root 3 by 2, which is greater than, so its magnitude is certainly greater than 1. If its magnitude is certainly greater than 1, then they are lying outside the unit circle. And if they are lying outside the unit circle, you know, right, you know, it will not be a minimum phase system. Then the system is not a minimum phase, it is non-minimum phase system. What about this one? The initial value of the impulse response is 2. Again, how to remember this? How to remember this thing? Like how to remember the initial value theorem and final value theorem. So you'll have to remember, I hope you remember the initial value theorem in the s domain, that is limit as s tends to 0, s into x of s, correct? Now of course initial value theorem system must be causal, and it is causal, nothing, it is crossing, it is causal, right? So we can use the initial value theorem. What about z domain? In z domain it is almost same. This you will have to remember, that your s will be converted into 1 minus z inverse, and this x of s will be x of z. This will be in multiplication. Now what will be the limit? So if we compare this equation, right, if I make my s tends to 0, what does z tends to? If my s is tending to 0, what is z tending to? 1. So this will tend to 1. Not now, the limits will change. This will tend to 1, not 0. That's why there is a limit of 1. So I am revising everything, okay? If you are enjoying this, make sure you hit the like button and let others know in the comments that yes, we are revising as well. We're not just solving questions, we are revising other concepts as well. So this will be x of z. Okay, this is my initial value theorem. So let's solve it. So this is my h of z, right, for which I have to calculate the initial value. So when my sorry I'm sorry, here we're doing so that was a final value. So this is where my s is tending to infinity. If s is tending to infinity, your z also is tending to infinity. If your s is tending to infinity, your z also is tending to infinity. Sorry, this will be z tending to infinity, not z tending to 1. Okay, and if z tends to infinity, 1 by z will be 0, so it will be only 1. So ultimately you will have to calculate z tending to infinity this value. Okay, so if z tends to infinity, you will only choose the basically the z square wala terms, right? I hope you know how to solve limits, right? So this will be simply 2 divided by z square, that is 1. So initial value is 2. So this is certainly true that the initial value of the impulse response is true. This is certainly true. What I have done, so as z tends to infinity, this will be 0. So this will be 1. Okay, 1 into x of z at z equals to infinity, and as z tends to infinity, just solve the limit. I will not explain how to solve the limits. That has been covered in the mathematics R-PYQ, right? So yeah, this will be 2. So option C is certainly true. What about option D? The final value of the impulse response is 0. So again, if I apply the final value theorem, now what is the final value theorem? It is in S domain, in Laplace domain, limit as s tends to 0, s x of s. Okay, that is my final value. Now, of course, all poles must lie on the left hand side of j omega axis, or in case of z transform, it must be stable. That is, all poles must lie within the unit circle, which is happening here. All poles are lying within the unit circle, that is happening. So this is certainly true. Okay, this is certainly true. So this will be equals to so yeah. So what about in the z domain? As I was saying, now if s is tending to 0, this will be tending to 1. So this will be limit as z tends to 1, 1 minus z inverse x of z. Okay, so now this is interesting, right? 1 minus z inverse x of z. X of z is this, right? All these values. So 2 z square plus 3 upon z plus 1 by 3 into z minus 1 by 3. Now if I put z equals to 1, if I put z equals to 1, what will happen? This will be 5 divided by 1 by 3 minus 1 by 3, right? Which is finite. So and this is 1 minus 1, which is 0. So 0 times finite will be 0 only. If here some term that would have become made it 0, then we would have had to do some cancelling stuff, right? But here nothing is making it 0. So certainly this will be 0 only. Okay, your final value will be 0, which is absolutely correct also. So option A, C, D are my correct answers for this question. Let's solve this question that came in 2025. So here they ask, let x of n be a discrete time signal. Let x of n be a discrete time signal whose z transform is x of z. Okay, so okay, the discrete time Fourier transform DTFT of x of n always exists. Is it true? No. The DTFT, if the z transform exists, DTFT will exist only if the ROC of x of z includes mod z equals to 1 circle. Basically, it must be absolutely integrable. And how it, so this is the formula, right? X of n z raised to the power of minus n equals to minus infinity to plus infinity. So it must include the, so when mod z equals to 1, basically when z is equals to 1, so this becomes summation of my x of n. Basically my x of n must be absolutely integrable, right? So yeah, it will not always exist. It will exist only if it includes mod z equals to 1 circle. The region of convergence ROC of x of z contains neither poles nor zeros. It does not contain poles, but it can contain zeros, right? Zeros does not have any harm, but it certainly contains zeros. It can contain zeros. So this statement is also wrong. They are telling me it neither contains pole nor zeros. Yeah, ROC does not contain poles. Certainly it does not contain poles, but it can contain zeros. The discrete time Fourier transform exists if the region of convergence ROC contains the unit circle. Certainly true. If it contains the unit circle, certainly the system will be absolutely summable. X of n will be absolutely summable, and certainly the discrete time Fourier transform will exist, similar to continuous time Fourier transform. Always relate. So when does continuous time Fourier transform exists? When the In the S domain, the ROC includes the j omega axis. Correct? Yeah. X of n is equals to alpha into delta of n, where delta of n is the unit impulse and alpha is the scalar. Then region of convergence of the uh, x of z would be entire z plane. Okay. If x of n is equals to alpha into delta n, region of convergence is entire z plane. Entire z plane. 0 raised to over 0, it is 0 only, so that won't be a problem. It is true. ROC would be entire z plane. It is true. So it is a finite duration signal, and you can just like, what is the z transform, right? Z transform of alpha delta n is simply alpha, correct? And here there are no restrictions on z. There are no restrictions on z. So certainly the ROC would be entire z plane. Okay. If it was alpha into delta n plus 1 or n minus 1, then this would have been alpha into z inverse. Then this would have been alpha equals to z alpha by z. So I have a pole at z equal to 0. So then I could have commented that z equal to 0 is not in the ROC. Okay, but they have given me the simplest form delta n. Delta n, the ROC would be entire z plane. It will be always entire z plane. If there is some shifting, then you will have to take care of it. Okay. So option C and D are a correct answer for this question. Let's move on to the next question. Now we will start solving the double E questions. So this is the first double E question. Which of the following is true? Which of the following is true for a linear time invariant discrete time system that obeys the difference equation? Okay, this is the difference equation basically. So y of n is unaffected by the values of x of n minus k. Okay, where k is greater than 2. Y of n is unaffected by the values of x of n minus k, where k is greater than 2. Okay. Okay, y of n is unaffected by the values of x of n. The system is necessarily causal. Okay, the system is causal. Okay, let me compute the impulse response of this system. So impulse response would be h when the input is impulse. What is the output? So it is h of n minus 1, that is equals to b naught delta of n minus b1 delta of n minus 1, right? So if I take the Laplace, if I take the z transform, this will be h of z minus a into z inverse h of z. I hope you know how to take the Laplace z transform of h of n minus 1, right? Same property, I think we have discussed in today's lecture itself. This will be again 1 minus b1, this will be z inverse. So your h of z would be equals to b naught minus b1 z inverse divided by 1 minus a z inverse. So here the number of poles and zeros are same. If the number of poles and zeros are same, then will it be causal or non-causal? Can I comment it? I cannot comment it, right? This will, so okay, any information is given regarding A, nothing is given regarding A. Okay, the system is necessarily causal. Okay, so if I draw the pole zero diagram, right? So I have a pole at z equals to A, correct? I have a pole at z equals to A, mod z equals to A, and this is my unit circle, correct? Now all of it, mod z of A can be here, can be here. So it depends, right? The system is necessarily causal. Is it stable? Is it causal? Is it stable? How do I know if it is causal or not causal? Have they told us is it stable? Y of n is unaffected linear time invariant system. If it is linear and time invariant, okay. So ROC can be right of the rightmost pole as well, but I have a 0, right? Okay, I have a 0, that is fine, but that won't make any difference. Z equals to 0, do I have any poles? Z equal to 0, I don't have any poles. I have only a single pole, so is it causal or not causal? You cannot comment, right? You cannot comment whether it will be causal or not causal, because it all depends on the ROC, and ROC is not given to us, right? ROC is not given to us. We don't know what is the ROC. If they would have commented whether the system is stable or whatever, then I could have commented. It is not necessarily causal. If I take the inverse of this, right, I can take the like non-causal version as well. Non-causal version can also be the inverse of this. Okay, so it is not necessarily causal, it can be non-causal as well. So this statement is certainly wrong. Y of n is unaffected by the values of x of n minus k, where k is greater than 2. Now again, let me because it is MCQ, let me read the other options. I am not able to figure out this option. The system impulse response is non-zero at infinitely many instants. It is non-zero at infinitely many instants. The system impulse response is non-zero at infinitely many instants. Okay. It is non-zero at infinitely many instants. So okay, impulse response. What is the impulse response? Impulse response is this, right? This is an impulse response. So non-zero at many instants. Okay, let me read this option. When x of n is equals to 0 for n less than 0, okay, the function y of n for n greater than 0 is solely determined by x of n. So they're telling me x of n is 0. Basically, it is a causal signal. So it will be solely, your output will be solely determined by x of n only. Okay. So if it is 0 for less than n, right? So if it is 0 for less than n, so let's take this case. So let's put n equals to 0 in this equation. So my y of 0 minus a y of minus 1 would be equals to b naught of x of 0 minus b1 of x of minus 1, that is anyway 0, right? Because they have told me for n less than 0 x of n is 0. So this is 0. Okay. So okay. So if you see, for y greater than 0, or okay, let me choose it for y equals to n equals to 1. So this will be y of 1 minus a of y n minus 1, that is 0, is equals to b naught of x of 1 minus b1 of x of 0, correct? Now the thing is that your y of 1 is dependent on x of n. Certainly it is dependent on that, but it is dependent on y of 0 as well, and your y of 0 is certainly dependent on x of 0 only, that is correct, but it is also dependent on y of minus 1. So it is dependent on y. Okay, it is dependent on y. So certainly this statement is wrong, that your x of n, if it is a causal signal, then your function y of n would be solely determined by x of n only. No, y of n also will have a say. Now this particular thing, the system impulse response is 0 at infinitely many instants. The system impulse response, this is the system impulse response, right? So okay, so let's assume that, let's take a very simple case. Okay, that let's take in this equation, let me put n equals to 0. Okay, n equals to 0, and let's assume that h of minus 1 is 0. Okay, let's assume that. So this is h of minus 1, right? If I put n equals to 0, I am just computing the impulse response. This will be delta of 0, and this is delta of 0 minus 1, that is minus 1, that is 0 anyways. So we know h of minus 1 is 0. So h of 0 is b naught delta, that is 1. Basically b naught into delta of 0, that is 1 only, right? H of 0 is b naught. Okay, now I'm just thinking something. X of k, y of n is unaffected. Uh, can I solve this in a different manner? So what will be impulse response, right? Your impulse response will be basically, impulse response will be this, right? Give me a second. This will be b naught, and now if I put n equals to 1 in this equation, right? If I put n equals to 1, this will be h of 1 minus a into h of 0. This will be 0. Okay, delta of 1 would be 0. This also, okay, this will be non-zero. This will be minus b1. So you will get some h of 1, and then again you will get some h of 2. So you will always get some value. Okay, now some non-zero value. So this statement seems correct. This seems correct, right? That the system impulse response is non-zero at infinitely many instants. Okay, it seems correct. So for sure, let us try to eliminate this option. Y of n is unaffected by x of n minus k. So what is y of n basically? So your y of n is equals to convolution. Basically, it is an LTI system. So it will be convolution from k equals to minus infinity to plus infinity h of n or h of k into x of n minus k. Okay, this is simply the convolution, right? All I'm doing is convolution. Now they are telling me that for k greater than 2, y of n will be unaffected. Y of n will not change for k greater than 2. Is that true? So that is not certainly true, right? Because your h of k, like h of 2, h of 3, all these are different values. All these are different values, right? So if there are different values, then your y of n also will come out to be different. Your x of n also are some different values, as you can see. So this statement certainly is wrong. So certainly option C only is the correct option. Okay, bit of like doubt might be there, but try to eliminate all the other options. Okay, so option C is the correct. This was a MCQ. So pretty good question, like bit of analytical thinking is required here. Consider a signal x of n equals to this. Okay, I think this has to be 1. Okay, where 1n is basically 0 if n is less than 0, and 1n is 1 if n is greater than equal to 0. It is simply the step function. The z transform of x of n minus k, where k is greater than 0, is this, with the region of convergence being what? Okay, so basically what is a z transform? What is a z transform of x of n? That would be equals to 1 by, like there is a derivation, you can derive it. It will hardly take you 20 seconds. Okay, in this lecture itself I think I have derived it. So it will be 1 by a into z inverse. So 1 by 2 into z inverse, right? That is your z transform. Now what about the z transform of x of n minus k? That would be basically x of z into z raised to power minus k. So z raised to power minus k into x of k. That will actually not change the ROC. Okay, and we see this is a causal signal, right? So our ROC would be mod of this greater than 1 because it is a causal signal, correct? So this will be equals to z less than mod z less than 1 by 2. Okay, That is the simple ROC, right? Because it is a causal signal, our mod hold on a second. No, sorry, what am I doing? This is wrong, right? So simply we know the pole location. What is the pole location? That is mod z equals to 1 by 2, right? And as it is a stable signal, okay, you see it is a stable signal, right? So it must include the mod j. First of all, our ROC must be right of the, if it is a right sided signal, as you can see here, it must be right of the pole, right? Outside the uh, pole basically. So it is mod z equals to half, so it must be outside the pole, that is this particular location, right? Okay, so basically it will include the unit circle. So our ROC would be, it will be outside because it is a causal signal, okay, and of course it is a stable signal, we can see. So causal stable, of course it will include mod z equals to 1, so it will be outside, so mod z will be equals to half. I was wrong there, I was doing this, right? Mod z inverse 1 by 2 is less than greater than 1, that is wrong. This thing is wrong, okay, don't do this. So first of all you compute the pole location and then you draw the pole location and then check whether your system is whether your signal is causal, non-causal, anti-causal, whatever it is, right? According to that you draw your ROC. So if it is causal, it will be outwards. If it is non-causal, it will be in the strip format. It is anti-causal, it will be inwards. Cool? Yeah. So it will be mod z greater than half, that is present in option D. So option D is the correct answer for this question. Let's move on to the next question. This is the next question, right? The causal signal with z transform this. Okay, they are simply asking what is x of n, right? So this is z square z minus a whole square. Okay, pretty interesting. Okay, I see there is some multiplication of n that might help. So I know this, right? I know this particular transform 1 by, this is the most basic transform, z inverse. For this the transform is n, sorry, a raised to the power of n e of n. Okay, a raised to the power of n e of n, right? So how to solve this? Give me a second. This would be, so if I want to solve this, I know one more property. Okay, we know this thing that my x of z is equals to summation n equals to minus infinity to plus infinity x of n z raised to the power of minus n, right? Now if I differentiate with respect to z on both sides, so d upon dz, so that will be basically n equals to minus infinity to plus infinity x of n into, so I am differentiating with respect to z, right? So n will not change, I am differentiating with respect to z. So what is the differentiation of z raised to the power minus n? It will be minus of n into z raised to the power of minus n minus 1, correct? So something interesting will happen here is that there is a additional, okay, z inverse is there. So this, right, if I rearrange everything properly, so this additional z raised to the power minus 1 can come in this side, that will become z, and I can multiply a minus sign. So this will be x z into dx z of dz will be equals to this particular summation, n going from minus infinity to plus infinity n x of n z raised to the power of minus n. Okay, so pretty interesting. Like this, anyways, you derive as a result, you remember as a result, but even if you don't remember the result, still you can get to the result, right? Just with simple derivation. That's what I tell you. Even if you forget everything, still you can get to this result, okay, with basics. So I got to this result. Now what I will do is I will mark this. Yeah, so I know this, right? So let me rearrange this a bit better. So this can be written as z by z minus a. This is much better. I see much similarity, right? Now what I will do, I will differentiate this. So if I differentiate and multiply by negative sign and multiply by z, right, that will, in the time domain, what do I have to do? I have to multiply by n. That's all. In the time domain, it is x in n into xn. So let me differentiate this. The differentiation of this would be z by z minus a whole square, and differentiation of the numerator 1 into z minus a minus z into differentiation of the denominator, that is again 1. So this z will be cancelled, this will be minus a. So this will be simply minus a z minus a square. Am I correct? This will be z into, this will be 1 multiply z, yeah, z minus a, and that will be also 1. Yeah. And then I will have to multiply by z, right? You will have to multiply by, sorry, you will have to multiply by minus z. So this will be az upon z minus a square. Okay, that has a z transform of what? A raised to the power of n un into n. Now still I am not in my proper format, because I see here I have z square. Okay, I see I have z square. So what do I need to do? I have a z square only here, right? And I see I have a into z. So basically what I can do, I can multiply. So here what do I need to multiply? I need to multiply z and a inverse. So a is just a constant number, right? So this a inverse can be multiplied on both sides. So if I multiply a inverse on both sides, technically this will become n minus 1. That's all. A raised to the power of n minus 1. Okay. And I'm multiplying by z in the z domain. What happens if you multiply by z in the z domain? Basically you are shifting. So if you remember this, right? So your x of n has a z transform of x of z. Your x of n plus n naught will have a z transform of x of z into z naught into z raised to the power of n naught. Okay, so that is the case over here, right? That is the case. So yeah, that is the case over here. So now if we solve this, so what is happening? So if I'm multiplying by z, right, basically z raised to the power of 1, I'm shifting all this x to be n plus 1, right? So this, wherever there is n, everything will become n plus 1. So this will be n plus 1 into a raised to the power of n minus 1. It is n plus 1, so n plus 1 minus 1, that is n only, and this will be u of n plus 1. Okay, that is actually the Laplace transform of this particular function. Okay, so where my a is simply what? A is simply a, right? So this is n plus 1 a raised to the power n u of n plus 1, n plus 1 a raised to the power n u of n is only there. Okay. It should be n plus 1, I'm thinking. Oh, okay. If you check just a very small thing, at n equals to minus 1, what is the value of this function? It is actually 0. It is actually 0, right? So here also at n equals to minus 1, it is already 0, right? So it is same. Like this function exists from n equals to 0. So n equals to 0, what is the value? This is 1. Basically a raised to power of 0, that is 1, and this is also 1. Here also n equals to 0, the value is 1 only. Okay, so basically, right, this function and this function are the same. You can check, you can compare. these two functions will be same. Okay, just a bit of trickery. So you can actually convert your u of n plus 1 to u of n if you have a multiplication of something that is a function of n. Okay, you'll have to observe and see, but certainly you can do the conversion. So this will be certainly your proper answer. That's how you derive the expression. Okay, yeah, let's solve the next question. This is the next question. The z transform of a discrete signal x of n is this with ROC R. Okay, so they are telling me whether the discrete time Fourier transform will converge or not. The discrete time Fourier transform converge is if mod z is greater than 3. Certainly no, it has to include the unit circle. So here I see it includes the unit circle. So discrete transform will DTFT will converge if ROC is between 2 by 3 and 3. Yes, because I see one pole is here, one pole is at 3, one pole is at 2 by 3. Certainly if it is between the two poles, then certainly it includes the mod z equals to 1 circle. Certainly the transform DTFT will converge. Okay, now discrete time Fourier transform converges if R is such that x of n is left sided sequence. What does left sided sequence means? So here I have two poles, so 3 poles, right? One is at 1 by 5, another one is at 2 by 3, another one is at 3. So this is my unit circle. Left sided sequence basically means that my ROC must be left of the leftmost pole. Okay, left of the leftmost pole. So if it is left of the leftmost pole, then of course it does not include the j omega axis, then certainly you can, so it DTFT will not converge. Okay, what about this one? DTFT converges if R is such that it is right sided sequence. Right sided sequence basically means outside of the rightmost pole. Again, not, it does not include mod z equals to 1. Certainly this also will not be true. That is what right sided sequence means, right? I hope you remember all these things. So only option B is the correct answer for this question. Let's solve the next question. So if z transform of a finite duration discrete time signal x of n is this, then z transform of y of n equals to x of 2n. What would be that, right? So again, it seems like you have forgotten the property. So write the basic equation. So what is my x of z? X of z is equals to x of n equals to minus infinity to plus infinity z raised to the power of minus n, right? Now what essentially is happening, you are replacing your n with 2n. Okay, if you are replacing your n with 2n, what will happen? And what is your y of z? Y of z is equals to integration of y of n equals to minus infinity to plus infinity z raised to the power of minus n, right? And this I can extend like this. My y of n is this value, y of n is x of 2n. Now I'm thinking, can I change something here? Can I make this dummy variable or something? Okay, so what is actually happening over here? N equals to 1, n equals to 2, n equals to 3, right? So I see they are doing something, right? X of z by 2, x of minus z by 2, or x of z square. So what is x of z square? If I do x of z square, right, this will be changed to 2n, but that will not help me, right? That is not the proper way, no. So z square certainly is not correct. X of z square is nothing but, if I replace here z with z raised to power 2, this also will be replaced by z raised to power 2n. That is not correct. That is not the proper format. But these seems promising. Okay, Let me think about these things. So what I can do is I can assume a variable k, that is 2n. Okay. So if k is 2n, right, then n will be equals to k by 2. Okay. So this can be rewritten because n is going from minus infinity to plus infinity. I can say, so n can be 0, 1, 2, 3, right? N can be 0, 1, 2, 3. So k can be, k actually can be 0, 2, 4, something like that. It will not be continuous. I mean, it will not be 0, 1, 2, 3 like that. Okay. It will not include all the samples. I'm just thinking, how can you solve it? Like, I know there is certainly a property. I know there is a property, but I'm just thinking, how can you solve using that property? Okay. Because you are only taking into action. So what you are adding up essentially, right? You want to add k equals to 0 to 4, right? So essentially, what signal you want to get? You want to get a signal over here that is like this. You want to perform this addition, right? So I'll start from 0. So when n is equals to 0, this will be x of 0. That's it. When n is equals to 1, this will be x of 1. Not x of 1, sorry, x of 2 into z raised to the power of minus 1. When n is equals to 2, it will be x of 4 into z raised to the power of minus 2, and so on. Okay, and so on. Now I want these kind of terms, right? What will help me achieve that? So if I assume k to be 2n, then what? Okay. If I assume k to be 2n, okay, and let's take your k varies from 1, 2, 3, 4 like this. Okay, like this is a very good question. If your k varies from 0, 1, 2 through 4 like this, right, but you don't want these terms, you don't want the odd terms, what you will do? So you can write this thing, x of k minus of 1 raised to the power of k yeah, I think this is fine. X of k into 1 minus x of 1 raised to the power of k, hold on, not 1 raised to the power of k, minus 1 raised to the power of k plus 1, this, right? Okay, I think this will work, divided by 2. Now what is happening? If you choose k equal to 0, this will be what? This will be 1 plus 1 divided by 2, that is 1. So x of 0. So I am getting x of 0. If I choose k equals to 1, now what will happen? This will be minus 1 raised to the power of 1. So 1 minus 1, that is 0 by 2, that is 0 only. So that term is gone. X of 1 is gone, and that is what I want, right? But next time what needs to happen? When k is 2, this will be 1 plus 1 divided by 2, that is 1, that is fine. So x of 2 into z raised to the power of minus 1. So I cannot keep here n, right? I need to keep here k by 2, because this will be minus 2 by 2, that is 1. So this equation can be converted into this format. This will be equals to x of k 1 plus 1 minus 1 raised to the power of k divided by 2 into z raised to the power of minus n, sorry, minus k by 2, k going from minus infinity to plus infinity. Now this will be much simpler. So I can actually expand this, expand meaning expand the brackets. So 1 by 2 can be outside, okay, and this will be summation of k minus infinity to plus infinity x of k, right, into z raised to the power of minus k by 2, then plus the same thing, right? What is the difference? There will be a term. What is that term? That term is this, minus 1 raised to the power of k. Okay, minus 1 raised to the power of k. Now k is just a dummy variable, so I can replace all the k here with n. I hope you will not be angry at me if I replace k with n, right? N varies from n equal to 0, 1, 2, 3, 4, k varies from k equal to 0, 1, 2, 3, 4 minus infinity, right? So I can replace my k with n. You will not be angry with this change. Okay, why is this not changing? What is happening? I'm choosing eraser, why is it not changing? N, 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 and n, and n, right? So what is this? This term is x of z raised to the power of minus half. Do you remember? So if I put here z raised to the power of minus half, you will get this term, right? Just put here z raised to the power minus half. Just put z raised to the power minus half. This will become n by 2, correct? Hold on a second. Is it minus half or plus half? Hold on. It is not minus half. It is plus half, right? Because already minus raised to the power of minus n by 2 is already there, right? I know I don't need to provide another additional minus sign. I just need to raise it to the power of half. Okay, so it will be z raised to the power of half. So this is certain. So option C is correct. Okay, but what about the second term? How do I explain you the second term? Okay, for the second term, what you can do is you can take this negative sign, right? So sorry, this was negative sign raised to the power of what? N, correct? So this is also raised to the power of n. So what I can do, I can take this negative sign inside. So this again can be further simplified as x raised to the power of n. This will be minus 1 because both are raised to the power of n. So minus 1 minus z raised to the power of n by 2 minus n by 2, correct? Okay, so yeah, minus z raised to the power of n. So basically you will replace your z with this minus z raised to the power of half, minus z raised to the power of half. Okay, very elegant, very beautiful question, and good questions do come from electrical branch as well. So this is the answer of this question. Now we have the final chapter remaining, sampling and filters. So we will do that, and with that we will end our signals and systems. So let's begin with sampling. Before beginning with sampling, we want to revise few concepts like this, right? What do we mean by Nyquist rate of sampling and so on. So before starting that, I wanted to discuss few things which few basic prerequisites that we will certainly discuss in this lecture. That is the first thing. So in sampling, what do we do? Basically in sampling, what we do, I have my input signal, let's say input message signal MT, right? And then we have a multiplier, correct? Let's say that is PT. And the task of the PT is to sample my message signal at every TS interval, right? So my PT is basically equals to, so what do I want? My MT is any signal, right? MT is any random signal. And don't worry, if you want to learn more about sampling, okay, more about sampling, then of course we'll do all these questions. You can go and watch this video. Okay, total everything has been covered in this video. If you want to learn totally and revise everything about sampling, LTI systems, analog filters as well, because this video was not obviously comprehensive. We are not able to cover all types of filters. Please go and watch this video, please, please, please. Okay, so yeah, that was a bit of what do you call, warning, because you will expect I will explain everything in just this 10 minutes. No, that does not happen, right? That is not possible. Whatever is possible, that I will do. So I have this signal, okay, and I am sampling this at every instant. So what we do essentially, ts, 2ts, 3ts, and so on. So I multiply it and I sample the individual points, correct? So my pt is essentially what? It is simply summation of delta of t minus n ts. Okay, why delta? Because it is just an impulse function, right? If you multiply let's say x of t with delta of t, what will be the value? It will be x of 0, right? uh, it will not be exactly x of, it will be x of 0 delta of t, and then ultimately we will integrate, like somewhere integration will be performed, and with that delta of t will be gone, don't worry about that. Okay, and similarly, if you want to perform, if you want to get x of ts, right, what I will do, I will sample x of t, I will multiply x of t with t minus ts, and that will give me x of ts. Certainly the magnitude will be x of ts, certainly there will be an impulse, and this impulse will go away, don't worry. Currently you are seeing this impulse will go away. Okay, so that is the purpose. So that's why this is my sampler, this is the time response of my sampler. Cool. Now what is the frequency domain, what is the Fourier transform of this sampler? That will be used everywhere else, so you should know this. So just quick revision, this signal, right, is periodic, right? This signal is periodic. So certainly the Fourier series will be easier to calculate than Fourier transform. Okay, certainly that will be the case, we'll see that. Okay, so let us first compute the Fourier series. So Fourier series, because it is periodic, Fourier series will be there, because it is continuous and periodic, Fourier series should be there, right? Periodic, basically it repeats after ts, that is delta t. So what is the Fourier series basically? So my c of n would be 1 by ts, that is at one time period, integration from, so integrating one time period, so let's say minus ts by 2 to plus ts by 2, and in that time period what is the value of the function? That is delta of t, correct, into e raised to power minus j n omega s into t with respect to dt. Now I am multiplying delta of t, right? This will be certainly t will be put to 0, right? If t is 0, this is 1. So integration of my delta t from minus ts by 2 to plus ts by 2 of delta t will certainly be 1. So my Cn is always equals to 1 by ts for all n. For any n, it is always equals to 1 by ts. Very beautiful result. Okay, that certainly we will use. So if I reconstruct my continuous time signal x of t, it can be written like this: Cn, hold on a second, yes, Cn into e raised to power j n omega s t, correct? N will be going from minus infinity to plus infinity. So Cn is 1 by ts, so 1 by ts can be taken outside, right? For all n, it is always 1 by ts, that is equals to minus infinity to plus infinity e raised to power j n omega s t. Now, can you tell me one thing? What is the Fourier transform of delta of t? It was 1. If you remember, it was always 1. Fourier transform of delta of t is 1. You can again derive it from the basic equation. Now, if I apply the principle of duality, so Fourier transform of 1 would be 2 pi into delta of omega. Okay. Now, what will be the Fourier transform of e raised to power j omega st? That will be basically 2 pi will be there, and I am multiplying 1 with a complex exponential. So in the frequency domain, it will be shifted in the opposite direction. So this will be 2 pi into delta of omega minus omega s. So I am adding up all these exponentials. So ultimately what will happen, the Fourier transform x of omega would be 2 pi by ts, that is there in the constant, and this also will be sum of what? Impulses. This will be sum of impulses, that is pi omega minus n omega s. where n is going from minus infinity to plus infinity. Because I have sum of complex exponential, same thing will happen with the Fourier transform, right? And this does make sense, because if you plot the Cn, right, you see these are all impulses. These are all, so these are not impulses, these are all basically 1 by Ts magnitude, correct? 1 by Ts magnitude. So Fourier transform would be somewhat similar to this, okay, because it will Fourier transform would exist. Basically, if I plot the Fourier transform, it will be there will be Fs, then at t equals to 1 also there will be an impulse, right? There will be 2Fs, this will be 0, this will be minus Fs, minus 2Fs, okay. So all these will exist, right? So yeah, cool. Now I hope you got the point. So this thing you will have to, if you, it's good if you remember, right? Of course you can derive, it will not take you much time to derive, but it's good if you remember. But you should know how to derive. Even if you forget, you should be able to derive this result. Okay, this is a very, very important result that you should certainly know. That is point 1. Point 2, let's now come back to our topic. Okay, so if this is my Ct, right, the Fourier transform would be this. Here we have written this in terms of f. Don't worry, you remember in terms of omega. If you ever have to replace this, if you ever have to go back to f, right, so replace omega with 2 pi f. Everywhere replace omega with 2 pi f. So this will be 2 pi f minus n into 2 pi fs. So what is happening? Ultimately, I can take the 2 pi common, and you know delta of at would is equals to 1 over mod of a into delta of t. So this 2 pi can come outside actually in the denominator. 2 pi will be cancelled. Ultimately, this will be converted into 1 by Ts n goes from minus infinity, or 1 by Ts is what? Fs simply, right? Inverse of the time period, sampling time period. Delta f minus n fs, right? Delta of f minus n fs, okay? So yeah, I hope you get the point. You get the point that what is the Fourier transform of this, right? Okay, so now if so that's how we got to this result, okay. Now what we do is, what is a sampled signal? It is simply multiplication, right? There is a multiplier here, right, and this is my sampled signal ms of t, that is multiplied with the impulse. So multiplication with impulse is actually convolution in the time domain, convolution in the frequency domain. So there is a convolution with impulses, right? If there is a convolution with impulses, what happens? Simply it is the same signal shifted, right? So we are essentially shifting the signal. So if my message signal has a frequency spectrum from minus fm to plus fm, that is the maximum frequency, right? So what I am doing, essentially I am shifting my signal, right, by fs. So this is the shifted signal. That is what we do in a sampler. This is the output of the sampler, okay. Now most important point here, if I want to properly reconstruct my signal, what filter do I need to pass through so that I can get, so this is my original frequency response, right? After sampling, I got these many components which are unwanted. All I want is this part. This was my original signal. So what do I need to do? I need to certainly pass it through a low pass filter. If I pass it through a low pass filter, then certainly I will be able to reconstruct my signal. But before that, there is another problem. As soon as you perform sampling, what happens? You got multiple frequency responses, and if the maximum value or maximum frequency of your message signal is greater than this value, right, after shifting, right, we are shifting, this is the first shift, that is fs minus fm, what will happen? These two components will be added, and you will actually never be able to reconstruct your old signal. That is never possible, okay. So I'm just giving you overview what happens. So that is not possible. If that is not possible, what will happen? You will not be able to reconstruct your old signal, then you will lose information. So this condition must satisfy to avoid, this is called as aliasing. Basically, the two components are added, right? The next shifted component and the original frequency component, both of them are added. That is called as aliasing. So to avoid aliasing, the minimum sampling frequency should be twice of the maximum frequency. How do we get it? So basically, this particular value must be greater than fm. So fs minus fm must be greater than fm or equals to is also fine, right? Exactly, equals to is also fine, just fine. So basically, your fs shall be always greater than or equals to 2fm. Basically, your sampling frequency shall be greater than or equals to 2fm. Okay, so minimum value of sampling frequency is twice the message signal frequency. Whatever is the message signal, maximum value of the message signal frequency, that will be my sampling frequency, and this particular frequency is called as the Nyquist rate. That's it. Okay, so fs equals to 2fm. This particular thing is called as Nyquist rate, but this has no relation to do with sampling, and you will not blindly apply the Nyquist rate everywhere. Don't blindly apply this. Okay, remember the derivation, remember this part. To properly reconstruct my signal, my fs minus fm must be greater than fm. Remember this part. Okay, in this case, it is getting fs shall be greater than or equals to 2fm, but this will always not be the case. Sometimes the sampler things will be different. If the things are different, then you will not be able to solve it like this. You will not be able to solve it like this. Okay, just be careful. Okay, so this part was to avoid aliasing. Now the second part is, again, if I want to properly reconstruct my signal, of course I don't want all these frequency components. I need to pass my sampled signal through a low pass filter whose cutoff frequency should be what? Whose cutoff frequency shall be less than fs minus fm, certainly, because I don't want any of this, but certainly whose cutoff frequency must be greater than fm. So that is what is written here. For a proper filter, cutoff frequency must be less than fs minus fm, and cutoff frequency must be greater than fm. So these are the two conditions for proper recovery. Okay, for no aliasing and for proper filter. Okay, so there are few terms. When fs is very greater than 2fm, then we oversample, and that is fine. There will be loss of energy. That is a separate topic, but this is fine. But if fs is equals to fm, this is called as critical sampling. You are just at the edge, boundary condition, right? And if f is less than 2fm, then it is called as undersampling. You will not be able to reconstruct your signal. Okay, so that is a bit of intro. Now few more things are there, like, okay, like this, right? So remember, because you will have to construct a low pass filter, and remember, although it feels like this is not a low pass filter, because whatever you know the low pass filter like this, right? But low pass filter, this is the frequency response of a low pass filter. We know all real systems, their magnitude spectrum is even. So actually we never draw it because we never discuss about negative frequency, but it will be always even. So in the negative side also this will be present. Actually in the negative side also this will be present. Okay, so yeah, that's what a low pass filter is, right? I think, yeah, also you should remember this thing, that what is the time domain function of a low pass filter, right? Basically Fourier transform of a low pass filter is a rect signal, and what is the time domain expression for that. So these are the two things that you need to remember. So let's come back to our questions and solve few questions. This is the first question. A band limited low pass signal xt of bandwidth 5 kilohertz. Okay, so basically if they're telling the bandwidth of xt is 5 kilohertz, basically they're telling me that my xt, right, the frequency spectrum of xt, that is x of f, will exist. I don't know whatever is the frequency spectrum, but certainly it will exist between, bandwidth is 5 kilohertz, so certainly it will exist in this region. Okay, so basically the maximum value of the frequency spectrum where it is non-zero shall be 5 kilohertz. Okay, so what information they have given me? They have given me what is my fm. What is my fm? So fm value is given to me, that is 5 kilohertz. Is sampled at a sampling rate of fs. So it is sampled at fs. Cool. The signal xt is reconstructed using reconstruction filter as shown. So we are sampling it. So after sampling, how will the frequency response look? So frequency response will look like something like this, right? So this will be the frequency response. Like I'm just drawing this, anything can be here, I don't care. This is -5 plus 5, and then again there will be this center will be shifted by Fs. So this will be Fs, this will be -5 plus Fs. Hold on a second. -5 plus Fs, and this will be 5 plus Fs. Okay, and again for no aliasing, your -5 plus Fs must be greater than 5. So basically your Fs must be greater than 10 kilohertz for no aliasing. Okay, this is one condition, right? And now what are they telling me? Now it is passed through a filter as shown. Okay, so of course the filter that I'm concerned about is the gain at 5 kilohertz, right? What is the gain at 5 kilohertz? The gain at the 5 kilohertz, so in this range, right, from -5 to 5, that is what I'm concerned. The gain is constant, that is k. So it is always constant. The gain is always k in where my like whatever is my frequency of concern, right? It is always 5 kilohertz. Okay, that is constant. Okay, whose magnitude is this? The minimum sampling frequency for perfect reconstruction of the signal shall be. What is the minimum sampling frequency for perfect reconstruction of the signal? Okay, now you will say, sir, I got to this condition that your Fs must be, like, for no aliasing, your Fs must be greater than 10 kilohertz. So the minimum sampling frequency you will say is 10 kilohertz, and you will be wrong. Why you will be wrong? Because what you have to take care is that make sure your cutoff frequency, right, this whatever is the passband frequency, 8 kilohertz, this must be less than this value. If let's say -5 plus Fs, let's say Fs is 10 kilohertz. If Fs is 10 kilohertz, right, then I will have, so this will be my frequency spectrum of the sampled signal, correct? So this is -5, this is 5, this will be 15, correct, and so on. What is the problem? The problem is, if I see at 8 kilohertz, or let's say at 7 kilohertz, I see this particular point, right, and 7 kilohertz, the gain of the filter is actually not 0. If the gain of the filter is actually not 0, it will pass this component. Then what will be the frequency spectrum of the passed component? Because I'm multiplying by the magnitude, right? So the frequency spectrum would look somewhat like this. Now, is this the frequency spectrum of my original signal, right? It is simply a triangular kind of thing, like whatever is inside that band, I don't care. But I don't have any values outside 5 kilohertz, right? But I see my frequency spectrum of the recovered signal, there is some non-zero component at 7 kilohertz, whatever values, right? So that is a problem. So certainly this value must be greater than the pass band frequency. So this is the second condition for proper filter operation. So what needs to happen? Basically this value, right, -5 plus Fs, -5 plus Fs must be greater than the pass band, because beyond this the gain is 0, I don't care, it will not pass anything beyond this, right? So this particular frequency, this particular point must be greater than 8, so that this particular points does not get passed. So this must be greater than 8, so Fs must be greater than 13 kilohertz. So there are two conditions. For no aliasing, Fs must be 10 kilohertz. For proper filter operation, Fs must be 13 kilohertz. Which one will you choose to reconstruct your original signal? You will choose this one, right? You will choose this one. Fs must be greater than 13 kilohertz. So that is your minimum sampling frequency. Your minimum sampling frequency is 13 kilohertz. That is your answer. Okay. Let's solve the next question. So this is the next question. Consider a real valued baseband signal which is band limited to 10 kilohertz. So my signal is now band limited to 10 kilohertz. Okay. The Nyquist rate for the signal yt, this, what will be the Nyquist rate? So they are simply asking me the Nyquist rate. If they are simply asking me the Nyquist rate, that basically means assume you have an ideal low pass filter. You have an ideal low pass filter. Then what is the Nyquist rate? Nyquist rate is nothing but 2f. That's all. This has nothing to do with the proper reconstruction of the signal, right? Nothing to do with that. Simply you assume you have an ideal filter, ideal low pass filter, and your Nyquist rate is 2 times the maximum frequency component. What is FM? What is FM basically? What is FM? So FM, if you see, right? So let's take a very basic example, right? If I have, let's say, sine of t into sine of t by 2, right? So this will be, there will be two terms, sine A into sine B. So you will have what? Cos of A minus B, cos of A minus B, that is t minus t by 2, minus cos of A plus B, t by 2. So what is the highest frequency component that we have? So this has frequency of 1 by 2, right? Omega is equals to 1 by 2, right? Here what is the frequency? Omega is equals to 3 by 2. So the highest frequency component is 3 by 2, right? So what you have to do, you have to simply add these two numbers, add the frequencies of both these signals, and that will give you the highest frequency component present in the signal, right? All I care about is the maximum frequency component that is present in the signal. So in this case, xt has a frequency, maximum frequency component of 10 kilohertz. X of t by 2 will have what frequency? 5 kilohertz, right? So what will be the overall maximum frequency component of yt? It will be 10 kilohertz plus 10 by 2, that is 5 kilohertz. That is the maximum frequency, correct? And we have to compute the Nyquist rate. So Nyquist rate would be twice the maximum frequency, that is 2 into 15, that is 30 kilohertz. Okay, so your answer would be 30 kilohertz for this particular question. Your answer would be 30 kilohertz for this particular question. Okay, that's how you solve it, right? Your y of t simply will be band limited between like minus 15 to plus 15. Okay, I hope that part makes sense. Now let's solve the next question. This is the next question. Let x1 of t and x2 of t be two band limited signals having bandwidth. Okay, just 1 second. Yeah, sorry for that, sorry for the noise. Let x1 of t and x2 of t be two band limited signals, okay, having bandwidth b equal to this. So both of them have the same bandwidth. Basically the maximum frequency is 4 pi. Maximum frequency is, if I compute, okay, they are asking in radian only, so maximum frequency omega m is equals to 4 pi into 10 cube radian per second. In the figure below, the Nyquist sampling frequency in radian per second required to sample y of t. In the figure below, the Nyquist sampling frequency in radian per second required to sample y of t is what? Okay, what is the maximum sampling frequency in radian per second required to sample y of t? Okay, or sample y of t. Okay, so if I am multiplying by cosine, right? What happens? Do you know what happens if I multiply by cosine? So cosine is just combination of complex exponentials. So your signal, right, in the frequency domain, if let's say x1 had maximum frequency of f of 1, it will be left shifted and right shifted. I hope you know this, right? So if I'm multiplying, so your cos is combination of exponentials. So in the frequency domain, you are just shifting your signal. So your maximum frequency also will be shifted by what? By this value. Okay, so this will be omega m plus this value, 4 pi into 10 cube. That is for the first part, right? For the second part, it will be, because this both of them have identical bandwidth. So it will be omega m plus 12 pi into 10 cube. I will not explain all this, right? Because we have covered this in Fourier transform. If I multiply by cos, this is nothing but a multiplier. And if I am multiplying by cos, what will happen? Simply in the frequency domain, the frequency spectrum will be shifted right once and left once by this particular frequency. Okay, this has been covered in Fourier transform and cos omega t. I hope you know this, right? I'm just explaining you. I hope you know this. If you don't know, you need to revise. So now, what is the maximum frequency component present at the adder? Maximum frequency component is this one, right? That is present at the adder. That is equals to omega m plus this. So 4 pi into 10 cube plus 12 pi into 10 cube, that is 16 pi into 10 cube, correct? That is present at the adder at y of t. So what is the Nyquist rate? Nyquist rate would be twice of this. So it will be 2 times this, because I will assume I have ideal low pass filter. So this would be 32 pi into 10. Okay, so your answer would be option D. Very good question, very beautiful question. All you need to know is what happens when I multiply a signal by cos. The frequency spectrum is shifted right and left. Okay, so 32 pi into 10 cube, option D would be the correct answer for this question. Let's solve the next one. So this is the next question. A continuous time signal x of t is equals to 2 into cos 8 pi t plus this, right, is sampled at a rate of 15 hertz. Okay, and the sampled signal x of s is passed through an LTI system with impulse response this. Okay, pretty interesting. We have a cos component as well. Okay, this is nothing but sine, right? Basically sine of 38, but basically this is nothing but sine of 38 pi t. Okay, that is fine. It produces an output of x naught of t. The expression for x naught of t shall be what? Okay, the continuous time signal is sampled. Let me think. So it is an LTI system, right? It is an LTI system. Okay, so certainly the output also will be like it is somewhat like eigenfunction, but for it to work properly, I have to check whether my sampling frequency is proper or not. My sampling frequency is proper or not. So let me first try to draw the frequency spectrum of the low pass filter. This is nothing but a low pass filter, right? Let me try to draw it. So I'm not comfortable with this, right? I don't understand anything. So I'm comfortable with this. So this is similar to a sampling function. Let me convert this first to a sampling function. So sine of 2 pi t upon pi t, sine of 2 pi t upon pi t, right? So this can be written, if I multiply and divide by 2, right, this will be equals to 2 of sampling of 2 pi t. Okay, 2 of sampling of 2 pi t, and I will come to this, don't worry, I will come to this later. So this is the function. Now what I am concerned about is this. I know this, right? Rect of t upon tau is actually equals to, like, the Fourier transform of this is basically a rect of t upon tau is a tau into sampling of omega tau by 2. Okay, omega tau by 2. So that is what my rect of t upon tau is equals to, right? So what will be, now if I apply the principle of duality, this will be tau sampling of omega, sorry, not omega, t tau upon 2. This will be rect of omega by tau. Minus is there, but because it is an even function, so minus sign will not be accounted for. Okay, so this is what I know, right? So in our case, I can take this tau on the other side, okay, and I can multiply by a to make it proper. and obviously don't forget there is a 2 pi, don't forget there is a 2 pi, right? There is a 2 pi multiplied, there is a 2 pi multiplied. Okay, don't forget to multiply 2 pi. Now we are fine. Now what is the tau? So our tau by 2 is actually equals to 2 pi. So our tau is actually equals to 4 pi. Tau is 4 pi and our a is 2, right? A is 2, tau is 4 pi. So this will be 2 pi into 2 upon 4 pi rect of omega upon 4 pi, right? So this will be basically 2, so gain would be 1. So pass band gain is 1, so it is nothing but rect of omega upon 4 pi. So your signal would be this, minus 2 pi, 2 plus 2 pi omega, and this is your function, not exactly because this is not the impulse response, right? Now what we need to do, this is the rect function, right? Now we are multiplying this with sine of 38 pi t. What is sine 38 pi t? Sine 38 pi t is equals to e raised to power j 38 pi t minus e raised to power minus j 38 pi t divided by 2j, correct? So this thing will be shifted and then multiplied by j, the phase will be different, that is fine. This thing will be shifted by minus 38, so right shifted by 38 pi. If I right shift this thing by 38 pi, right, so I will be somewhere here, okay? So this will be 38 pi, this will be 40 pi, this will be 36 pi, and what will be the magnitude? This magnitude will be, remember I am multiplying by 1 by 2j, okay, multiplying by 1 by 2j. The magnitude was 1, here I am multiplying this by 1 by 2j, so this will be actually 1 by 2j, okay? And similarly I am left shifting this here, the magnitude spectrum is actually even but the phase spectrum is odd, okay? So don't worry about it, magnitude spectrum is even, right? Because if I take the mod of 1 by 2j, mod of minus 1 by 2j, it will be same, right? So don't worry about it. So this will be actually minus 1 by 2j and it will be left shifted by 38. So this will be minus 38 pi, this will be minus 36 pi, this will be minus 40 pi, okay? Okay, so we got our filter, right? And now what are they telling me? There's a continuous time signal is sampled at a rate of 15 kilohertz, okay? If it is sampled at a rate of 15 kilohertz, what is the frequency spectrum? So I certainly know what is the frequency, like it is cos 8 pi t, right? So the frequency spectrum of my signal, right, x of omega, what is the maximum value of the frequency that is present? It is certainly 2 impulses, certainly I know it because it is simply exponential, right? I know this, it will be impulses, but the maximum frequencies that is present is 8 pi, right? And we are sampling at 15 hertz, okay? So my if you are sampling at 15 hertz, right, so there will be a shift. So what is in frequency terms, what is this? This is 4, right? 8 pi by omega m is 8 pi, so divided by 2 pi, that will be 4 hertz, and we are sampling at 15 hertz, so it is fine. So there will not be any aliasing, I don't have to worry about it, there is no aliasing because my fs, right, Nyquist rate of sampling is 8 hertz, which is greater, which is less than my actual sampling rate. So certainly I don't have to worry about aliasing, there will not be any aliasing, so I can ignore this fact, okay? So all I know is I have 8 pi component that I am passing through the low pass filter. Now if I have 8 pi component, right, will anything be passed? Okay, hold on a second. Okay, something is happening. So certainly I know this is cos omega, cos of 8 pi t, right? And I know it will have 2 impulses, right? One will be at plus 8 pi, because if you break this down into exponentials, this will be e raised to power plus j 8 pi t minus plus e raised to power minus j 8 pi t upon 2, right? I know this. So there will be one 8 pi component here impulse, another 8 pi impulse here, right? Because if I do the Fourier transform of a complex exponential, I get impulse. Certainly we know that. Now the interesting part is, if I am sampling it at 50 hertz, so there will be another, so if I am sampling at 8 hertz, right, what will happen? So this will be copied again after what? At fs, right? So this particular frequency spectrum will be copied after fs, right? So everything will be, so what will happen? This 8 pi will be shifted by fs. So what do you know what used to happen in sampling? So now the original signal, nothing is getting passed. Okay, that is point one. Point one, the original signal has a frequency bandwidth of 8 pi, correct? And I see my low pass filter, right? It passes components from 36 pi to 40 pi. So 8 pi is somewhere here. So nothing will be passed for the original signal, but we are sampling it. And what happens in sampling? In sampling, if you remember, if let's say I have a frequency like this, right, which exists from minus 8 pi to plus 8 pi. So again, because I am sampling, it will be shifted, everything will be copied and shifted by fs, right? This will be going on till infinity. So this point, 0 point will be shifted to fs or omega s, if I say, and this point will be minus 8 pi, this point will be shifted by fs, right? So the left hand side will also be shifted by fs. So minus 8 pi plus omega s, correct? So what is omega s? Omega s is what? So fs is 15 hertz, omega s is 30 pi. So actually omega s is 30 pi, right? So this left hand side point, right, that is a left impulse basically, right? Left impulse. For in my case it is just the left impulse, right? We have only two impulses, one impulse here, one impulse here, that's it. So in our case what will happen? Just to properly show you, in our case after sampling what will happen? So this impulse, this left impulse will be shifted by fs, right? I will get impulse here. What will be the frequency at which I will get the impulse? That will be so this is minus 8 pi, sorry, minus 8 pi plus 30 pi. So that is 22 pi, right? And then there will be another component, that will be what? That will be plus 8 pi plus 30, that is 38 pi. Okay, like very interesting stuff is happening. Now this will be passed, this particular component will certainly be passed. Okay, what is happening in the left hand side? In the left hand side also something similar will happen, right? So this point can be left shifted by minus fs, right? So basically minus omega s. So I will get a component at minus 22 pi, and then I will again get a component at minus 38 pi, and certainly I see that minus 38 pi is a pass band, right? After this I will not get, like, in this pass band, right, my main concern is what frequency components are in the pass band. So in the pass band I have two frequency components, this one and this one. Okay, so and this will have, let's assume this will have some multiplication factor of k, this also will have some multiplication factor of k. Let's for a second assume that, right? So with k, now I am multiplying these things, right? I am multiplying minus 1 by 2j to the minus 38 component, correct? So there is a impulse of minus 1 by 2j to the minus 38 component. So this I am talking about after the output, right? The output x naught of t, right? After passing it through the filter, right? Only minus 38 pi and plus 38 pi, these two components, these two impulses will be passed. So minus j 38 pi and plus j 38 pi. Now this will be k minus k by 2j plus k by 2j. I don't care about the magnitude for now. For now I don't care about the magnitude. Okay. Do you know what is the, this is the Fourier transform of my output signal. Do you know what is the inverse Fourier transform of this? So whenever we have impulses in the opposite fashion, that means we will get a sine function. We will certainly get a sine function. Okay, we will certainly get a sine function. That is certain, right? And what will be the magnitude of the sine function? Magnitude of the sine function would be, because this is not providing any change. Okay, this is multiplying by minus 1 by 2j, this is just multiplying by 1 by 2j. this is not providing any change, so I will certainly get a sine function. Okay, now whether it will be sine 38 pi plus pi by 3 or minus pi by 3, that we will have to consider, that we will have to see how to consider that. Okay, how to consider that, I'm just thinking. Intuitively, can we do this? Certainly we'll get a sign. Okay, certainly we'll get a sign, but intuitively can we do this? So what is the value of k basically? What is the value of k? So k would be, what would be the value of k? So k, right, k would be simply, in omega domain it will be 2 pi by 2, correct? So it will be simply pi, correct? It will be simply pi. Am I correct? So this will be shifted, I will multiply 2 pi by 2 is there, so yeah, this will be pi and pi, that's all. In omega domain this will be pi, this also will be pi. Okay, it will be simply pi. Okay, it will be pi, and here also it will be, because k is pi, right, k is pi, pi by 2j minus pi by 2j. Is it so? Okay, just a small change here, because I have this pi by 3 as well, right? So maybe I should break down this function, because there is a phase shift. Okay, why have they provided phase shift? That makes the question even more difficult. Okay, uh, that makes the question even more difficult. Let me change it, right? Just give me 1 second. Let me change it. uh okay, okay, 2 is also there, right? In the front 2 is also there. Cos a plus b, okay, uh, just thinking whether I can make any changes or not. That is what I'm thinking. Let's yeah, let's make bit of changes, because this pi by 3 will be pretty bit difficult for me to tolerate. So this is 2 cos a plus b, right? Cos a plus b is nothing but uh, cos a plus b, right? So it will be cos b minus sin a sin b. Okay, so cos a cos b, 2 into cos a cos b, cos of 8 pi t into cos b is cos 60, right? What is sorry, yeah, what is cos 60? It is half. So this will be multiplied by half, then minus sin a sin b. So sin of 8 pi t into sin of 60. Sin of 60 is root 3 by 2, right? So if I'm multiplying by 2, right, what will happen? This 2 will go away, that's it. So this is the expression. So I have both a cos and a sine function. Okay, so both cos and sine function, right, both are present. Okay, don't worry, I'm just drawing the frequency response of cos. Sine also same thing will happen. Okay, don't worry, don't take the stress. Okay, so with cos, what will happen? This cos component will have two impulses, right? 1 by 2j and, sorry, 1 by 2 and 1 by 2. So this will not be pi actually. Oh sorry, this will be pi only, right? This will be pi plus pi plus pi. Yeah. So cos component will have two impulses, plus pi, and that plus pi will come here. Okay, and I will get a sine component out of it. So basically this is the Fourier transform of a sine function. This is the Fourier transform of a sine function. Okay, minus pi by 2j plus pi by 2j. This is the Fourier transform of a sine function. Here I have plus pi minus pi, right? So what will be the frequency of that sine function? That is what I am thinking. What will be the frequency of the sine function? Frequency would be 38 pi. Certainly it will be 38 pi. But what about the magnitude? Okay, magnitude I will have to compute. Magnitude I will have to compute. So this has a magnitude of 1, that gets here, that gives me pi. Okay, so this gives me pi. So pi is here, it pi by 2j minus pi by 2j. Now basically I have, this is my, for cos 8 pi t, this is the output of my filter, right? That is what is this? So x naught of omega is simply equals to pi by 2j delta of omega minus 38 pi and minus pi by 2j delta of omega plus 38 pi. Okay. So if I take the inverse Fourier transform, so what is the inverse Fourier transform of? So 2 pi delta of omega has a inverse Fourier transform of 1. Okay. So pi delta of omega will have an inverse Fourier transform of 1 by 2, and just give me a second, right? Yeah. So pi delta of omega will have a Fourier transform of 1 by 2, and if I give a shift in the exponential, let's say omega naught t, then this by 2 will have a Fourier transform of pi delta of omega minus omega naught. So that is what I am doing. So what will be the Fourier transform of, so I can take 1 by 2j common, right? I can take 1 by 2j common. It is not a matter of concern to me. So pi delta of omega minus 38 pi will have a Fourier transform of j e raised to power j 38 pi t upon 2. Then this will have a Fourier transform of minus j e raised to power 38 pi t upon 2. Okay. So this is what? This is simply nothing but 1 by 2 of sine of 38 pi t. Okay. 1 by 2 of sine of 38 pi t. So this gets converted to sine of 38 pi t. So your cos 38 pi t, right, has been changed to sine of half sine of 38 pi t. Because the system is LTI, I can comment what will happen to what? Root 3 into sine of 8 pi. So this, sorry, because it was 8 pi, don't worry, even if it's 8 pi, you will say, sir, how is the frequency component different? Because there are a lot of filters, sampling is happening, that's why. Okay, don't worry. So similarly with intuition, for sine of 8 pi into root 3, right, what will happen? You see there is a phase shift of minus 90, right? So if I shift this by minus 90, this will be minus cos of t. So this will be, I will have to multiply by half, and this will become minus of cos of 38 pi t. Okay. Now, but how am I getting 15? How are they getting 15 here? I'm just curious. Okay. You are curious. I'm also curious. So whenever we are sampling, right? Whenever we are sampling, we have to multiply by 1 by ts as well. We'll have to multiply by 1 by ts. Correct? Yes, the Fourier series coefficients also will be multiplied by 1 by ts. Sorry, there will be multiplication of what was that? That was 2 pi by ts. If I am correct, yeah, that was 2 pi by ts. So I forgot this. We will have to multiply this by 2 pi by ts as well, right? Yes. So whenever we are performing sampling, right? So that is the Fourier transform of this, and wherever we are performing the sampling, just as we have discussed just here, where was it? Here. So our x of omega becomes 2 pi by ts. So we will have to multiply this term as well, 2 pi by ts, right, in the omega domain. Don't forget this. So if I have to multiply by 2 pi by ts, this will be converted into 2 pi square by ts. I know this is a bit complex, but if you are following the lecture, you will be able to do it. 2 pi by ts. Ts is my sampling frequency. Ts is my sampling time period. That is 1 by 15, right? So simply it is simply 30 pi square. Am I correct? Is it pi? Hold on a second now. Okay, pi is already there. Why is pi there? Why is pi already there actually? Okay, why I have kept pi previously? Oh, because this, the what was the Fourier transform of this actually? In frequency domain, in omega domain, Fourier transform of this would be 2 pi into del of this, right? 2 pi into del of omega minus omega naught, isn't it? Exponential. Hmm. So there will already be a pi. Okay, there will already be a pi multiplied. Hold on a second now. There will already be a pi multiplied because it is just the Fourier transform of this particular term, right? That is e to minus 38 pi plus 38 pi is pi delta of omega. Now I am passing it through a filter. I'm sampling it, right? If I'm sampling it, what happens? So if I'm sampling it, it's like sampling the impulses, right? So this particular thing is a constant. This will be multiplied there. There will be another additional pi square there. Okay, there will be additional pi square. Just thinking, give me a second. This ts, right? One by ts. So what is happening here? So here so what I am observing is I need to multiply this by so 2 pi by ts, right? And ts is 1 by 15. So 2 pi into 15, that is 30 pi. I have to multiply this by 30 pi. So this will become actually 30 pi square, and this will also become 30 pi square because I'm multiplying 2 pi by ts due to the sampler gain, right? Due to the sampler gain. Okay, is the sampler at rate of this? Okay, if it is 30 pi square, then here I will have, basically this will not be pi only, this will be 30 pi square, this will be 30 pi square. Okay, all it will do, it will change the gain. So now if I reconstruct this, here I will have 30 pi square, right? So just a small change, I will have to multiply this by 30 pi also. So this will be multiplied by 30 pi. Now I don't know, maybe I'm making a mistake or not. This is getting multiplied by 30 pi. Okay, because I had what is the magnitude here? The magnitude was half, right? So I will have to multiply 30 pi because that is a constant number. That is simply the sampler gain. So that would be 15 pi in this case. But I think this pi is not there. I'm messing it up. You guys can let me know in the comments below where I'm messing it up. Pi should not be there actually. I don't know. So here also it will be multiplied. It will be scaled by 15 pi, right? So same thing will happen here. So this will become 15 root 3 pi. But pi should not be there. I don't know why pi is there. Somewhere I'm messing up. Pi should not be there. Actually in the final result, right? This pi should not be there. I don't know where I'm messing up. Maybe I'm messing up somewhere. I don't know. So actually what happens, this is the components. So if I add these two components, right, 15 is the common part, sine of, so what I can do is I can take 30 common. Okay, this will become 1 by 2 sine of 38 pi t minus root 3 by 2 cos of 38 pi t. Okay, so now we can do it. So this is again sin a sin b format. So if you see, it is sin a sin b, you can do sin a cos b minus sin b cos a, right? So where a is 38 pi and cos b, this would be 60, right? So this is essentially sine of 38 pi minus 60, that is pi by 3. Okay, just one small change. Actually your signal, right, it is minus of sine 8 pi t. So here there will be a negative sign. If there is a negative sign, this will be plus. Okay, I'm not sure about the magnitude. Somewhere something is missed. You can check it. Okay, so there will be a minus sign. This will become plus. Then if this is plus, this will be sine a plus b, not a minus b, sin a plus b. So sin 30, I don't know why the pi is missed, I don't know. So okay, sin 30 sin 38 pi plus pi by 3, or this can also be written as 30 cos 38 pi t. Don't forget there is a t, right? Don't forget there is t. Don't forget the t. Minus pi by 6. Okay. So yeah, 30. I see 30 cos. Okay, no, there is 30. Okay, maybe there is a, I don't know, maybe there is an additional, I am forgetting to divide by 2 pi somewhere, because I am guessing there we need to divide by 2 pi somewhere. I don't know, maybe we need to divide by 2 pi somewhere. I am multiplying by 2 pi extra. It seems like I am here multiplying by 2 pi extra. Why am I multiplying by 2 pi extra? I exactly don't know. Okay, maybe the sampler gain is, okay, I don't know, it is 50, I don't know, it seems like I'm multiplying by 2 pi extra. Okay, I don't know why I'm multiplying, you guys can figure out. I am not able to figure out, unfortunately. So here there will be 15. Okay, I'm sorry, I'm not able to figure out where I'm multiplying 2 pi extra, because everywhere the magnitude is same. So I know that will be the answer, but somewhere you guys can let me know in the comments below exactly in which time I'm multiplying by 2 pi. Maybe I can pin that in the comment. But our answer would be cos of 38 pi minus pi by 6 and sine of 38 pi plus pi by 3. So option A and C all are correct. I think this was MTA in 2024. I don't know. I think there is some pi ka problem hai. I do think, because I am seeing this is MTA. This is given as MTA. Right, so there is some magnitude problem. Either I am doing something wrong, or maybe I am doing correctly. Okay, so maybe I am doing everything correctly. This is 30 pi only, right? I'm guessing this is 30 pi only. Okay, so because I saw this question was given MTA, so not so sure why this was given in MTA, but I think they missed a factor of 2 pi. That is my assumption. They missed a factor of 2 pi. Okay, so but if you go by the options, if you reduce the 2 pi factor, then these two options are matching. Okay, yeah, let's solve the next question. This question is again very very interesting. Okay, and I will highly recommend you to go and watch this video for the proper solution of this question. Okay, here I'll not give the complete solution, because that will, again, already the video is extended, it will go even further. I don't want it to go even further, right? So basically what happens, you have a continuous time finite energy signal f of t, right? It is a continuous time finite energy signal, so it is a finite duration signal in time domain, whose Fourier transform vanishes outside the frequency omega c plus omega c. Basically the frequency spectrum of this signal f of omega, it vanishes from plus omega c minus omega c to plus omega c, correct? So it vanishes. Now the signal f of t is uniformly sampled to obtain y of t. So we are sampling the signal f of t, uh, uh, sampling it with p of t. P of t is this. So this is a bit peculiar than what we already know. If you see, there is a phase shift of tau. Our sampling function was what? It was del of t minus nts. And what was the Fourier transform of this? The Fourier transform of this was 2 pi upon ts. Like this was this was our p of t, right? It was 2 pi upon ts delta of omega minus n omega s, correct? N is going from minus infinity to plus infinity, that is understood. But here we are providing a phase shift of tau. So our p of t, right, has a phase shift of tau, that's it. Will that make any difference? So what happens if I have a phase shift of tau in time domain? If I have a phase shift of tau in time domain, what happens? Then a complex exponential is multiplied, right, in the frequency domain. What will be the value? It will be e raised to power minus j tau, that is it, right? Yeah, that is it. e raised to power minus j tau, uh, complex exponential is multiplied. So if I have a signal x of t minus t naught, right, what happens if xt has Fourier transform of x of omega? What will be the Fourier transform of x of t minus t naught? It will be e raised to power minus j, I think there is this omega as well, omega t naught. I will have to check. So let us check it actually because I also tend to forget these things. Okay. If I okay, let's take a very basic example, right? So xt has a Fourier transform of omega. What will be the Fourier transform? So x of what is x of omega? X of omega is equals to minus infinity to plus infinity x of t e raised to power minus j omega t dt, right? Now if I am, let's say I'm calculating y of omega, that is equals to, like, so that's how you remember it. If you forget, derive it. I know it's like everything you will not be able to derive in the exam hall, so you leave it for later. You even if you have doubt in this question, you leave it for later, mark for review, leave it for later. Okay, t minus t naught, right? I want to calculate the Fourier transform of this particular signal. So what I can do technically is I can replace, okay, there will be a omega term, right? So I can replace my I can create a new dummy variable alpha, that is equals to t minus t naught, right? So your t would be equals to alpha plus t naught, and your d alpha would be equals to dt. So this will be basically minus infinity to plus infinity. Limits will not change, because if t is going to infinity, alpha also is going to infinity. X of alpha e raised to power minus j, I'm just deriving, all I'm doing, I'm just deriving, right? If I forget, I will derive in the exam hall. Minus j omega into t. So t is basically alpha plus t naught. So alpha plus t naught. Okay. So yeah, this, right, what will happen? This additional term minus, I will stop here, minus j omega into t naught. This will come at the outside. So this will be the additional term. So you will have minus j omega into t naught basically. So you will have here minus j omega into tau. Okay. Even if you forget, you can derive it in the exam hall. Like that's why I'm showing you all this, because I can show you everything is perfect. I remember every single thing. I forget, right? Like I have very bad memory. I forget almost everything. So it's good to build a habit to derive. Okay. So yeah, this will be the case. Now what you will do is, so this, right, only will affect the uh, only the phase. Okay, this will not affect the magnitude spectrum. So magnitude will not change. All it can do is change the phase. Magnitude of f of t will not change. And they have told me that this particular y of t is passed through an ideal low pass filter with h of t this, right, and with a pass band gain of t of s and cutoff frequency of omega c. So if I am sampling it, right, sampling it, they have not told me what is the sampling rate. Okay, sampling. So they are telling me if t of s is less than pi by omega c. What do they mean by t of s less than pi by omega c? I will explain. So for proper, if I want to reconstruct my signal, right, nothing is mentioned, everything is ideal. It is an ideal low pass filter and it is almost an ideal sampler. This just changes the phase. This will not change the magnitude. This will just change the phase. If it just changes the phase, then what will happen here? Then I don't care about this, right? I don't care about this. It will just change the phase. All I care is what will happen if I am able to properly sample my signal, right? So then I will have here, after sampling, the frequency spectrum would be something like this. Correct. If I have an ideal sampler, right? So this will basically match. This will be omega c and cutoff frequency is also omega c, and I will only pass this particular section, right, on my ideal low pass filter, and this particular point would be what? This will be equals to omega c would be equals to what? This would be, because this particular omega c will be shifted by plus fs, right? So this will be minus omega c plus omega s. I hope you get this point. This is the first starting point that we discuss, right? First point here, this part. If I am sampling it, this particular point will be shifted here, right? And in case of Nyquist rate of sampling, right, we want this to touch it because our low pass filter is ideal. It will only pass this particular section. Cool, understood? Now this is minus omega c plus omega s. So basically from here I can get the condition on omega s. So omega s must be at least greater than, so this particular part, right, this particular point must come after omega c. So omega c minus omega s must be greater than omega c. So I can get from this omega s must be greater than 2 omega c, correct? And so what will be the condition of Ts? So this is your, okay, hold on a second. So omega s is equals to what? Omega s is equals to 2 pi fs, 2 pi fs greater than 2 omega c. What is fs? Fs is 1 by Ts. So pi into fs, sorry, pi by Ts must be greater than omega c, or I can say Ts must be, both are positive numbers, must be less than pi by omega c for proper sampling. Ts must be less than pi by omega c, that I see only here, here and here in these two options. Certainly it will be either this one or this one. Okay, now many students might be confused here that whether there will be a phase shift or not. Okay, I know many students will be confused whether there will be a whether here there will be a phase shift or not. There will not be. Okay, why there will not be? Because once if this is your impulse, right, what happens if you are calculating? So all you're doing, you're shifting your signal by tau, okay, and then you're multiplying this with f of t. Okay, and do you know what happens when you multiply this by delta of omega? So I will replace here e raised to power minus j tau omega equals to n omega ts, right? This can be replaced, omega can be replaced here, right, because this is just a multiplication of delta of t. So if I replace by this value, this will be delta of omega minus n omega s, and if I replace omega with n omega s, this can be replaced omega with e raised to power minus j tau n omega s. So ultimately, right, now this is not even a function of omega, this is neither a function of omega. Okay, this is not a function of omega, this is not a function of omega. So ultimately in the frequency spectrum I don't have a term like this, I have a term like this which is constant. Okay, so certainly there will not be any time shifting. If there was a time shifting, then I would have had a term like this, right, which was a function of omega in the frequency spectrum, but I see this term is not present, right? So there will not be any phase shift. Now this is how I will solve intuitively. If you want to understand the complete solution, you can watch this video. Okay, in this video proper, I think 1 hour he has explained this solution, so you can go not 1 hour, like 30 minutes, 30 to 35 minutes he has explained this solution. You can go and watch it. Okay, my purpose was to give you a good revision. This question was very good question, like the best question of GATE. Okay, so you can go and watch this. We have to solve other questions as well, so I'm not going too much in depth here. Okay, now let's come to the double E questions. The double E questions will be much simpler than the EC ones, because in double E we don't have analog communication, so they ask very simple questions from double E. The output y of t of the following system is to be sampled so as to reconstruct it from the samples uniquely. The minimum required sampling rate would be x of omega is given, it is band limited between minus 1000 to plus 1000. Then I am multiplying this with cos of 1000 t. So essentially my frequency spectrum is getting shifted by 1000 pi, right? So this will be 2000 pi now, and this will be, okay, this will be actually 0. This will be 0, right, because this point will be shifted by 1000. so that will become 0. Okay, so that is the point. So we got this. Now it is passed through what? A low pass filter whose cutoff frequency is what? I see, whose cutoff frequency is 1500 pi. Okay, again if you want, you can do the Fourier transform, that you can do, but you certainly know whose cutoff frequency is 1500 pi. Okay, so its cutoff frequency is 1500 pi, right? You can do the Fourier transform. I hope you can do the Fourier transform. You can solve it. So for this sample, so as to reconstruct it from uniquely. So that will be the frequency spectrum after passing it through this low pass filter. Okay, maximum frequency, cutoff frequency as it is 1500 pi, so it will only pass the 1500 pi components. After that it will not pass. Okay, you can calculate, you can do that, you can do the Fourier transform, like we have done a lot of problems, you can do it, right? Now what is the problem here? The problem is what is the minimum sampling rate? Okay, what the output YFT of the system is to be sampled so as to reconstruct. So all we care, it's not like we want to reconstruct x of t. No, they are not telling me to reconstruct x of t. All they are asking me is to reconstruct y of t uniquely. What is the maximum frequency component of y of t? 1500 pi. They are not asking me to reconstruct x of t, right? They are not asking me that. They are asking me to reconstruct y of t. So maximum frequency component is 1500 pi. Now I will assume everything ideal, right? Low pass filter is ideal, properly cutoff frequency is there. So what is the Nyquist rate? Okay, for y of t, not for x of t, for y of t. So for y of t, maximum frequency is 1500 pi. So your omega s would be 2 into omega m for y of t, not for x of t. I am saying it again, not for x of t, for y of t. So this will be 3000 pi. Now this is in radians per second. We want in samples per second, basically per second, right? So I can divide it by 2 pi. That will give me the value in hertz, that is 1500 samples per second. So that is present in option B. Pretty good question actually, because most of you guys will tell me, sir, I want to reconstruct x of t. We will never be able to reconstruct x of t because we are losing out information. You are correct, but they are not reconstructing x of t, they are reconstructing y of t. So whatever is this y of t signal, that is what they are reconstructing. They don't care x of t. Okay, I don't know why, but they don't. Okay, let's move on to the next question. This is the next question, right? A signal x of t is this. Okay, cool. Is sampled at 200 hertz and then passed through an ideal low pass filter 100 hertz, the maximum frequency present in the filtered signal. So let's say I have this signal, right? Cos of 180 pi t. Okay, so cos pi t, you know, you will get two impulses. For omega, the frequency spectrum would be at 180 pi and at minus 180 pi. Okay, you are getting two impulses. Don't care about the magnitude for now. Now what you are doing, you are multiplying by cos pi t. If you are multiplying by cos pi t, what you are doing, you are essentially shifting the whole frequency spectrum left hand side by 65 and then again right hand side by 65. Got it? I hope you know this, right? And we have done this. So if I am multiplying by cos, we are shifting the whole frequency spectrum right hand side by 65. So this will be changed to, okay, this will be changed to 240 pi and this again will be shifted to the right hand side. If I shift it to the right hand side by 60 pi, this will be 120 pi, right? And the whole thing will be shifted to the left hand side by again 60 pi. So this will be 120 pi and this will be minus 240 pi, right? Got it? Now what they are telling me, it is sampled at 200 hertz. If it is sampled at 200 hertz, what is the omega s? Omega s is 400 pi, right? If it is 400 pi, again I don't care because like this thing will be copied again after 400 pi, right? So this whole thing, if I add this with 400 pi, okay, I do care, things will change, So what is happening? if I am sampling it at 400 pi, everything will be shifted on the right hand side by 400 pi, on the left hand side as well, right? So I hope you remember, right? This is my frequency spectrum. This thing will be copied, everything will be shifted right hand side by 400 pi, like fs, then 2fs, 3fs, it will be copied, right? At fs, at 2fs, at 3fs, also at minus fs, at minus 2fs. So everything will be copied. So this whole thing I can shift on the right hand side by fs, it will be copied. So if I shift the leftmost impulse by fs, what is omega s? Omega s is 400. So if I shift this by 400, what will happen? Minus 240 pi plus 400, right? Minus 240 pi plus 400. So this will be at 160 pi, somewhere here. Okay, although I don't care about this, but I might be caring about this, right? And this point, if I shift this by 400 pi, this will be 280 pi. 280 pi will be somewhere here. Okay, and this one, if I shift by 400, this will be 520 pi. I may not care about this. Why I may not care about this? Because they are saying me I am passing it through an ideal low pass filter whose cutoff frequency is 100 hertz. So in omega c, this will be 200 pi. So all I care about is the 200 pi components, just the components before the 200 pi. So the components before the 200 pi, what is the maximum frequency component that is present before 200 pi? That is 160 pi. It is not 120 pi. Many students will answer it to be 120 pi. Trust me. If they don't draw all this, they will answer 120 pi. Be very careful. Okay. So this 160 pi, they're asking me in hertz, right? So in hertz, what is the value? So 160 pi radian per second by 2 pi, this would be 80 hertz. So 80 hertz is the answer for this particular question. Many students will answer 60 hertz and they will be wrong, because they will assume that the maximum frequency of the signal before 200 hertz or 100 hertz or 200 pi is 120 pi. But they will miss out that due to sampling, due to aliasing, this component will come here. And why is this happening? Now you can see the live example of aliasing. Because what is the maximum frequency of your message signal? It is 120 hertz and you are sampling at 100 hertz. So certainly there will be aliasing, and there is aliasing. Aliasing is happening. You will not be able to properly reconstruct your signal. Got it? So this will be 80 hertz. That will be the answer. Let's solve this question. A continuous, okay, this is more on filters. Okay, we're done. We are almost done with samplers. Now we are coming to filters. Okay, so a continuous time filter with transfer function h of s is equals to this is converted to a discrete time filter with transfer function g of z equals to this, so that the impulse response of the continuous time filter, it is sampled at 2 hertz, is identical at the sampling instant to the impulse response of discrete time filter. What is the value of k? They are asking me the value of k basically. So do you know what the sampling means? So basically what I am doing, I am sampling my continuous time signal to make it discrete time, right? So how do you sample? So basically you change your nts to nts, right? That's what you do. So if you remember, I actually have discussed this previously as well, that your x of s is equals to minus infinity to plus infinity x of t e raised to power minus st dt, and your x of z is equals to n equals to minus infinity to plus infinity x of n z raised to the power of n. Correct. Now if I am sampling this, right, what essentially happens, this t gets converted into nts. This will be nts. So essentially what happens, your e raised to power minus s nts becomes same. So this particular thing, if I convert this into nts, right, this is same as the z transform. Okay, so these two things are equal. Basically this particular term and this particular term will be equal, z raised to the power of minus n. From this I get the value of z or I get the value of s. Okay. Hmm. Give me 1 second. Hmm. Get the value of z. So z is equals to e raised to power minus s ts. Sampling frequency is given to me. So your z will be e raised to power st. Uh, but we will not use this particular thing. What we will use is, so they are telling me that they are sampling my, so a continuous time filter is converted to a discrete time filter with transfer function this, so that the impulse response of the continuous time filter is sampled at 2 hertz. Okay. So what is the time domain expression? So let me compute the time domain expression for the filter. So it is 2s plus 6, 2s plus 6 upon s square plus 6s plus 8, 2s plus 6 upon s square plus 6s plus 8, right? So if I solve this, this will be 2s plus 6 upon s plus 4 into s plus 2. Okay. So now if I make this, if I make this equals to a by s plus 4 plus b by s plus 2, this will be equals to 2s plus 6 is equals to a into s plus 2 plus b into s plus 4. So basically your a plus b equals to 2 and your 2a plus 4b equals to 6. So if I multiply by 2 and then subtract, this will be 2b will be equals to 2 and b will be equals to 1. So b is equals to 1, right? And a is equals to 1. So b and a both are 1. So this will be actually 1 by s plus 4 plus 1 by s plus 2. So if I convert this into the time domain expression, this will be e raised to power minus 40 ut plus e raised to power minus 2t ut. Now we are sampling it, right? So basically our t is getting converted into nts. We're sampling it with a frequency of 2 hertz. So ts would be 1 by 2. So t will be converted to n by 2. Okay. Because we're sampling, right? We're simply sampling it, sampling the impulse response. So t will be converted into nts. So this will be e raised to power minus n by, so e raised to power minus 2n u of n by 2 plus e raised to power minus n u of n by 2. Now we know certain thing that u of n by 2 is same as u of n. Okay, there is no scaling happens, no scaling happens. So this is e raised to power minus 2 raised to the power of n, and your, this will be converted into u of n plus this will be e raised to power minus 1 raised to the power of n u of n, right? So yeah, okay. Okay, so this will be, this will be equals to, this will be equals to this, right? So now if I compute the z transform, I hope you know this is my a raised to power n, right? A is e raised to power minus 2, here a is e raised to power minus 1. I hope you remember what is the z transform of this. This will be e raised to power minus 2 into z plus 1 by z inverse, right? So this will be z inverse, and this will be 1 minus e raised to power minus 1 into z inverse. Okay, and of course you know the ROC. I will not explain you the ROC. So if I solve this, this will be 1 minus e raised to power minus z into z inverse plus 1 minus e raised to power minus 2 into z inverse divided by 2 into z inverse into, just give me a second now, because I have to check whether I'm recording or not. I have to check because this has been recording since quite a while. So into this, right? So before converting this, let me actually simplify this. I don't like z inverse, right? Let me simplify. This will be z, this will be z, this will be z. Okay, it will not let me do the z. So okay, what is happening, man? What is happening? क्या हो रहा है यार? क्या हो रहा है? Delete नहीं हो रहा. Z z. So now I think this will be better. So I can take z common. This will be z minus e raised to power minus z plus z minus e raised to power minus e raised to power 2. Z is common, and this will be 1 e raised to power. Okay, this also will become z minus e raised to power 2 into z minus e raised to power 1. So what I was referring to, I will explain that. Basically the pole locations will be same. I will explain what are the pole locations. So if you see, this will be basically 2z square, and what is e raised to power minus 1 and e raised to power minus 2? So e raised to power minus 1, right, plus e raised to power minus 2. So this is actually 0.5. So this will be minus 0.53z. If you see, something similar you are seeing here, right? This divided by, so you should be assured that whatever you are solving, that is correct. Z square minus e raised to power minus 2. So e raised to power minus 2, right? E raised to power minus 2. So e raised to power minus 2 would be, basically you have to multiply, so you have to again add this. So this will be minus 0.503z and plus e raised to power minus 3, actually e raised to power minus 3, that is actually equals to 0.04978. Okay, what have they asked? They have asked the value of k. K would be a very small number, 0.04978. Okay, that is the answer of k, right? Now why I was, so this is your answer, you got your answer. Why I was explaining you all this? Because I will use this. So what are the pole locations here? The pole locations here are at s equals to 2 and 4. So individual points will be mapped according to this relation. So what is the pole of the sampled function? It will be zp1 will be equals to e raised to power s p1 into ts. So here the, okay, sorry, it is minus 2 and minus 4, right? Minus 2 and minus 4. So what is your ts? Ts is 0.5, right? So the first pole would be e raised to power minus 2 into 0.5, that is 1 by 2, that is equals to e raised to power minus 1. Isn't this the pole here? Isn't this the pole here? What about the second pole? Second pole is at s equals to minus 4, e raised to power minus 4 into 1 by 2, that is equals to e raised to power minus 2. Isn't this the pole here? So technically you know the denominator, right? You know one pole is at e raised to power minus 2, one pole is at e raised to power minus 1. So if you multiply, if you know the poles in the denominator, you know the two poles, right? E raised to power minus 1, e raised to power minus 2, right? If you multiply these functions, right, so you will get your denominator, and you will verify that one term of the denominator, two terms of the denominator are matching. Certainly the third term also will match. So you can solve this question in a faster manner with this, okay, with this trick. But I will again say, if you are again scared that what if I'm making a mistake, just to be 100% sure, if you have enough time, solve with this long method, that is fine. Okay, but this is also another good trick that you should know. This is how the individual points from the S plane will be mapped in the Z plane. These are the individual point mapping. It is not the whole function, but the individual point mapping. Okay, so this is the solution of this question. Pretty good question. Okay, one more question from this uh, impulse response is given. So they're asking me what the filter can be used as a low pass filter, high pass filter, band pass filter. What can be the filter used for, right? So let's for us to know what kind of filter this is, we will now compute the impulse response, right? This is a discrete time, so we will calculate the Z transform of the impulse response, correct? So let's say if my input is impulse signal delta of n, so this would be 5 into delta of n, and there will be an unit delay and then again another unit delay. So here I will have delta of n minus 2, and this will be basically minus of 5 into delta of n minus 2. So your y of n would be equals to 5 into delta of n minus 5 into delta of n minus 2, right? Okay, so now this is the impulse response. This is my h of n. What is a Z transform of the impulse response? That would be 5 delta of n has a Z transform of 1 minus 5 Z raised to the power of minus 2. Okay, so this is the impulse response. So 1 minus Z raised to the power of minus 2. Now what we will do is we will write the DTFT of this. Okay, because we are talking about filters, we are talking about frequency response, we will directly compute the DTFT. If you directly want to compute the DTFT, you will replace, so your Z is actually equals to R raised to the power of j omega, right? So if you are computing the DTFT, you write your R as 1. So you replace your Z with e raised to the power of j omega for computing the DTFT. Okay, so you place this value to be 5 of 1 minus Z raised to the power of e raised to the power minus j 2 omega. Okay, now we have got the DTFT, right? Because we are talking about filters. Now what shall be the frequency range? If you remember one thing, if my signal is discrete and it is aperiodic, because x of n can be anything, they have not told me that it is aperiodic or aperiodic, and aperiodic. Okay, so in the frequency domain, the DTFT would be what? The DTFT, because it is discrete, it will be periodic, and because it is aperiodic, it will be continuous. So frequency domain would be continuous and it would be aperiodic. As you can see, it is continuous. Sorry, it is continuous and it is periodic. Periodic by what? It is periodic with period 2 pi. This will always be the case. So in discrete frequencies, discrete time Fourier transform, your minimum frequency would be omega equal to 0 and highest frequency will always be omega equals to pi, right? Basically we check from minus pi to plus pi. That is our range of frequencies in DTFT, because after that everything will just repeat. So pi, omega equals to pi is the highest band of frequency, omega equals to 0 is the lowest band of frequency. This thing you will have to remember. This is actually used and they can ask these kind of questions, so you will have to remember it. Okay, so in this case, what is the magnitude of the transfer function or the value of the transfer function at omega equal to 0? So h of omega equal to 0, that is simply equals to 0, right? If I put omega equal to 0, this will be 1 minus 1, that is 0, that is 0. And h of pi, if I put omega equals to pi, what is e raised to power minus j 2 pi? So e raised to power minus j 2 pi is essentially 1. So this is also actually equals to 0. So it feels like at high band of frequencies and lower band it is not passing, right? Magnitude is 0, like transfer function is 0. So somewhere in the middle is it passing? Let's see that. So let's check at middle, omega equals to pi by 2. at omega equals to pi by 2, this will be e raised to power minus j pi, and e raised to power minus j pi is minus 1. So this will be 1 minus of minus 1 into 5. So that is actually equals to 10. So 10 simply is your, so 10 it is passing, certainly it is passing the middle frequencies, it is not passing the lower band of frequencies, not passing the higher band of frequency. So certainly this will be a band pass filter. It will be a band pass filter. Let's solve this question. The system transfer function is this, right? If a1 b1 is 0, all other coefficients are positive. So a1 and b1 is 0. So basically your transfer function is this, a2 s square plus b2 s plus c2, right? So what kind of filter is this? Is this low pass filter, high pass filter, band pass filter, notch filter? What kind of filter is this, right? So notch filter is like this. Sorry, notch filter is like this, which is essentially a band stop filter. Notch, if you see your phone front camera, it is like a notch. So again, if you are doing the filter analysis, so you will replace your s with j omega. So this will be s1, this will be minus a2 omega square, s with j omega, this will be plus j omega into b2 plus c2, right? Now at omega equals to infinity, what is happening? The transfer function is 0, right? H of j omega is 0. At omega equals to 0, certainly at omega equals to 0, right, it is not 0, it is equals to c1 by c2. Certainly it is not 0, right? It is not passing higher band of frequencies, it is passing lower band of frequency. Certainly this will be a low pass filter. Okay, this acts as a low pass filter. So option A will be your correct answer for the question. And yes, we are finally done with signals. If you have enjoyed this whole revision video series, right, if you have enjoyed this whole revision video series, make sure to hit the like button, make sure to comment on below whatever you felt like, right? So because this was a huge effort from my end, I tried to solve with basics as much as possible, right? Of course I was using formulas, but I was deriving them as well. Okay, I tried that. Of course for few formulas I was directly writing them, because otherwise this session will go forever. So I tried my best, right, to give a good revision to you. Although I have not taught any concepts, I have taught concepts, right? I have taught bit of revisions, not comprehensively, but I have told you what videos you need to follow, right? And questions we have solved with basics. Okay, so yeah, make sure to hype the video, like the video, and I will see you in the next lecture. Until then, happy learning.